Good morning, everyone. I hope you all had a wonderful and insightful 2 days. It is my great pleasure to welcome this esteemed gathering of distinguished scientists, technocrats, and academicians to International Conference Ships and Offshore Structures 2024. Today, we all are set for another day filled with insightful discussions, innovative ideas, and groundbreaking research. Before commencing the program for the day 3, let us have a recap of last 2 days. The day before yesterday, we began with the inauguration, followed by the insightful keynote session and impactful presentations, where we explored the dynamic fields of ocean energies and innovative coastal structures. Yesterday, we began with some great presentations with respect to ships, followed by some informative keynote sessions. After that, we attended impactful presentation based on numerical modeling offshore structures and coastal structures. Let's begin with the third day of ICSOS 2024 conference. The first session of the day is based on offshore structures. Now we have Professor Deepak Kumar and Dr. Tejas Garla to join us for the chair for this session. Thank you.
Thank you. This is the first session of last day today, and we have total 5 papers, and all the papers are from Department of Ocean Engineering. So it's a internal review, it seems like. Okay. So first paper is experimental and numerical investigation of ultimate strength of ring stiffened tubular X joint under axial compression load. And I think presenter is Bharatraj. Or sir.
Okay. Good morning to all of you.
Professor Nalarasu is the presenter. Okay.
So good morning to all of you. This work on strength of tubular joints reinforced with internal ring stiffeners. We have been working on this for last 5-6 years. 2-3 PhD students graduated with empirical formula incorporated into API. So basically X joint was left out. They have done all other joints, and this particular one was taken up by this MTech student, Bharatraj. Now he is not able to come, also not able to participate in online because he is in offshore, Abu Dhabi. So what I told him, he has to present. So what he did, he has recorded voices behind the slides. So we will run through this. In case if there are any questions, I can answer. So I will be down there and we'll run through. I hope it is within 20 minutes.
Yeah, that's fine, sir.
Right?
Yeah, that's fine, sir. If you are here to answer, then
yeah,
it's fine.
So I wanted the student to present, but then unfortunately, he could not even join online because the internet is very bad in the offshore country. So that's why. Thank you. So let us
video is there? How you going to play? Just play it.
Bharatraj. So I'm a former student of IIT Madras. So I graduated this year. Right now I'm an offshore, so I don't want to miss this conference, and I'm making this recorded voice presentation. So my paper is about study of ultimate strength of ring stiffened tubular X joint under axial compression. So I'm the author of this paper, and my co-author is Professor Nalarasu, head of the Department of Ocean Engineering at IIT Madras. Let me give you a quick intro about jacket structures. We all know that the jacket structures are economical in shallow water depth, typically when it is less than 200 meters to support oil and gas installations. And it is continued to be used considerably worldwide due to its simplicity in design, fabrication, and installation. The reason to use circular hollow sections in jackets is due to its inherent characteristics such as low hydrodynamic effects, strong local strength due to circular geometry, and high torsional strength overcoming the disadvantages of fabrication. A joint and a frame structure is an assembly of more than 2 members connected at a common point. The member delivering the force is called as brace, and the member which receives the load from the brace is called a cord. The objective of the study is to determine the ultimate strength of ring-stiff and tubular X joint under axial compression, and the results are to be compared experimentally and numerically. The scope of this study is to mainly investigate the ultimate strength of ring-stiff and tubular X joints under axial compression using experiments and numerical models. The second is numerical simulations using Abacus software, establishing a load displacement characteristics for these joints in practical engineering applications, and measure the failure loads of both stiffened and unstiffened tubular X joints with internal ring stiffness. What I have actually did is I have fabricated a couple of X joints using a steel material. So one is unstiffened X joint and the other one is stiffened X joint, which is stiffened by internal ring stiffness. So first, a coupon test, that is tension test, is conducted to find out the material properties, and then compression test is being conducted on both the models, that is unstiffened and a stiffened X joint, and the ultimate strength is being arrived through the results, experimental results. And on the other hand, X joint is being modeled in a software called Abacus. So using the results of the tension test, the material properties is being added to the data, and then meshing is done, and then the load is applied, and then the ultimate strength is being arrived using Abacus software and is being compared with the experimental results. Let's first look at the experimental study in detail. Typical member sizes for frame structures like jacket or any other template may vary from 500 mm to 2000 mm, and the same is used for the design of scale model for experimental investigation. The scale selected for the experimental setup is 1:8, using a cord diameter of 219 mm, the brace diameter of 114 mm. In order to investigate the local failure of cord rather than the global beam bending, suitable cord length parameter shall be selected. A cord length parameter of 6 was chosen to capture the local failure of the joint. Selection of suitable dimensions of internal ring stiffener and its thickness plays a major role in constructability and efficiency of the stiffened joints. The depth of stiffener could be based on the limiting slenderness, but it can be limited to provide access for welding from both the sides, especially for thickness larger than 25 mm, which may require double groove welds. It's recommended that the ratio of stiffener web depth to cord diameter should be around the range of 0.1 to 0.2. Similarly, it is recommended that the ratio of stiffener web thickness to cord thickness should be in the range of 0.5 to 0.8. It should be noted that the thickness of the ring stiffener shall be compact in sections to avoid any local buckling. Hence, the dimension of the ring stiffener depth is chosen based on the section classification as per ICSOS 360-2016 in the table B4.1 for compact selection criteria. Dimensions for the unstiffened X joint and the ring stiffened X joint. The outer diameter of the cord is 219 mm. The outer diameter of the brace is 114 mm. The thickness of the cord is 8 mm. The thickness of the brace is 5.5 mm. The length of the cord is 800 mm. The length of the brace is 1000 mm. The depth of plain ring stiffener is 50 mm. The thickness of the plain ring stiffener is 6 mm. Two joints is being fabricated using steel material of grade API 5X42 and X52 for brace and cord respectively. One is stiffened X joint, where the plain ring stiffener is provided, and the other one is unstiffened X joint. The coupon test is to be conducted. That is nothing but the tension test to find out the material properties. So let us have a brief look into that. 3 coupon specimens were taken from each tube, that is cord, brace, and plate used for ring stiffener. The coupon tests were performed on specimens selected from the material in the MTS tension testing machine, which had a displacement control mechanism with a testing capacity of 1000 kN. 2 strain gauges with gauge length of 5 mm, gauge resistance of 120 plus or minus 0.3 ohms, and gauge factor of 2.11 plus or minus 1% were pasted on each specimen. In addition to the strain gauges, an extensometer of gauge length 50 mm was also used to measure the elongation. Readings from strain gauges are considered for analysis since the measurement using strain gauges are accurate than the extensometer. At higher strain, the strain gauge readings may not be accurate as they tend to peel off. In such cases, the extensometer readings were used to check the accuracy. Using the data of load and elongation obtained from the experiment, we can first find out the stress and strain. As we all know, stress is nothing but load by area, strain is nothing but the extension by the original length. Then using the Excel sheet, we will find the 0.2% strain, which is calculated by adding strain plus 0.002. 0.2% stress is calculated by multiplying the Young's modulus with the 0.2% strain. Then we will plot the graph of 0.2% strain and 0.2% stress. It would be a straight line and would intersect a point in the stress strain graph, and thus it gives us the yield stress. As we all saw in the last slide, the blue one is the stress strain curve, and the red one is 0.2% offset stress strain curve, which is a straight line, and the point of intersection is what gives us the yield stress. The maximum stress in the stress strain curve is taken as the ultimate stress. The Young's modulus has been calculated using the stress strain data, which is nothing but the stress strain. And the Poisson's ratio is calculated by the formula that is nothing but lateral strain by the longitudinal strain. And we hereby obtain the material properties as given in the table below. As the tension test is completed, and now let's move on to the compression test. It is done mainly to find the ultimate capacity of the stiffened and unstiffened joints using an axial compression test, which is to be carried out in a MTS compression testing machine with a capacity of 1000 kN. Using a hydraulic jack, the axial compression load was supplied to the bracing. An integrated load cell accessed the applied load, while an internal transducer measured the displacement. The displacement transducer with a measurement accuracy of 0.001 mm, and the load cell has a granularity of 0.001 kN. The ovalization of the card in addition to the built-in displacement measurement. One LVDT is placed at the sideways of the card surface, and the other LVDT is placed at the bottom surface of the card. The displacement controlling mechanism was used to increase the load during the experiments, and a displacement rate of 0.05 mm per second was used. We would receive the load details and displacement details from the load cell of the MTS compression testing machine. And in that, the first peak that is obtained in the load displacement graph is the ultimate capacity of the joint. These are the images of the unstiffened tubular X joint after the compression load test. The details obtained from the load cell of the MTS compression testing machine. A load displacement graph is plotted, and the first peak is taken as the ultimate capacity, as we saw in the previous slides. So according to that, the ultimate capacity of the unstiffened X joint obtained through experiment is about 262.73 kN. These are the images of the stiffened X joint after failure of compression test. Following the same procedure, the ultimate capacity of stiffened X joint obtained through the experiments is about 422.08 kN. Now let's jump on to the numerical model. These models are made in Abacus software. Here the brace is made of 114 mm outer diameter and the thickness of 5.5 mm is given. It is as per the same which is done in the experiments. The cord is made of outer diameter of 219 mm and the thickness of 8 mm is given. Now the brace and the cord has been intersected exactly at the middle. The highlighted part is to be extruded in order to get a typical X joint. This is how the unstiffened X joint is being made in the Abacus software. Adding on to it, ring stiffener is designed separately of outer diameter 203.1 mm and a thickness and depth of about 6 mm and 50 mm respectively. The ring stiffeners are placed at the brace cord intersections on both the sides. This is how the final output will be after placing the plain ring stiffeners. The internal ring stiffeners is considered the best suitable method at design stage because of less possibility of corrosion, less wind and wave loads, less stress concentration factor at the brace cord intersection. General purpose first order interpolation of 8-noded brick element with reduced integration technique is to be used for the present study. The reduced integration technique uses only one Gaussian intersection point at the center of the element, thus reducing the computational time. The concentric axial load will be applied at the top of the brace using displacement control method, and failure load is obtained. Because the solution is approximate, the mesh size, pattern, and type used will affect the FE simulation results. As a result, the only way to find an appropriate mesh size is iteratively through simulation at different mesh sizes. Even if the smallest mesh size is preferable, it is customary to calculate the ideal mesh size because it requires a lot of computational time and work. In order to ascertain how much the outcomes depend on the element size, the mesh sensitivities research for the current problem was conducted by changing the element size. In terms of the entire number of finite elements, the mesh density is expressed. The coarser mesh is utilized in the remaining portion of the joint, while the finer mesh is employed at the area of brace cord junction to capture the stress concentration around the connection. Various mesh sizes were being used for simulation in an iterative way and have calculated the ultimate capacity using those, in which mesh size of 2 mm is chosen for the finer mesh areas, as the percentage of error which is obtained from 2 mm mesh size is much lesser than the other fine mesh sizes. And for coarser mesh, size of 20 mm was adopted in all other parts than the intersections. Material properties such as yield stress, ultimate stress, Young's modulus, Poisson's ratio, which was obtained from stress strain curve of Coupon test, is added to model properties in Abacus. The support is given in a way where the bottom of the brace is fixed and the ends of the curves are vertically restrained and the load is applied from the top of the brace. The incrementations and displacement rates are set. The load that's involved here is static. Then the job analysis is submitted for solution. Abacus will solve the finite element model based on the specified boundary conditions and material properties. Once the analysis is complete, we have to navigate to the visualization model in Abacus and display the von Mises stress contours by selecting stress from the available output variables and choosing equivalent von Mises stress as the stress component to visualize. We have to adjust the display options as needed to view the stress contours effectively. Example, contour levels can be adjusted, color map, legend, etc. This is how the stress contour is obtained. Using this, it can be seen that where the stress concentration is higher and where the failure would occur. And this is the stress contour of the unstiffened X joint. And this is the obtained stress contour of the stiffened X joint. Again, let's navigate back to the visualization module in Abacus to plot the load displacement curve by selecting appropriate output variables. In this case, reaction force and displacement at the loading point is taken. Extract the reaction forces and displacement data at the loading point using the XY data tool in Abacus and export the reaction force and displacement data to a text file or a CSV format for further analysis or plotting in external software such as MATLAB, Python, or Excel. The exported data is analyzed to obtain displacement graph. The reaction force is taken on the y-axis and the displacement is taken in the x-axis to visualize the relationship between load and displacement for the X joint under compression. As per that, the ultimate capacity of the unstiffened X joint obtained numerically is about 270.02 kN. And the ultimate capacity of the unstiffened X joint obtained numerically is about 441.43 kN. Now we have got all the results and it's time for validation. The ultimate capacity of the stiffened joint and unstiffened joint obtained through experiments and numerical simulation is compared with each other. Since the percentage of difference between the results obtained from the experiments and the numerical simulation is very less, it thus proves that the results are fine. Even if the first portion within the load displacement relationship shows a mismatch between the simulated and measured capacities, the same corresponds quite well close to the failure load. The maximum percentage of difference doesn't exist, 3%, which indicates that the numerical simulation gives us the appropriate results and thus we can rely on it. Here is the comparative graph of unstiffened X joint obtained through numerical and experimental methods. The difference between the results obtained from the experiments and numerical simulation for unstiffened joint is about 2.7%. This is the comparative graph of ultimate capacity when internal ring stiffener is placed, that is when the X joint is stiffened, both numerically and experimentally. The difference between the results is about 2.1%. So thus, when comparing the plain ring stiffness to unstiffened X joints, the ultimate capacity has increased about 64%. The numerical model is suitable for parametric research since the final capacity of the stiffened and unstiffened joint obtained from numerical simulation and experiments varies only up to a maximum of 3%. These are my references. Thank you all. Have a nice day.
This is only a small part of that X joint. One student has worked, so it's a lot more parametric study has to be carried out before we come with the equations for use in alignment with API and stiffened joint. So any questions I could answer, because this MTech student is in offshore, he is not able to come. From chairman, co-chairman.
The whole idea of investigating the ultimate strength is to derive a new design philosophy. What is the status of that? Have they come up with any code which basically derives the new design approach based on ultimate strength?
See, for unstiffened joint already the equations are available from API or Eurocodes. For stiffened joints, they are not incorporating any of the parameters involving the stiffening effect, leaving it to industry to fish out whatever the method is right. So last, I think almost 10 years I am working on it. Now we come up with one parametric equation where one factor can be multiplied as a cumulative effect of stiffening based on the ultimate strength and factor safety. So all the joints are completed. Some, I think, as I mentioned earlier, 3-4 PhDs, MS have been graduated, and the equations are ready and published in various journal papers. Only the X joint was not possible at that time. I was looking for students, so fortunately this MTech student came and he did a good work within a short period of time. With hand, some accident also was there. So he was able to do this, and then only thing is he did limited number of tests. See, all this strength test for tubular joints, all are parametric based on experiments only. So analytical formulation is not possible. So experiments plus large set of numerical simulation using any one of the software to get the parameters tested for various geometries. Then you can do a curve fit, how the behavior of strength versus parameter 1, 2, 3, 4. So that's how all the API equations are set, but this is a very small piece of work what he has done. So a lot more to be done. For this X joint, TY joints already been completed and published in journals, which we call it QR, which is a factor to account for ring. So there are 3 factors in the API equation, which he did not put it here: QR, QF, and QG. And basically geometry and load effect. Then the last factor is the ring factor.
Extensively used in jackets, for example. There are a lot of experiments.
No, the main problem is stiffening. Every project will have stiffening because many times we end up with design changes at the last minute. So material cannot change, then the only way is to go and put reinforcement inside. So this is something useful one. Thank you. Yes.
Yeah. Sir, this is a experimental, mainly experiment is the important part of this. The experiment, what it was showing, it's a scaled one or?
Scaled.
It's a scaled one.
So it's 1:8 scale. Typically the dimensions of jackets, in shallow water depth may vary from 500, 600 to 2000. So we selected a typical jacket. 1:8 is the scale.
Okay.
Basically the 200 mm core diameter is 1:8.
So main purpose was to understand the behavior of the joint, that how this one is behaving, because end condition is also important in that case.
Yes.
So when scaling, how you consider the end condition?
So I think he has tried to explain. In
He missed it.
tubular joint modeling, there are 2 factors to be considered. One is geometric QF factor, which is including the length of the cord and end fixity at the other support joints. If you look at a jacket, you will have another joint and another joint. But at the location of joint, the local flexibility only investigated here. The QF parameter will be taken from API, which will depend on the cord length, which is the point of contraflexure between the bending of the first member to the next member. So that factor is not coming here. This is only a local interface stiffening between ring, card, and brace.
Okay.
So that's how the whole three equations are set.
And thank you, sir. The limited time is there, so if someone wants to ask the question, they can ask separately from sir. Okay. Thank you, sir.
Thank you.
Okay, so our next presentation is on experimental and numerical investigation of bearing capacity of jacket mud mat with central opening in the soft clay. The presenting author is Ms. Kantri Konda Bopana. Thank you, Professor, to allow, because I have to go for.
Good morning, everyone. Thank you for
Go to mic.
to navigate here only. Remote.
Stay near to the mic.
Good morning, everyone. Thank you for the opportunity to present at the 9th International Conference on Ships and Offshore Structures. I am Kranti Konda Boppana, and I have recently completed my Master's from the Department of Ocean Engineering, IIT Madras. And I would also like to acknowledge my research advisor, Professor S. Nallairasu, for his guidance on this project. Today I will be presenting my research on experimental and numerical investigation of bearing capacity of jacket mud mat with central opening in soft clay. Here is the presentation outline. Firstly, I'll begin with introduction to mud mat and its importance in offshore structures, and I will explain objective and scope. Then I'll walk you through the methodology, which includes experimental and numerical investigations, and I'll discuss the key results and concluded with the major findings of this study. Let me give brief introduction to mud mats. Mud mats are the temporary seafloor support for the jacket structure immediately after being appended from the horizontal floating position prior to supported by piles. These mud mats should be designed with sufficient bearing area and strength to avoid excessive settlements of the jacket. Recently, mud mats with central openings have been introduced to improve installation and removal efficiencies. However, there is a limited literature on the bearing capacity of the mud mat with central opening. Existing studies primarily focuses on the on-bottom stability and combined bearing capacity. This gap in literature motivated our study to conduct experimental and numerical investigations. The main objective of this study is to investigate the bearing capacity of jacket mud mat with and without central opening by numerical and experimental investigations. The scope of the study is to perform experiments for mud mats with and without central opening, to perform numerical investigation using Plaxis 3D, to compare the results from both the analysis and validated numerical analysis with the experimental analysis. Methodology includes two main aspects. One is numerical investigation, one is experimental investigation. I have used Plaxis 3D software to simulate the mud mats with and without central opening, and I have conducted physical experiments on the scaled models of mud mats, and then I compared and validated the numerical analysis with the experimental analysis. I have used fine China kaolinite clay for conducting experiments, and existing studies also have used this for conducting similar kind of study. And I have determined the kaolinite China clay properties at the Department of Civil Engineering, IIT Madras. The liquid limit was determined by Cassegrain aperatures, which was 31.67%, and plastic limit was 20.68%, and specific gravity was determined by density bottle method, which was 2.74, and the variation of shear strength with water content was determined by vane shear apertures. The results are depicted here. And I have used for model I have used two main configurations. First one is solid mud mat model with 10 centimeter by 10 centimeter size, and a second one is mud mat with a central opening of size 5 centimeter by 5 centimeter. These mud mats are scaled down based on the geometric scale of 1:200 to simulate the real life scenario of mud mat having size of 20 meter by 20 meter. I have used test loading device, MTS compression test loading device at MPCM lab at IIT Madras, having a maximum load capacity of 1000 kilonewton with a resolution of load cell having 0.001 kilonewton, and that of displacement transducer is 0.001 mm. The loading rate, I have applied the load at the rate of 1 mm per second. Here is the schematic of experimental setup. I have conducted saturated undrained test on the clay. The load was applied on the top of the mud mat while measuring the displacement to derive the load settlement relationship. I have adopted the physical properties of China clay and properties of mud mat plate, same as the properties which I have simulated in the experimental setup. The soil was modeled as soft clay with undrained sea condition, and unit weight 16 kilonewton per meter cube, and Poisson ratio 0.499, and dilatancy angle and the angle of internal friction is 0, and groundwater level is global, and the shear strength parameter is 7 kilopascal. And mud mat plate is modeled as steel plate, elastic steel plate with the Poisson ratio 0.25 and Young's modulus 210 into 10 power 6 kilopascal, and unit weight modeled as 0, and plate thickness is 0.1. Here is the finite element model of the numerical simulation in Plaxis 3D. I have considered the boundary as 5 times of the size of the mud mat to eliminate the boundary effects on the stress paths and displacement contours. Here is the comparison plots. First one is comparison plot for both the mud mats, and second one is comparison plot for both the mud mats, numerical and experimental results. Mud mat 1 refers to mud mat without central opening. Mud mat 2 refers to mud mat with central opening. The load corresponding to the settlement of 10% of size of the mud mat was taken as the bearing capacity. The size of the mud mat model was 10 centimeter, and the 10% of the size is 10 mm, and the load corresponding to 10 mm settlement was taken as the ultimate load, and then ultimate bearing capacity was determined by dividing the ultimate load with the size of the footing, area of the footing. And here in plots we can clearly see the mud mat 1, which is without central opening, is having higher ultimate load than the mud mat 2, which is with the central opening. This table shows the validation of the numerical and experimental results. For a solid mud mat, there is a discrepancy of 1.25% between the numerical and experimental results. And for mud mat with central opening, there is a discrepancy of 2.22% between experimental and numerical analysis. And the bearing capacity of solid mud mat was 48.25 kilopascal, and mud mat with central opening is 41.98%. And here we can clearly see that mud mat with central opening is having lower bearing capacity than solid mud mat in both the experimental and numerical investigation. The major conclusions of this study is is that bearing capacity of the mud mat with central opening is having lower bearing capacity than the mud mat without central opening. And specifically for an opening of 25%, there is a notable decrease of 13% in bearing capacity compared to solid mud mat. Here are the references, and I would like to thank my research advisor, Professor S. Nallayarasu, for his guidance, and Renuka Devi, research scholar, for her support, and friends for their support and motivation. Thank you for all for your attention. I am open for questions you may have.
Any questions from the audience? Yes, Garala, please.
Yeah, good work, Kranti. Usually the experiments are very difficult, especially with clay.
Yes, sir.
How did you prepare the clay specimen? I see a
Yes, sir.
large tank. How did you prepare the clay specimen there?
Yes, sir. From the variation of shear strength plot,
Yeah, I mean, physically, how did you model it? Just
yes, sir.
compaction or
yes, sir.
consolidation?
Compaction. Each layer of size 10 centimeter. The model was tank size was 50 centimeter by 50 centimeter by 60 centimeter. I have filled the clay up to 50 centimeter height, and I have prepared clay each layers 10 centimeter 10 centimeter, prepared separately within a controllable environment, and I have filled and compacted each layer.
So this 7 kPa is before the compaction. Then.
Yes, I tried to simulate 5 kilopascal. Then after preparation, I have tested. The results shown 7 kilopascal. The moisture content have reduced, changed. Sir.
Usually, you expect minimum coercive strength for kaolin will be around 3 kPa, 4 kPa.
Yes, sir.
Even at its liquid limit.
Yes, sir.
So probably with the moisture content, you might get 7 kPa. But once you compact it, might be have slightly more strength than the 7 kPa. But yeah, that's something you can look for. Have you try to look in simple analytical calculation? You know the bearing capacity, you know the undrained shear
Yes, sir.
strength, you know the footing size.
Yes, sir.
We got now an opening. Have you
Yes,
done
sir.
any of that comparison?
I have done and compared, but it's not in the scope, so I didn't add it here.
Excellent. Okay, yeah.
It was matching, sir. Sir, yes, sir.
Yeah, good one. Yeah.
I am working as engineer at Eka Solutions, Mumbai, sir. Yes, sir.
Great work. Can you guess what's the source of the noise on your experimental data, and have you considered putting a filter on it, like a high pass, low pass filter, or a moving average?
Sorry, I didn't get.
Could you, yeah, the simulation result and experimental result. Here.
Yes, sir.
So on the left side, you see your experimental data,
Yes.
and there's clearly some noise on it. So, can you guess what's the source of that noise, and have you considered filtering the noise?
I didn't understand.
So what she is asking, what he is asking
Yes,
is
sir.
that in the first graph,
Yes, sir.
when you are plotting the results,
Yes,
you are
sir.
plotting them in a band.
Yes, sir.
And the band means that there is a lower limit, there is the upper limit.
Yes, sir.
And he is asking that means there is a noise coming into the results.
Yes, sir.
You are not getting a value which is fixed. For example, the next curve is you are getting only one value.
Yes,
You are
sir.
not plotting the band.
Yes, sir.
That means you are not plotting the limits. Experimental results will always have some band. That means upper band and lower band. You
Yes,
are
sir.
plotting between that band and you are plotting the average value most of the time. So what the expert is asking is that what is the source of these noise which have entered your results?
Yeah, from literature, I have researchers have considered ultimate load at the 10% of the. Sir, sir. Yes, sir. Okay, okay, sir. Okay, sir. So I have in experiments I have recorded the data with requisition frequency of 10 Hz. So for every 0.1 second, the data was recorded. So lot of data have been recorded. So it is coming like that.
There is some problem in the recording data acquisition.
Data acquisition
Or your frequency is too small.
frequency is too so 10 hertz.
You saw earlier one, our Bharat,
Yes,
his measurement was very clear.
yes.
Thank you.
Thank you.
Any further question? No. Then I have one question.
Yes, sir.
On the same slide,
Yes, sir.
how is a numerical result and experimental result, how you are comparing?
Sir, numeric here I plotted load versus settlement relationship, sir.
Okay.
I have compared bearing capacity. Prototype is in numerical simulation. I have simulated prototype of size 20 meter by 20 meter.
Okay, it's a scaled
And
one.
Yes,
Okay,
sir.
yeah,
Model it's scaled one. So,
Yeah,
low-
you should
yes,
explain that.
Yes, sir.
Otherwise, everyone will get confused. Okay, thank you.
Also, one last, just don't put so many decimal, now we are working in industry.
Okay, sir.
One decimal, you know.
Okay.
Yeah, any further question? Then we will say thank you. So time is limited. Okay.
Thank you, sir.
Presentation. So next, yeah, done.
Thank you, sir. Thank you, everyone.
Thank you, Kranti.
Thank you, sir.
Now we have the next presentation. Analysis of offshore topside under hydrocarbon fire. Presenter is Ms. Pradeepa M.
Happy morning, everyone. It's a pleasure to have you here. I'm Pradeepa, a PhD scholar from IIT Madras, and alongside me is my esteemed co-author, Professor S. Chandrasekharan from Department of Ocean Engineering. In the next 15 minutes, I will walk you through the key aspects of my study and the significant findings that contribute to our understanding of analysis of offshore topside under hydrocarbon fire. Let's understand a little bit about hydrocarbon fire. As the name suggests, it is the combination of hydrogen and carbon, and these reactions have rapid ignition, high heat release rates, release of dense smoke, and toxic gases. And hydrocarbon fire causes risk to personnel on board and structural damage, operational downtime, and environmental impact. Figure 1 and 2 shows the significant fire accidents happened in offshore industry in the past. According to literature, hydrocarbon fire and explosion can cause more than 70% of accidents happening on offshore installations. Hence, it is very important to assess the hydrocarbon fire load and the structural response for offshore topside. To assess the fire load, a sequentially coupled thermal structural analysis methodology has been proposed here. The first step is preliminary analysis of the chosen platform. Then the selection of fire scenario. Next, the fire simulation to get the time temperature curves as output. Together, this step is called fire simulation step. Subsequently, heat transfer and stress deformation analysis has been carried out using finite element analysis. Together, this is called structural response. Now let's see all these steps in detail. This figure shows a graphical representation of the sequential thermal and structural analysis. So here, from the fire source, the heat has been transferred through radiation, convection, and conduction. This has been modeled using FDS, Fire Dynamic Simulator, a CFD tool, and thereby the output of nodal temperatures. Then the model is taken into finite element software, which is Abacus, to apply the time temperature curve as an input and get the structural responses, which are depending on the characteristic material properties which are mentioned here, which are also a function of temperature. So considering all these change in material properties with respect to temperature, the first step preliminary analysis has been carried out. Here are the governing equations which are used at different steps during the sequentially coupled thermal and structural analysis. This is Petronius platform located in Central Gulf of Mexico. This has been chosen as an example platform for the preliminary analysis. Here, the wireframe model shows the trial sections which are assumed based on the past literature, and the material has been chosen as X52 marine steel. Figure 5 shows the deformed members under the critical load combination, and the loads considered are dead load, live load, wind load, and nonlinear combinations of all of this according to API RP2A and Eurocode 1993. And figure 6 confirms that the design check has verified that all the structural members assumed can withstand the external applied load before any accidental load has been assumed. After the preliminary analysis, a vulnerable region in the platform has been chosen for fire scenario at the place where the condensate injection pumps has been located. The simulation area has been shown in figure 8. So this is the vulnerable region in plan, and this figure is a blowout of the simulation volume. And this volume has been extended to all the sides to capture the effect of wind turbulence acting on the top side. The mesh boundary is open along all the 4 sides to allow the wind turbulence. So thereby we are simulating a real-time offshore platform. Further, we will see how the fuel is introduced into the simulation. So here are some of the basic equations of combustion reaction of hydrocarbon fire. Now I have taken an example of methane fire. Figure 9A, B, and 10A shows the different mesh size results at time second 1200 seconds. Why we are looking at 1200 seconds is that is the time when the simulation has reached the maximum temperature it can attain. And further refinement beyond the mesh size of 0.25 meter has not been improving the accuracy of results. Hence, the mesh size has been decided as 0.25 meter. And the simulation has been further extended to 2400 seconds, considering the emergency response time guidelines given by API RP. And let's see some more results from the fire simulation. Figure 11 shows a temperature slice above the fire source at around 11 meter height. And you can see here also the intensity of temperature is very high, around 1000 degrees. And this section, the members, are more likely to be fail faster. And figure 12 is the isosurface plots showing 400 degrees Celsius, which is this light blue color, at 1200 seconds. So why we are focusing on 400 degrees Celsius is the steel degradation starts at 400 degrees Celsius. And you can see an example slice of 3D temperature growth. Now let's compare the real fire which has been reported from the simulation to the standard fire curves available in code provisions. So here the red line shows ISO fire curve, and green one is Eurocode fire, and the blue line is the real fire which is taken from the simulation. So Eurocode has been suggested for a conventional analysis of hydrocarbon fire load, but we can clearly see that it underestimates the temperature. And both the fire curves, standard fire curves, are not considering the attenuation effect in the design. Now, we have realized that the fire load has to be characterized based on real fire curve and not a standard fire curve. Let's see the subsequent steps. In order to account for the material properties, these inputs are necessary in sequential thermal and structural analysis, and I have listed all of them here. So you can clearly see density, specific heat, thermal conductivity, and surface heat transfer coefficient. And for the structural response, density, Young's modulus, initial yield stress, Poisson's ratio, and coefficient of thermal expansion. So in most of the standard conventional design procedure, Poisson's ratio and coefficient of thermal expansion has taken as a constant, but it is not so, and it has been proved in the literature. Further, the simulation has been extended to heat transfer analysis to account for the nodal temperatures which we got from the fire simulation. So this is the development of boundary condition and the governing equation of motion. To account for the attenuation effect of fire, different time temperature curves at different locations, critical nodes, has been considered from the output of FDS into the input of heat transfer analysis. So here you can see bottom plate, column middle node, and beam flange. Considering the change in material properties to temperature, the heat transfer analysis has been done with the effects of convection, conduction, and radiation. And you can see here the maximum temperature has reached 1459 degrees Celsius, which confirms that whatever the input we gave from FDS into Abacus has been applied successfully. Using the same 3D model with a compatible mesh size, a solid element has been used to model the structural response. Here it is very important to understand how the load has been applied along with the external load and the temperature load. So in this load step definition, I have defined two different steps. The first step has been a ramped mechanical load. So at the end of first step, whatever the external load has been acting on the platform has reached its maximum magnitude. And at that time, the temperature has been started to apply. So when the fire happens, the platform has been already loaded with the maximum load case scenario. That is the simulation step definition here. So the results have been compared with when there is no fire loading and with the hydrocarbon fire input. So here we can see the stress contour, and the maximum stress value is around 98 megapascals. And here the maximum stress concentration is around this joint, and which is around 222 megapascal. From X52 steel data, we can say that this has not crossed the yield limit. And looking at the deformation curves, we can see as the time progresses at around 1800 seconds, the maximum deformation has been observed in the center of the deck plate top. But at around the end of the simulation, 2400 seconds, the maximum deformation has been shifted from center to beam column joint, which shows a maximum deformation of 0.49 meters. So you can clearly see at 1800 degrees Celsius, this is the maximum temperature at any given node, and at 2400 seconds. So even though the temperature has been same, but due to the reduction factor, the deformation has been shifted from center to the beam column joint. So the key findings are: hydrocarbon fire poses a significant threat to offshore due to its intense heat. So we need to do accurate fire simulation using real-time TT curves. Designing fire resistance based on the standard fire curves can lead to underestimation of fire risk in offshore structures. So we are in need of specialized fire simulations such as this sequential thermal and structural analysis to effectively design the fire impact on offshore platforms. I appreciate your presence and attention. Now I look forward to hear your comments and questions.
Any questions from the audience?
Please go to slide number 13. Now you have been saying in this slide that there is conduction, radiation, and convection.
Yes.
Can you explain where is conduction, where is convection, where is radiation?
Actually, the fuel source has been introduced here. So from here, through the medium, the convection is happening. And
What is the medium?
air, sir. So through the material, conduction is happening. And radiation through exposed and non-exposed, both the coefficients has been taken care by the simulation. As an input we have given.
Okay, fine.
Anything else? Any other question?
This analysis have been taken care by like prototype size or what is the model size in Abacus?
This is a real size.
Real size.
Real size platform.
So what is your simulation time or how much
Real time or simulation time?
simulation time?
Simulation time is 2400 seconds.
No. How much time it will take to run complete full set of
It's almost like 14 hours.
14 hours?
Yes.
Okay, in the back, yes.
Thank you for this presentation. I just want to like which type of element did you use for your model?
It's actually there are two different elements. So first for heat transfer, I used DC3D8, linear 8-noded brick element.
Okay.
And for structural response, I used C3D8R. That's also 8-noded with reduced integration.
So like you are saying you are using solid element only.
Yes, solid elements.
Then why not cell element? Because like if you are using solid element, then the simulation time will increase.
Yeah.
So why do you not go for cell element? Any specific reason for that one, choosing only for solid?
No. We have tried with shell and solid elements. This separate sequentially coupled thermal analysis is not particularly working with surface elements. So we opted for solid elements.
To capture conduction, you have to have a solid element here. You cannot work on surface elements.
Any further question? Okay, I have, one is there.
Thank you for the presentation. It was a great presentation.
Thank you.
I have one question. Can you move to the last slide where you showed the deformation shifting from the center to the beam column joint?
Yeah.
Yeah. So can you just explain, like, give me a clarity why the deformation is from 2400 second, like from the starting initial 1800 to 2400 second, it's only moving to a particular beam column joint.
So you mean to say why it is not happening here at
And,
the 2400 seconds, why it has shifted to here after
a certain particular
So
beam column
you
joint.
can see so here the input parameters considered are like Poisson's ratio and coefficient of thermal expansion also varies with time and temperature. So there are two different variables. As the time increases, the temperature also increases. With the increase in temperature, the expansion of the material, steel, is being more for the same applied load. So from at 1800 seconds, the temperature was different, like here.
See, that
It's
is
around
one-
1000.
Yeah, that's one component. Other component is the shell element or the deck element is only under pure deflection, whereas the beam column is under biaxial bending. That's more critical because already the plastic hinges have started forming there.
Yes, sir. Yes, sir.
Though the stress value is less than the yield value, because of the degradation, the yield value is no more 230. It's gone to very low level. So already there is a hinge formation under biaxial bending. Naturally, that becomes a critical node automatically.
Thank you, sir. Thank you.
Okay, I have one
Yes.
question. So this is the finally the simplified model what you consider, is
Yes.
not it?
Yes.
And had you considered changing the position of the fire also, or right now you have only
Yes,
one
sir.
position?
For this scope, it is not been included, but
You will do
in
it.
parametric,
Yeah.
we have included it.
First, I should say that your presentation was very nice,
Thank you, sir.
and topic is also interesting.
Thank you, sir.
And are you also going to consider progressive collapse of the structure in future?
Actually,
Means,
progressive collapse.
Means because of the heat, some member will get damaged, and then further another damage. So how the damage is happening?
That's been considered in parametric studies, sir, like
So
in
you are going
future
to
scope.
consider. Okay, okay. You are at earlier
Yes,
stage,
at-
but you prepared the model.
8 to do, yes, sir.
Thank
And
you.
the structural analysis will give ultimately the fire rating.
Yes.
We are not looking at the failure scenario. Progressive collapse is applied only when you want to load capacity.
Yes.
Now, in fire resistant designs, load capacity is never estimated. We are looking for the fire rating. So, fire rating is the first collapse. Progressive collapse will come only when you want to know the load demand
Extreme.
capacity relationship. So, fire rating is the intersection of demand exceeding the capacity at a first point.
Yes.
Subsequently, it will exceed. So, our ultimate goal is to get the fire rating, right? And the fire rating should be more than the first interface what a prevention will have to happen. Either a suppression system or a fire deluge when this is switched on. So, fire rating should be more than that. System should sustain fire till that point. So, the estimate or the conclusion of any fire resistant design should to estimate the fire rating. Collapse will come only when you want to load the load capacity. Load capacity, nobody is further interested because structure is already collapsed. Okay?
So that point is not there in
Okay.
collapse.
No, I'll
Is not
improve,
it?
sir.
Okay.
Yes.
So you were saying that yes, going to do it. Okay. Thank you. Time is limited.
Yes.
So if anyone wants to interact, they can interact later. Okay.
Thank you.
Let me clarify on one thing because the question was asked on the shell element. Please get this very clear that shell elements are used when the volume to surface ratio is not very high. It means the thickness is not really important. So it's basically for the kind of problems where you have the surface deformation, not really anything to do with thickness. Whenever you have thickness which is in the dominating side, you cannot use shell elements by law. So please do not explore the application of shell elements to the problems where you have significant dominance coming from the thickness, especially when it is not a surface-driven phenomena. On this topic which she has presented, also please understand that what happens when the material temperature goes up, the properties start degrading. For example, you will lose E, you will lose other properties. And when you are losing the modulus of elasticity, you will see that everything will change. Your deformations, your load-bearing capacity, etc., everything. So she has explored way beyond even the crystallization because it still will crystallize around 740. She has gone up to 1200. So she is trying to understand what happens when the material is crystallized. What will happen to the properties, how the properties will be lost over a period of time. Okay, so next presentation is on effect of wave directionality on TLP with passive damper for surge motion control. The presenter is Shuja, our former PhD scholar.
A very good morning to all of you. Myself, Sujay TP. I'm working as an assistant professor in the Department of Civil Engineering, Manipal Academy of Higher Education, Manipal. And this is part of my thesis done here with the guidance of Professor Srinivasan Chandrasekharan, Department of Ocean Engineering. So here I am going to discuss about the effect of wave directionality on TLP with passive damper for surge motion control. So here the TLP is basically a is basically a floating platform with the tethers connected to the seabed to anchor the platform. So it is a compliant platform, flexible in their movement, and this resists the force encountered. And among the compliant platforms, we all know that TLP is one of the common one. These TLPs are installed from a water depth of 200 to 1000 meters, which is more with the tethers. Among these, Auger TLP, ISSC TLP are some of the classical examples. So in the literatures, I have found that TLPs are mostly on their, research is on mostly on their response behavior under different environmental loading. But few studies carried out response control methodologies for TLPs showed effectiveness in response reduction. Also, this research on response control for large surge displacement, which is the largest one among the 6 degrees of freedom, is very scarce in literature. However, this response control in compliant motion is essential to enhance their functional service in harsh sea states. So basically, my work is focusing on the effectiveness of the novel tuned mass damper as a passive device on the TLP performance for different wave heading angles. So as an example TLP, I have taken the ISSC TLP deployed in the Gulf of Mexican waters with a water depth of 450 meters. So this is the geometric parameters of the ISSC TLP. Now to the TLP TMD model. How I have modeled the TLP, this is a conceptual figure which the TLP TMD is combined. So it's modeled as a non-diffracting secondary structure attached to the primary structure. Now the mass properties of the TMD is assigned to the secondary structure. Also the mass center of the platform and the secondary structure coincide with each other. And the connection to the TLP from the TMD is established through the inextensible linear cable. The spring and dashboard system for secondary structure is established through unidirectional fender element. And the fender element's orientation is done to transmit the restoring and damping forces to TLP. All these numerical modeling and the simulations are done in ANSYS Echo. So to formulate, this is idealized numerical model with a free body diagram and the equation of motion, coupled equation of motion in the matrix form is as shown in the slide. And so the ratio of x by x static is formulated with 4 parameters. This damping, the mass ratio, mg by m, and frequency ratio omega by omega of the TMD divided by omega of the platform, and G omega by omega n, and these parameters are tuned. So if we require any particular x by x static for a particular mu value, the other parameters f can be tuned to get that. So to attain decided displacement ratio at fixed mass ratio, other parameters are basically tuned. Validation of the results are done by the Su et al. 2022, and a quite good agreement is being observed for the natural frequencies. Now to decide upon the mu value, I have conducted a preliminary study from mass ratio 0.1 to 1 with a time 0.1 to 1 through 0.2, 0.3, 0.4, etc. and found that at around 0.3 to 0.4 it shows a optimal result, and so I have chosen the 0.3, which shows the almost good agreement for selecting it. 0.3 the mass ratio. Now for the analysis purpose, I have taken PM spectrum, PSM Moscovite spectrum, and the sea state is the moderate sea state of Gulf of Mexico. The analysis is done for wave approach angles 0, 45 as well as 90 degree with a significant wave height of 6.5, zero crossing period of 8.15 seconds, and wind speed of 15 seconds. This shows the two extremes, 0 and 90 degree wave heading angles. So here with the TMD and without TMD, the spectral plot is shown, and it is observed that the spectral energy without TMD is being reduced considerably for both the cases. That indicates that there is a quite good damping and the response has been reduced considerably. And also we can see that the peak frequency is being shifted for the case with the TMD. And to check the coupling of effect of heave and pitch, I have analyzed for the heave and pitch. So it's observed that heave and pitch is not having so much of variations or effect in with the TMD cases, and so that's the observation from PSD plots. And to compare the comparison of damped natural period and the damping ratio for surge and heave and pitch for the said wave angles. So the natural period without TMD and with the TMD for the surge have considerably reduced. Also, the damping ratio is increasing. That indicates the TMD, whichever we have implemented, have a good control over the surge degree of freedom or the surge response. So the main conclusions over here is the surge response is maximum compared to heave and pitch responses for all wave heading anchors. Reduction in maximum surge response at all degrees of freedom is observed even after implementing TMD with the TLP. The zero change in the mean response indicates the recentering capacity of the platform, and the heave and pitch degrees of freedom, there is no effect after introducing TMD at all angles. And the damping ratio has increased for the platform with the TMD at all angles of wave heading, confirming the effectiveness of surge control. Thank you all for listening. And if there is any question, I am welcome.
Any question from the audience? Deepak, any question?
Okay, some simple questions. Okay, you considered 30% mass ratio. So what was the mass of your platform?
40,000 tons, sir.
And what is the mass of your TMD then?
1,200 tons.
More than 1 ton. It's a huge one, is not it? So one concern is that. And how your TMD is basically working? It's vertically, how you model mathematically means it's generating a force in horizontal direction or vertical direction?
For this case, actually, the TMD is inducing the motion, getting the motion as a induced motion. That is when the platform...
No, my question, I should clear it again.
Yes.
So when you are developing an equation of motion in surge direction, your TMD should also work in surge direction, is not it? So that way you consider that your TMD is also working in surge direction?
Definitely, sir.
So your TMD is basically hanging, yes?
Yes.
Is not it? It's hanging, and because of oscillation, it's generating, if I'm right.
Yes.
Or if I'm not understood it, you should tell me. So if it's oscillating, so what's the time period you consider for TMD? What is the time period of your TMD, and what is, your this mass system, and what is the time period of your TLP?
Okay, let me add a couple of things before you. Number one, Professor Deepak also worked on a similar problem along with me on Ranjani on the same tuner mass control systems where he has used, we have used spring mass system provided on the top of the deck. A suspended pendulum. So here it is not a pendulum action, it's a fender. Okay, fender has got reaction surfaces on the sides. Okay, it doesn't actually have suspension as theta as the angle of degree of freedom. It is x as the angle of degree of freedom, number one. Number two, when you talk about mass ratio, see, TLP is a positive buoyant system. TLP already has a restoring force coming from the tethers. So W is not compromised on TMD at all. When the mass gets displaced because of the offset set down problem, which is hardly 10% of the total mass maximum, you are taking 30% of that. Approximately is just 3% of 40,500. You are not getting this concept clearly. Okay, it is never 12,000 tons anyway. It's not 30% of the total mass. Total mass need not be actually tuned at all.
Mass.
It is a positive buoyant system.
It's the displaced mass.
It's a displaced mass. Secondly, what he is asking is, are you tuning the frequency of the TMD or if you tuning the mass of the TLD? You please answer what chairman asked. That will clarify, because I am intervening because of the interest of the audience. Because you are not able to, you are receiving the questions. It's better that you respond also. Better I add some value to your interpretation. Please respond what chairman asked.
Yes. It's okay. If you not able to, we will ask some other questions also. No question. One more question I wanted to ask. Where you were showing PSDF, can you go back? I think slide number 12. Yeah. You were saying that frequency changed, is not it? In the first figure. So previously frequency is a surge natural frequency omega n without TMD is in your blue color. And then the surge natural frequency with TMD is in a green color. And it's showing that your frequency increased, is not it?
Actually, in that figure, there is a shift.
This is my question. How you decided that? From figure, I can see that your response, that is a blue PSDF, is shifting towards left, is not it? So peak frequency is shifting towards left, but you are saying that frequency is increased. So I just wanted to understand how you are saying that.
Frequency is shifted, sir. That's it.
Yeah, shifted, but where it
Towards
shifted?
left.
Okay.
So the peak frequency, actually that you can discard that vertical dots. Then the peak frequency for the TLP without TMD and the peak frequency for TLP with the TMD. In those two cases, the frequency is being shifted.
No, Dr. Suja, let me be very clear. 1 minute, sorry. Sir.
Yes, sir. Okay, sir.
This was also posted to you by the examiner. Let me recollect that. When you add a mass, okay, when you add a mass, displacement increases. When displacement increases, T0 decreases. It causes slackening effect.
Yes.
So when T0 decreases, system becomes softer. So the period increases, frequency decreases. But in your case, it has been increasing marginally. What could be the reason? The reason is very simple. Mass is added, buoyancy is also added. So there's an upward force coming onto the system because of added mass.
Yes.
This upward force is invoking further buoyancy, which is causing increase in T0. So
Yes,
there is no
yes.
slackening. It is because of this you are having a shift.
Yes.
And now tell me why the shift has happened in the response. This is about the shift in the fundamental frequency.
Yes.
Why shift is towards response? Because TMD works with anti-out of phase with the model. That's the reason. Okay? So that's the interference.
You should clear a lot of things. But still I have a question. I should not ask now.
Okay.
So time is limited. Okay, thank you.
Shuja, only one suggestion. You can add doctor to your name now, okay? You have defended yourself. Okay, thank you.
No problem.
Now we have the last presentation.
Thank you, sir.
Thank you. Stability analysis of offshore triceratops under tether failure condition in diverse sea states. Presenter is Ashish, PhD scholar in our department.
Good morning, everyone. Thank you for joining the session. My name is Ashish Unikrishnan, and today I'm excited to present our research on this topic. This work has been a collaborative effort between myself, Advait Panindre, and Dr. Srinivasan Chandrasekharan, a professor, Department of Ocean Engineering, IIT Madras. I'll walk you through our work's essential findings and contributions. If you have any questions, feel free to ask during the question and answer session at the end. As the title suggests, this study focuses on the stability of a deep ocean platform, which in this case is offshore triceratops. We examine its stability by applying Matthew's stability parameters, specifically under the combined conditions. Two conditions. One is the removal of tethers, second under diverse sea states. Various structures are being utilized in deep oceans, with some being floating as spar and semi-submersibles, and some being compliant like TLPs, also known as tension leg platforms. Despite their differences, these structures share a common characteristic. Each consists of a submerged section rigidly connected to the top side, so we can call it monolithic structures. Okay. However, the offshore triceratops stands apart from these traditional structures due to its unique ball and socket joint. First, let us observe this video. Here, the legs are rotating about this ball and socket joint, but as we can observe, the top side is laying flat. It may having some heave motion, but it is not having any significant roll motion. Okay, so why that is so? It is because of the ball and socket joint that connects the buoyant legs with the top side. Especially to be noted is that, to clarify from the outset, the Triceratops is not simply a three-legged spar. Spars are neutrally buoyant structures that are spread moved to the seabed. But here it is a positively buoyant tether moved, pretension with pretension tethers, so it's not a spar. Also, it's not a TLP because TLP does not have a ball and socket joint connecting the top side and the legs. So the equation of motion, the components have 9 degrees of freedom. Normally, the floating structures have only 6 degrees of freedom. But here, since there is a rotational independency between the legs and the top side, there are 3 rotational degrees for the top side, 3 rotational degrees for the buoyant legs, and combined translational degrees 3. So total 9. The additional flexibility allows for independent motion between the top side and the buoyant legs. The numerical studies carried out under the simultaneous incidence of wave and current aligned at 0 degrees, that is, along the surge axis. The wave input spectrum follows the John-Swap model, and the 3 different wave conditions are applied for analysis. 2 distinct failure cases are considered. First is when tether 1 fails, and in second case, both the tether 1 and tether 3 is removed. Especially to be noted is this: both the tethers are situated in leg 1. That is, all the tethers of leg 2 and leg 3 remains intact. The postulated failure means we are assuming a failure. It is a hypothetical failure condition. In reality, the case may emerge during tether removal or when accidental load occurs. That is, collision can happen or ice loads may cause this tether failure. Also, when you keep on variable submergence due to that fatigue effect also, this tether failure can occur. The next case when it can occur in reality is the snap load, that initial elongation which will cause plastic deformation. So this tether failure analysis will help in 2 things. First, understanding the survivability of the structure if any of the above happens. Second, it also helps to let you know the order in which you must replace the tethers. You cannot replace as you want. Certain order has to be followed. This analysis will enable you to do that. The phase plots display the velocity in the y-axis and displacement in the x-axis. The pink curve corresponds to the structure in its intact state, the pink curve. The light blue-green color for the postulated 1 case, and the darker blue denotes postulated 2 phase plot. The phase plots reveal several key behavioral patterns of the structure. Notably, the deck center of gravity is 26.24 meter above the mean sea level. Also, when tethers are removed, we observe a shift in the mean position. Also, the width and height of the phase plots keeps on changing for each postulated cases. That means when the tethers are failed, the response is having a broad range compared to the intact condition. The plots are also symmetric about the vertical axis. That means even though it goes to that extreme sides, it is regaining its position very smoothly because of the recentering capability that is given to the structure due to the high pretension tethers. Also, the ellipse is seen to be very smooth, which indicates, as per the research literatures, the stability in that response degree of freedom. Also, we can observe there is a hollow point, hollow position or hollow shape in that blue curve. Why that is so? It is because when the structure is at that equilibrium position, that mean position, the velocity is never zero. So it follows a simple pendulum concept. Whenever it is at the extreme position only, it is having zero velocity. So it is having a very elastic restoration capability in heave degree of freedom. But in the 4,000-year wave period, we have some different results. It is no longer smooth elliptical shape as we have observed in the previous curve. The plots display some chaotic patterns while the structure is not yet deemed unstable since it oscillates around a new mean. First it was here, then it now oscillates around a new mean, but still it is now somewhere oscillating around that new mean. So it's not that much unstable also. This behavior is anticipated due to the scenario's significantly high wave loads. This figure shows the deck response for a 10-year wave and current action, while figure 8 shows for the same deck roll response for 1,000-year wave and current. As in the 10-year heave response phase plots, the shape is as of smooth ellipse. This shows the stable nature. Especially to be noted is this. There is a shift in the mean roll degree of freedom response, but even in this 1,000-year wave and current, a smooth ellipse is observed. Similarly, for the heave phase plot, see the shape. It is a vertical ellipse. That means the velocity component is very high for the response. That means the damping, which is proportional to the velocity, is also high. So in heave degree of freedom, that damping component is being, we are getting some damping component. But here in roll degree of freedom, it is a horizontal ellipse. So relatively, the velocity is less. So the damping also will be less. Still, the response is getting stable and very smooth elliptical shape. The stability of the structure behaves as if the sea is calm, even though the sea is 1,000-year wave current. It is not feeling the waves. Why? This behavior can be attributed to the ball and socket joint, which isolates the structure from wave-induced forces. However, the presence of roll motion still exists. The reason is unrelated to it is not related to legs roll motion, but the reason is something else. What would be that reason? So that reason is a differential leg motion in heave. As we can see, we have already noted that the leg 2 and leg 3 remains intact. So there is no tether failures. So in the bottom figure, in leg 2, there is no change in the mean heave position of the legs. But for leg 1, it is changing the mean heave response for each postulated case. Therefore, one leg goes up and one remains there. So the top side, which is connected using ball joints, will have a roll. So the roll of the top side is not coming from the roll of the buoyant legs. Rather, it is coming from the differential heave of the legs. That is the particular response characteristic of this structure due to the physics that is being given by the ball and socket joint. So this is a structure whose top side remains stable in that roll degree of freedom even during a very high sea state, even when some tethers are removed and despite having lower damping, as we have observed from phase plots. This remarkable stability is due to the inherent form-dominant design of the Triceratops. It's an inherent stability. So it is a smart structure. In the tether tension analysis, we plot the variations in tension for tether 2 and tether 6. So tether 2, tether 2 is situated on leg 1 where these tethers are failed, and tether 6 is situated in the intact legs. Okay. when tether fail, the remaining tethers on the same legs, emphasis the word, the same leg must bear increased tension. The load that was previously distributed among 4 tethers is now shared by just 2 tethers or 3, depending on the number of failed tethers. Conversely, the tethers on the other legs experience minimal impact. The less 21 meganewton, other tethers 42 meganewton and 29 meganewton. So a similar pattern is observed for 1000-year wave. Matthew equation is a linear second order differential equation that we have been carried out for this stability analysis that is usually used for assessing the stability of floating structures. This is a second order differential equation with a periodic coefficient, and it was first introduced by French mathematician Leonard Mathieu in his memoir on vibrations of an elliptic membrane in 1868. When the Mathieu parameters will lie between this red, blue, and the x-axis, we call it stable region. When it is in that unbounded space, it is called unstable response. This is how we interpret from Matthew's stability chart. So under this 10-year wave load condition, the parameters are situated within the stable zone. So it is showing stable response. Even in 1000-year wave conditions, most parameters fall within the stable region. But one point lies on the boundary. The study highlights, in general, a structure whose topside remains stable during a very high sea state, even when some tethers are removed. Offshore triceratops is a form-dominant smart structure. I look forward to any questions you may have.
Any question from the audience, please?
As the top side
It's
is
better you stand and ask the question.
there might be a differential movement between top side and triceratops. So what is the basic load transfer mechanism?
Okay. The loads from the wave-induced loads that happens in the buoyant legs will cause a moment on the buoyant legs, but it will isolate it. So the moments will not be transferred, but the vertical forces, heave forces will be transferred to the deck. Likewise, the aerodynamic moments caused due to the air on that all the topside parts, it will not get transferred to the buoyant legs, but that surge force on that topside will get transferred to the buoyant legs. That's how it is. That moment isolation happens. Yes, that's.
Can you also elaborate for the interest of the audience? What do you understand by post-tether failure? Why a post-tether failure is essential in such systems? Because tethers are never allowed to fail.
Yes.
Then why you are considering a case where tethers are supposed to fail and you are inspecting the stability? What is the great fun about it?
Sir, in reality, the case may occur when we remove the tethers for inspection or for replacement. Also for when accidental loads occur as collision and ice loads, or when you keep on varying submergence and that fatigue happens, it will also affect the tethers that then needs to be removed. Also the snap load, that is as we have already told, the plastic deformation due to that initial elongation will also cause some damage. So this all cause some tether instability. That's why this tether failure is important. Also, this analysis will help in understanding the survivability of the structure if any of the above happens. Also, the order of the tether replacement, that order we can get from this tether analysis. So,
okay.
I have a few questions. You prepared your mathematical model or you prepared this one in some software?
ANSYS.
ANSYS.
Yes,
okay.
for this.
So you will not be able to find the nonlinear terms which is basically affecting this response, isn't it?
Actually, that is not in the full scope of this presentation, but I'm doing it, sir.
Yeah.
Yeah.
It may be, but the problem is the
Yes.
same, no?
Yes.
So it will remain in this scope. Okay, but right now you are not able to find it.
Here.
What the load you are considering? Nature of the load.
Irregular wave, sir.
Irregular wave.
Irregular wave.
Then how your phase plot is looking very smooth? Can you go to your phase plot?
So phase plots are smooth because of the stable nature of the response.
No.
For that
No.
elastic
No.
restoring effect that is given due to the
I
tethers.
said no. I said no.
Yes, sir.
See it. Okay. Another thing, uh, when you are doing a Matthews stability, how you are doing it if you are considering irregular load and you are using ANSYS, is not it?
Sir.
So how you are basically coming to Matthews stability?
Yes, sir. So before assessing the Matthews stability parameters, we find the tether analysis. So there, the Matthew that has to be in that parameters that have
First thing, Matthews stability, what you did is for platform or for tether? What you did?
for tether.
Tether.
Yes,
Okay.
that is.
Right.
Yeah.
So now how you did it?
So from that tether analysis, we get that mean tether response as well as the amplitude that is varying with respect to that mean. So in that will be inputted into this Matthews equation, and we get that Matthew parameter.
And then excitation frequency?
Yes, sir. That's also.
How you use that? How you used that?
Excitation frequency is the peak excitation that of
So
that
peak,
Jones spectrum.
peak excitation you consider?
Yes.
Okay. So you modified your Matthews equation?
Yes, yes.
Okay. So you should present that. That is more contributive, no? If you modified Matthews equation, more debate will be there over that. Because modifying Matthews equation for random excitation is a real task. It's not an easy one. Okay? Okay. Any further question? Thank you.
Thanks to everyone, especially the audience and the presenters. So we have come to the last. So please note down all the comments which the people have made. It will help you in refining the presentation in the future. Also, when you try to convert this particular conference paper to the journal, please incorporate all the comments which have been made. Good luck to all of you. Wish you all the best. God bless you. Thank you.
Thank you for all presentations. Thank you, Professor Deepak Kumar, for joining us once again. Now I request Professor S. Shekharan to honor our chairperson, Professor Raju Sharma, with a memento as a token of gratitude. Thank you, sir. Please join us for high tea at dining hall. The second session will begin at 11 a.m. Thank you.
Welcome back. Now we'll proceed with the second session of the day. This session has been lined up with insightful keynote talks, and I would like to introduce our first esteemed keynote speaker, Professor Jonas Ringsberg. Professor Jonas Ringsberg is an esteemed professor of marine structures and currently serving as the head of the Marine Technology Division at the Chalmers University of Technology. Professor Ringsberg specializes in courses and supervises thesis projects for the International Master's Program on Mobility Engineering. Professor Ringsberg is actively involved in research within several regimes of marine structural engineering, material sciences, ice mechanics, Arctic engineering, wind-assisted ship propulsion, marine renewable energy. Professor Ringsberg is a member of Royal Institution of Naval Architects, Society of Naval Architecture and Marine Engineering, and American Society of Mechanical Engineers. He has been a member and served as chair for several international ship and offshore structure congress like Fatigue and Fracture from 2006 to 2012, Quasi-Static Response from 2012 to 2018, to name a few. Since January 2024, Professor Ringsberg is serving as the editor-in-chief for the Journal of Ocean Engineering. Thank you, sir, for your unwavering contribution in the academy and research. I welcome you on behalf of the entire ICSOS 2024 team.
Invitation to give this talk on energy. Thank you for the invitation to give this talk on energy efficient shipping. My name is Jonas Ringsberg, and I am a professor of marine structures at Chalmers University of Technology in Gothenburg, Sweden. Before I start my presentation, I want to acknowledge my colleagues, Professor Zhao, Dr. Thies, and Dr. Arabnejad, who have all contributed to the work I'm going to present. The work is an overview of perspectives and models developed during the last 20 years by our group, together with international partners in several projects. At the end of the presentation, a link is shown to the website where publications relevant to this talk can be downloaded. I also want to acknowledge all the good papers and discussions we have had with colleagues helping us to jointly develop the models that will be presented later in this talk. My university, Chalmers University of Technology, has roots in shipping that go back to the 19th century. The founder of Chalmers University of Technology was William Chalmers, a former director of the Swedish East India Company. He wrote in his testament that he wanted half of his fortune to be used to start Chalmers Craft School, which was founded in 1829. With these roots in history and the importance of shipping for global wealth, care and economy, ocean engineering and naval architecture have always been high on the university's agenda in education, research and collaboration activities. In 2005, a Swedish maritime competence center called Lighthouse was established at Chalmers. 5 thematic research areas were defined, and I coordinated the area Cargo Ship, which emphasizes research on ocean engineering and naval architecture. The Cargo Ship theme area has had 4 main topics in the research strategy: transportation efficiency, energy-efficient solutions and ship designs, lightweight ship designs, and energy carriers, storage on board, producers and consumers. Our signum has been to work holistically with universities, institutes and industry, looking for combinations of solutions and technologies that will minimize shipping's negative impact on the environment. There is an ongoing renaissance for sailing ships. Different sail solutions have been proposed, such as wing sails, suction sails, rotor sails, and kite sails. However, the visions of new designs of sailing ships require high-tech and multidisciplinary development. See, for example, the 2 examples where Chalmers has been a partner in their development. To the left, you can see the concept Orcel from Wallenius Wilhelmsen Lines, which started its development 2010. And to the right, you can see the Ocean Bird from Wallenius and Alfa Laval, and the development of this concept started 2011. These examples demonstrate that we have pushed the need for new research on large ships in our effort to make them transportation and energy efficient. The ships have wing sails, they have solar panels, a perfect aerodynamic design, but also hydrofoils. However, can we only rely on the sail as the main propulsor, or do additional energy carriers such as batteries or fuel cells, do they need to be installed? How do we know which systems should be integrated to achieve the fossil-free ship? In the remainder of my presentation, I will talk about energy-efficient shipping from the perspective if the current goals are reachable or not. I will present ship performance and energy management and how models can be designed to do these predictions relatively accurately. I'm going to present 2 models developed by Chalmers. One is called Ship Clean and one is called Chase. After that, I'm going to give examples of case studies where both Ship Clean and Chase have been used. And finally, I will conclude my presentation with some concluding remarks. The left figure shows how the world's seaborne trade has developed from 1970 to 2021. It has increased steadily as indicated by the red arrow. The right figure shows the carbon dioxide emissions from 2012 to 2023. As you can see, they also increase, but the slope of its red arrow is lower compared to the increase in seaborne trade. This is a positive sign that ship transport has become more energy efficient. Unfortunately, these trends together are alarming. Even if shipping only contributes to 2% of all global CO2 emissions, the emissions from shipping must be reduced dramatically if the IMO goal should be able to be reached. Seaborne trade has increased by almost 50% since 2008, and there are no indications that it will decrease. For a long time, regarding fuel reduction measures, there has been too much of a business-as-usual mentality instead of having sustainability as the priority. A lot of research efforts have been presented in the literature, and there are good examples of initiatives by ship owners and researchers together. However, shipping still needs more and better tools and models to predict and analyze the energy consumption of ships in operation, the energy consumption of new builds in the early design phase, and for retrofitting solutions, what is the effect of energy saving measures on energy consumption and the economy? Radical but needed emissions cuts will not be able to be reached by only researching ship energy efficiency, ship routing, or even wind-assisted propulsion. Some initiatives for pure sailing merchant ships are proposed, such as the Ocean Bird example, but they will also need complementary energy and propulsion systems. We should discuss more and join efforts to think fossil-free ships and which systems that can be combined to achieve such solutions for different ship types. Thus, research and development on ship performance and energy management should strive for holistic models of the entire ship system. We should develop models that include energy consumers, energy producers, energy storage and carrier systems, and energy losses in the system. We should investigate by simulations how the ship's system reacts or responds to different operation conditions on different routes for various met-ocean conditions. There are, of course, various approaches and methods that can be combined to form such a model. The choice of method and model must be made based on what accuracy and precision are expected. It is also important to include the aspect of computation efficiency, that is, the time it takes to run one simulation compared to thousands of simulations if Monte Carlo simulation approach is going to be used to simulate many operation conditions for the ship. At Chalmers, we have developed a candidate for a holistic model of a ship's energy system. We call it Ship Clean. It can be used to simulate a ship's energy performance, and it has been presented in numerous studies in the literature. Our ambition is to release it during 2025 as a Python code that is free to use, but under the new name Chase. Ship Clean has been developed to have high accuracy with acceptable precision compared to real measurements. We have prioritized analytical formula to as large extent as possible, using response surfaces to offer rapid simulation times for each voyage analysis. Hence, the model is suitable for simulation and analysis of a ship's energy performance during a full year operation using hindcast data. The architecture of the code is module-based. It means that energy consumers and producers, they have their own models. This is a convenient way of creating the architecture of the code, since new technologies or systems can easily be added to the code to compare different alternatives. The Ship Clean code has been validated against several model tests for 5 ships during still water conditions. You can see that agreement is good between the Ship Clean results and the measurements in the vessel's design points. The agreement is actually better compared to the validation goal that was defined before the validation was made. The code has also been verified against full-scale measurements from 3 different ship types. The AIS and the engine power data for all 3 ships were available in a verification study. The results show that the power prediction to measured power ratio is between 2 and 5%. These are just some examples of studies where Ship Clean has been used. It has also been used to investigate how ship routing and slow steaming may lower fuel consumption and thereby the CO2 emissions. It is, however, clear to us that the cuts are far away from what is needed compared to the IMO goals. Different sail types and technologies have therefore been added to Ship Clean to explore the potential for reduced fuel consumption if wind-assisted ship propulsion, WASP, is installed. Our findings this far show that the ship type, its operation profile, ship route, and sail type need to be studied on a case-by-case basis to understand how we should be able to reach the optimal fuel savings. I should mention here that the results this far show that WASP is not the solution. We must investigate solutions to combine, for example, WASP, batteries, and fuel cells. The need to better understand how various energy carriers and producers work has resulted in the need for numerical simulation models that can, at least virtually, simulate the performance of integrated system solutions. The ShipClean model could have been used for this purpose, but a new model we call Chase was developed to obtain a more user-friendly simulation platform. It is also Python code with objective-oriented programming with an architecture that offers flexibility if new future features should be coded. It is faster code than ShipClean, but with the same accuracy and precision. A simulation has different classes, ship and route classes, which are defined as input to the ship performance simulator, which is basically a recoded version of the ShipClean model. One of the new novel parts in the Chase code is the propulsion system class illustrated in the figure. The user can define which propulsion systems should be integrated and how the energy management should be run. For example, charging times for batteries, load on the fuel cells, RPMs of Flettner rotors, etc. The publication to the right in the Ocean Engineering Journal presents all the details behind the Chase model and its development. In the following case studies, we present some important findings where ShipClean and Chase have been applied on real ships together with ship owners to explore alternatives for fuel reduction measures. In a validation study 2018 made on the RoPax vessel Grace, ShipClean's ship systems model, including a Flettner rotor, was only 1.7% off compared to fuel consumption measurements. This was the first time the ShipClean model was used in a validation study. The study gave us confidence in the ShipClean and Flettner rotor models, where hydrodynamics, aerodynamics, and energy systems analyses were combined together. In the WASP EU project from 2022, ShipClean was applied to model the ship and the Flettner rotor installation shown in the photo. This analysis was made after the installation was made to explain why the thrust provided by the Flettner rotor was lower compared to expectations. Hence, the task was to resimulate the as-installed Flettner rotor and the ship's voyages and explain why the predictions prior to the installation were inaccurate. Hindcast data for the ship during several months of operation was collected, and all the voyages were simulated using ShipClean and its 4 degree of freedom ship motions model and the Flettner rotor model. Note that the windrows indicates that the wind conditions in the area are not very stable, which will affect the performance of the Flettner rotor. The results are shown in the right figure, where the cross marks the as installed position of the Flettner rotor. The company that installed the rotor expected a thrust of 15%, while the rotor delivered only 11% according to the measurements. The prediction by ShipClean is presented as the mean value of the performance from all voyages and months. It is estimated to 2.5%, which is close to what actual measurements show, that is 11%. The simulation results show that the position of the Flettner rotor is important in combination with the ship's motions and rudder forces. The study shows that ShipClean seems to consider these factors and forces satisfactorily, at least compared to this case study. In another study, a ship owner wanted to install 4 Flettner rotors on a ship. When several rotors are installed, there will be interaction effects between them, meaning that the true wind angle and the apparent wind angle for each rotor will differ. This must be considered if accurate predictions of the thrust from the rotors should be made, but also in the calculation of the rudder forces. The arrow in this diagram points to the Flettner rotor thrust curve if no interaction effects are considered. It corresponds to the curve for only one Flettner rotor. The other curves show how the individual curves for the rotors look for the studied rotor size and the rotor's relative positions. Note that if the distance between the rotors is changed, then the thrust curves need to be updated. These differences are not minor if they're used in a ship performance simulation model. They are large enough to have a relatively large influence on the entire ship's energy performance model and fuel consumption prediction. Normally, the reduction in fuel consumption prediction is overestimated if no interaction effects are accounted for. Finally, sailing ships either reef or they sheet their sails to control the thrust and forces acting on the sails. For Flettner rotors, it is the rotor's RPM that can be controlled and optimized to maximize their efficiency. The diagram to the right shows an example of how optimal RPMs for each rotor will maximize the total thrust from all 4 rotors on the case study ship. It illustrates that depending on the true wind angle conditions, control algorithms that regulate the rotor's RPMs are needed. The third example illustrates how much fuel would have been saved for a ship if it had been equipped with a sail but without any other changes in the route or operation conditions. We selected an Aframax tanker which we received AIS and fuel consumption data for during 1 year, 2018. The ship was modeled in Ship Clean, and its voyages during 2018 were first simulated without sails. The deviation was only 2% between simulations and fuel consumption statistics. A model of a crescent-shaped sail was integrated in Ship Clean, and the ship's voyages during 2018 were rerun. With this sail, almost 10% of the fuel would have been saved. We then compared it with the Flettner rotor, and the fuel savings were about the same. Note, though, that there could have been practical aspects in the choice of sail technology, such as the dimensions of the sail or how it needs to be operated by the crew. Finally, the ship was equipped with 6 Flettner rotors to increase the sail area. The simulations showed that 33% fuel savings would have been achieved with 6 Flettner rotors. The results from this case study shows at least 2 important things to us. Installation of single or several sails, such as Flettner rotors, will give us immediate fuel savings. However, they will not be enough if the IMO goals are able to be fulfilled. This takes us to the fourth and final example, where different technologies and energy carriers have been combined to see what is needed to possibly achieve a fossil-free ship. The example presented here explores WASP, battery, and fuel cell systems. The example ship has been modeled, simulated, and analyzed with the new Chase model. In a case study, the existing Ro-Ro ship Tavastland operating in the Baltic Sea was used. Its operation profile is shown in the table, indicating the start and end harbors, the journey time, average ship speed, and harbor time as it is operating today. It was decided, together with the ship owner, to try to keep this operation profile during the case study and all the solutions that were tested. We decided to run Chase simulations for 1 full year of operation, where we used hindcast data to model the weather, the current, but also the ice conditions in the area. The upper figure showed the propulsive power and energy needed every week and between ports to keep the schedule as the ship is operating today without WASP. The lower figures, They show the corresponding results when the ship is equipped with 4 Flettner rotors. The required energy or fuel is reduced with some 30%. Hence, to make this ship fossil-free, additional energy carriers and propellers need to substitute the fossil fuel engine. Let us first look on batteries. The question is how to size the batteries to achieve a fossil-free ship with WASP. The sizing of the batteries depends on charging possibilities in the ports and how much power is allowed to be consumed from the batteries between the charging stations. You see here what we have assumed in our simulation model. It should be noted that these are typical values that are used today in the design of ship battery systems. The figures show from the upper left to the lower right that fewer and fewer voyages have to be cancelled or are delayed with an increasing size of the battery. The final results show that the battery capacity of 1,500 megawatt hours is needed if charging will only take place in Oulu in Finland. The weight of the batteries corresponds to 85% of the ship's dead weight. This weight cannot be accepted, of course. If we allow the ship to charge the batteries in both Lübeck and in Oulu, it is enough with the battery capacity of 1,200 megawatt hours, with the weight corresponding to 68% of the ship's dead weight. Still, the weight of the batteries is too high. So because of the battery weight, a hydrogen fuel cell system was added as a complement to the WASP and the batteries. The results show that if there is no charging in Lübeck, 900 megawatt hour batteries will be required. This is still not optimal. However, with Chase, it is possible to explore and compare different alternatives. The Tavastan case study shows that more options need to be explored to identify realistic and cost-efficient solutions to make the Tavastan ship a fossil-free ship by retrofitting. Finally, this presentation has shown that wind propulsion can save a considerable amount of fuel on many of the existing vessels. However, it is important to have proper simulation tools and holistic models that can be used to simulate and analyze the performance and potential fuel savings with high accuracy and acceptable precision and at a low computational cost. Holistic models can be used to analyze and guide us on what to develop, why and how to retrofit a ship with the most suitable WASP, batteries, fuel cell system or a combination of the different systems. I want to thank you for your attention and I'm happy to answer any questions that you may have. Thank you.
Thank you, sir. Any question from the audience? I have one question, sir. When it comes to the commercial vessel, for example, the big ones, the container ship, VLCCs, is there any potential that the wind-assisted propulsion can be used?
Thank you very much for your good questions. Yes, if you think about the ocean bird concept, that the idea was to have it fully sailing, but now it has been realized that there must be complementary energy savings. So it must have some kind of hydrogen fuel cell-based system. That is what is going to happen. When it comes to the biggest container ships, to have sails put on board, that's not really realistic. Research is more moving into nuclear-powered container ships in the future. So we are currently investigating that as another alternative. It's not completely fossil-free, but it's a very good alternative, especially when the sizes of the container ships continue to increase.
Thank you, sir.
I have a question.
Yes, please.
Yeah. See, the sizes of the sail on these ships are quite large. Is there any sizing required for this vessels, how many in number and the sizes of these sails, particularly fixed sails, how big it should be. And most of the time it's operate in pairs. Maybe they are wanted to, the sway force which is created, they want to negate it. Is there any study on that also?
Thank you very much for a very good question, which is more sailing related. The dimensions of the sails, that's a topic itself. If you think about the sails, they will be very, very large. So we have to think about stability conditions of the ship and the strength of the mast and the sails. So that's the structural integrity point and ship stability point. That's one aspect. It also shows that if the sails become too tall, we will have difficulties to get these ships into some of the ports in the world. So we cannot have foldable masts on all of them. So my best guess would be that we will have retractable sails, like the crescent-shaped profile indicated in one of the concepts. Or the large sailing ships, they may have a separate port outside the larger ports, and then we will have some unloading if sails are really going to be used in the future of these dimensions.
Thank you. Any questions further? Thank you, sir.
Thank you very much.
Professor Paniselvam.
Thank you, Jonas. I personally thank on behalf of the Department of Ocean Engineering in coming online, as also that it is time to hand over the baton to you, and all the best for the next ICSOS 2025. Thank you.
Thank you very much, and welcome to Sweden next year.
Yeah.
Thank you.
Thank you. So next will be held in Sweden. So please prepare yourself, all the audience. Thank you, sir. Thanks. You can log off, sir. Next, it is my honor to invite Dr. Mujib. And before that, we would like to briefly introduce him. So, please.
So I would like to introduce our next keynote speaker for the day, Dr. Mujib Ahmed MP. Dr. Mujib is currently working as a research associate in the Department of Naval Architecture, Ocean and Marine Engineering at University of Strathclyde, Glasgow. He has a master's degree in ocean engineering from IIT Madras, followed by a Doctor of Philosophy from Pusan National University, Korea in Naval Architecture and Ocean Engineering. Dr. Mujib expertises in the domain of safety and risk assessment, management of ships and offshore structures. Dr. Mujib was the recipient of the prestigious Anne Telfer Prize in the year 2022. He is also serving as an associate member of the Royal Institution of Naval Architects. We welcome you, sir.
Good morning, ladies and gentlemen. Welcome to my presentation on quantitative risk assessment on ammonia fuel ship. The presentation will focus on key results, discussion, and design recommendation arising from the study. My name is Mujib Ahmed, and I have been a research associate at the University of Strathclyde since 2020. I also serve as the technical lead for the Nursery Craft project. In this presentation, I will share some of the significant findings from the latest research over 2 years, and I hope you will find it engaging and informative. Before I dive into the topic, I would like to express my gratitude. As a former student of IIT Madras, it is an honor to present here today. Also, I extend my sincere thanks to Professor Paniselvam for inviting me and providing this opportunity. I would also like to acknowledge Professor Jomki Paik, who is my PhD supervisor, as well as all the distinguished professors and colleagues who have joined both online and in person at IIT Madras. The objective of the QRS study includes safety simulation for potential ammonia gas leakage, dispersion, fire, and explosion. To perform risk evaluation on ship dangerous areas such as bunkering station, fuel preparation room, storage tank, and engine room. Finally, we provide risk control and optimal design or operational solution for enhancing the safety of ammonia fuel ship. Okay, ammonia as a potential marine fuel. According to IMO's revised strategy for greenhouse gas emissions in 2023, the target is to reduce the greenhouse gas by to 20% by 2030 to 70% by 2040 compared to 2008 level and to net zero by 2050. There can be various measures which can be followed to reduce to achieve this ambitious target. For example, use of alternate zero carbon or renewable fuels through energy efficiency by systematic change in global trade dynamics or improving the design operational measures, etc. If you consider the alternate marine fuels, we have a number of options such as use ammonia fuel, hydrogen, methanol, biofuel, LNG, etc. In this research, we focus on the ammonia as a marine fuel. Ammonia got several advantages such as it is a zero carbon dioxide emission gas. It can be stored as a liquid at relatively moderate pressure and temperature. Well-developed global infrastructure for ammonia production, storage, and transportation due to its use in fertilizers and other industries. However, this comes with certain disadvantages such as ammonia got low energy density, so that means it needs more storage space required on the ship. The production of green ammonia is expensive. Ammonia itself is toxic and corrosive, so safety during storage, handling, and its use as a fuel on board becomes critical. On the right, the table shows ammonia properties. As you can see on the bold font size, auto ignition temperature is 630, that is quite high, so that means ammonia is quite hard to ignite. The flammability range is narrow, which is only 15 to 28. As I said before, energy density is quite low, so more storage space is required to store ammonia, and the density of ammonia is 0.69, which is quite low compared to the density of air, which is 1.2. Now a brief introduction to the project Ammonia Craft Project. It's a EU Horizon Research and Innovative Program. It consists of 12 partners from 6 different member states, including ICSOS, classification societies, major engineering designers and consultancies, leading technical universities, industrial partners, and SMEs, and one of the largest ship management companies globally. The objective of this project is to develop a new design methodology that will offer the feasibility of about 1000 cubic meters storage of ammonia in liquid form at a pressure of about 10 bar, and to demonstrate the methodology on a 31,000 DWT ton multi-purpose general cargo ship. This slide shows overview of different work packages in the Ammonia Craft project. Risk assessment, which is work package 7, is integrated and work closely with the design team during each design stage, starting from conceptual to basic to detailed design. We conduct safety and risk assessment and provide design and operational recommendation, which will ultimately support in the final design approval and followed by retrofitting, testing, and operation. The findings from the risk assessment are then recorded in the form of safety guidelines and materials for training and education. This slide shows the severity of ammonia toxicity. The table shows different risk level of ammonia starting from AEG level 1, that is, for example, ammonia concentration of 30 ppm exposed to 10 minutes can have discomfort, irritation, or asymptotic numb effect. In the risk level 2, for example, ammonia concentration of 220 ppm exposed to 10 minutes, it could potentially incur irreversible or other serious and long-lasting adverse health effects or impaired ability to escape. For higher concentrations, such as 2700 ppm, life-threatening health effects or death even could occur. As such, different class societies has come up with safe level of ammonia which can be detected on the ship. For example, ABS comes up with ammonia concentration of 25 ppm, also KR and NK, while BB proposed 30 ppm and RENA 50 ppm. For the mechanical ventilation capacity, all classification societies suggest that at least 30 air change per hour should be the capacity of the ventilation system. Okay, So the demonstrator ship used in our study is a 31,000 multipurpose cargo ship, as you can see on the left. Regarding ammonia storage tanks, 2 tanks have been placed on the deck, 2 large tanks, and many tanks, smaller tanks have been placed, consist of metallic and composite tanks are placed in the cargo hold space. This constitutes a total number of tanks of 48 with a total capacity of 770 cubic meter. On the right, it shows the various units involved in the ammonia retrofit ship, which includes tank storage on the upper deck, fuel preparation room, vent master, tank storage on the number 5 cargo hold space, and engine room. So after we define the demonstrator ship, the next step is to define the QRS scenarios. In the project, we initially had a hazard workshop. So during that workshop, which includes both internal partners as well as external stakeholders, we come up with 7 major scenarios which has to be conducted in QRA. The first scenario includes ammonia gas dispersion analysis from vent mast. The objective is to determine the location of the vent master. In scenario 2, ammonia gas dispersion in humid condition is conducted so as to confirm the effect of humidity on gas concentration on deck. In scenario 3, we perform ammonia leakage on deck so that we could establish the toxic zone. In scenario 4, ammonia gas explosion analysis in number 5 cargo hold space will be conducted, and this is to assess the structural integrity against overpressure. In scenario 5, mechanical ventilation fan effect in number 5 cargo hold space is conducted. This was to determine the vent effect and the location inside the number 5 cargo hold space is efficient or not. In scenario 6, ammonia gas fire analysis in number 5 cargo hold space. Again, we assess any fire safety measures, which includes active as well as passive measures are required to protect the tanks against fire. In scenario 5, we assess the potential ammonia leakage during bunkering operation. Thereby, we aim to establish bunkering safety zone. This slide shows QRA methodology. I'm not going into deeper, as you all well familiarized with the QRA, which includes basically 5 steps. That is step 1, that is target ship. In our case, it is a demonstrator ship. And step 2 is to identify the hazard scenarios which have been selected from the hazard workshops, which is 7 scenarios. And for each of these scenarios, we conduct CFD simulation, and also we perform the probabilistic frequency analysis, and we combine that, we get to risk. And finally, in step 4, we process the result of the risk, that is risk evaluation in terms of risk grant, and we present the results in form of 2D and 3D plots. And in step 5, we provide safety and recommendation, which includes both design and operational. In our study, for the CFD simulations, we mainly used Flux software, which is well established and validated tool for dispersion, fire, and explosion of different gases. Further, in my presentation, I will not go in detail about the CFD simulation setup, and I'll focus mostly on the result, the different scenarios we have considered, and finally, the design recommendations. Okay, so scenario 1, that is ammonia gas dispersion analysis from the vent mass release. As you know, the ammonia is toxic, so any dispersion via vent mass could have a direct impact on the crew or passengers on the ship. So the objective of the study is to identify the optimal position and height of vent mass so as to minimize the concentration of ammonia around the accommodation area. Okay, let's see what are the toxic areas as per the class rule and regulatory committees. For example, IGF core recommendation for vent exit recommends a vent mass height to be greater of be over 3 or 6 meter above weather deck, or at least 6 meter above working areas and walkways. Also, the vent mass should be at a minimum distance of 10 meter radius from non-hazardous space. Further, IGC regulation states that the release should be unimpeded, that is vertically upward discharge at exit. There should be no components restricting flow or creating counter pressure after valve. 3 scenarios have been considered based on the position of the vent mast and the height of the vent mast. Also, 3 gas release rate have been considered: 10 kg per second, 30 kg per second, and 50 kg per second. And the wind speed considered calm, light air and gentle breeze with wind direction of 270 from port to starboard, 225 degree, and 180 from bow to stern. This slide shows the results of the QRS study with increasing leak rate. As you can see, as the leak rate increases, the range of ammonia gas dispersion also increases. Baseline of 108, which is far from the accommodation area, possesses less risk of ammonia spread compared to the baseline of 40 meter, which is close to the accommodation area. From the results of varying wind speed, we found that even with a small wind speed of 1 meter per second or greater, ammonia concentration measured around the accommodation area is well over 30 ppm, irrespective of the release height and the vent mass location. Further, with varying wind direction, as you can see, it has a strong and direct impact on the ammonia gas dispersed. For the most of the scenarios, ammonia concentration measured around the accommodation area was again well over 30 ppm. So the study shows that regardless of vent mass position and height and weather condition, the ammonia concentration could easily surpass 30 ppm around the accommodation area. So the design recommendation from our side was to have ammonia catching system, which was then applied to demonstrate a ship. Figure on the left shows ammonia as a typical ammonia catching system, which includes ammonia coming from the tank or knockout drums, which passes through a dilution tank where the water comes from freshwater tank, and the diluted ammonia with the concentration of less than 30 ppm is then released to the air. On the right shows the process flow diagram with ammonia catching system used in the MAN engine maker's ammonia engine test. Scenario 2: ammonia gas dispersion analysis in humid conditions. The objective of the study is to identify that ammonia which could potentially form a toxic zone by settling on the deck due to humid condition. Because unburned ammonia emissions are much lighter than air, they rise rapidly in dry air due to the density difference. At sea, however, they quickly react with humidity in the air, remaining close to the ship's surface, which may cause hull corrosion. Therefore, it is a factor to be considered. The formation of ammonia vapor cloud in the vicinity of the ship or in remote location, taking into account the ambient condition, example humidity. To consider the effect of humidity, we considered a scenario with a pool leakage of a radius of 2 meters, and we have considered 3 scenarios based on the humidity levels, that is 90, 50 and 10%. Okay, so 3D plot video shows, let me play this video. Okay, on the left shows 90% humidity level, on the right we have 10% humidity level. So with over the time the ammonia get deposited over the deck. Instead of dispersing away from the ship, they try to get settled over the deck, as you can see. So for both 90 as well as for the 10% humidity level, the ammonia tend to remain on the deck. The results from the different monitor points located around the pool leakage shows that the concentration of ammonia in terms of ppm at 90% humidity level is quite high compared to 50% or 10% humidity level. A similar observation can be also found for other monitor points. Okay, so based on the results, we found that high humidity conditions likely cause dispersed or leaked ammonia to remain on the deck. Therefore, we strongly suggest to implement operational safety guidelines for crew and passenger awareness regarding ammonia's presence during ammonia release. Further, we recommend to consider installing humidity monitoring devices on the deck for continuous assessment. Also, we found that the effect of varying humidity levels, 90, 50, and 10%, the ammonia gas near the deck was observed to be minimum, and this we think is due to the limitation of the software. So we propose further experimental in terms of small and large scale, as well as probabilistic study to fill this gap. Okay, so the third scenario is ammonia leakage from the tanks installed on the upper deck. Here the objective of our study is to identify and determine the toxic zone, that is 30 ppm or over, resulting from ammonia leakage. According to the class rules, the toxic areas is they're determined to be 10 meter. It should be away from open deck or semi-enclosed space on deck or any fuel tank outlets. So to assess these conditions proposed by the class societies, so we in our QRS study have considered different leak scenarios, which includes parameters such as leak direction. As you can see on the left, we have considered a vertical direction, Z direction, as well as horizontal leak direction, with a different leak size of 3 mm, 10 mm, 50 mm, wind speed of 0, 5, 10, and 20 meter per second. So the toxic zone is considered to be 30 ppm or greater. This slide shows 3D and 2D plots, that is dispersion over the time. As you can see, the potential leakage from the ammonia from the tank could disperse easily around the accommodation area. And also you can see the 2D slice which has been placed across the leak point. A significant presence of ammonia has been observed behind the accommodation area, while the ammonia concentration or lower presence ammonia concentration of less than 30 ppm can be observed in the farther distance. Okay, this slide shows the summary of the leak scenarios for different wind speed and leak size. Wind speed of 0 meter per second, 5, 10, and 20 meter per second. As you can see, with increasing leak size, the ammonia dispersion also increases, thereby the toxic zone around the leakage also has to be increased. So similarly for the leak direction, horizontal leak direction from stern to bow, a similar observation was found. In summary, there was found to be a variety of parameters which contribute to the establishment of toxic zone. As you can see, for the leak direction, different wind speed, different leak sizes, we can have varying toxic zone. So the design recommendation from our side, a toxic zone has to be established based on a common assessment method. The class societies provides two general, but research indicates that two case-specific and impractically large zones. So incorporating variety of parameters such as size and direction of the leak along with wind speed into probabilistic study is crucial for refining risk zone to achieve more accurate risk assessment. This method provides a thorough understanding of potential impact area in the event of ammonia leak, considering the variability and uncertainty typical of real-world scenarios. So scenario 4, ammonia gas explosion analysis from the tanks in the cargo hold number 5 space. Even though the flammability range of ammonia is quite narrow, however, in the closed space such as cargo hold space, in the event of ammonia leakage, can easily go through this and the ammonia can easily reach this flammability range and cause explosion in the right condition. So the objective of this study is to identify the explosion pressure of ammonia, thereby ensuring the structural integrity and safety measures if required. This slide shows geometric and grid modeling. On the left shows the cargo hold space where you have a big metallic tank And containers two, one contains metallic tanks, other contains composite tanks. And on the right, it shows the 8 ignition points. For the boundary condition, we use Euler condition. This slide shows 3D plot video of the explosion. For the considered scenario, we have considered ammonia concentration at LFL, UFL, and stoichiometric ratio. This slide shows the results of the ammonia during explosion at 8 ignition points. On an average, across different LFL, UFL, and stoichiometric ratio, the pressure is found to be around 7.3 bars. So, the design recommendation from our side. So, taking into account 8 ignition points, which represent the entire area within the number 5 cargo hold space, and the ammonia, the amount of ammonia that has leaked as LFL and UFL, it is anticipated that there could be exposure of pressure ranging from 7 to 7.3 bars. However, an overpressure of 7.3 bars could significantly impact the structural integrity of the ammonia storage tanks and the associated pipelines in the cargo hold space. So this may be difficult to achieve. So to properly assess the potential risk and to recommend appropriately safety measure, we recommend for further investigation, basically to employ a probabilistic approach to fully understand and mitigate the risk involved. Okay, so scenario number 5, mechanical ventilation, a fan effect scenario in cargo hold number 5 space. Okay, so in case of leakage, the ventilation system should be effective in extracting all the leaked ammonia out of the space so as to prevent any potential fire and explosion. So the optimal arrangement of ventilation system become paramount importance. So this slide shows again the same space, geometric cargo hold, geometric modeling cargo hold space. So we are following the mechanical ventilation with the capacity of 30 air change per hour as required by all the class societies. For the ventilation arrangement, different scenarios has been considered, namely 4 scenarios, scenario A, B, C, and D, based on the inlet and outlet positions of the duct. So, considering 30 air change per hour with ammonia density, and the volume of air inside the cargo hold space, the calculated fan capacity was found to be 37.32 kg per second. The result shows the 3D plot of different scenarios, namely the velocity vector. This slide shows a 3D plot video of ammonia concentration. So 3 concentration has been considered for our study. 10, 20, and 30% ammonia is initially present inside the cargo hold space. As you can see, with all the time, the ammonia concentration is lowered.
Dr. Mujib?
Okay, so the result shows that across
Mujib,
different
can you hear me?
scenarios, in terms of time to reach below LFL or time
Yes,
to
I
reach
can
under
hear
30
you, yes.
BPM
Yes. Wait, can you
in
please
less than
conclude?
30 minutes, or you can say the maximum time.
Oh, you recorded. Okay.
Sorry, can you repeat that?
Mujib, we will
Yes.
be cut-shorting this in another 5 minutes because of time. And we'll
Okay.
play this in the conference or seminar hall in the Department of Ocean Engineering for students' benefit. Because we are running out
Okay.
of time, and I see still there are many slides, another 20, 25
Yes.
slides, which may require another 15 or 20 minutes. So we are going to cut short this in another few minutes, okay? And
Okay, no problem.
Yeah, take some few questions.
Okay.
Thank you.
Inside, we have a number of components such as manual valve, actuated valve, pipe, flange, etc. And we calculate the vessel operation profile with the tank capacity of 770 cubic meter. With the bunkering supply time of 3.75 hours, we found total bunkering time to be around 5 hours, and the leak frequency we consider to be around 5 mm, 5 mm, 10 mm, and 100 mm for analysis. Two port areas have been considered in our study, Port of Hamburg, Port of Rotterdam. The wind rows for this location have been used. On the bottom, you can see the population density. The Rotterdam has higher population density compared to Hamburg. The population density has been distributed based on the again based on city center area, residential area, harbor area, working area, car parking area, bulk storage area. So again, for the leakage scenarios, 3 scenarios have been considered in the event of leakage. So in the scenario 1, there has been a leakage occur and there has been an immediate action through sensors, so 5 seconds. And for the scenario 2, we have automated emergency shutdown operation with manual intervention. And for scenario 3, with the late intervention. So for each of these scenarios, we collected leakage quantity for different leak sizes. So you can see here the safety zone for ammonia bunkering at ports. Boundaries has been defined. Each boundary is represented by frequency. For example, for the scenario 1 where you have small leakage, the boundary is found to be around 50 meter, while for scenario 2 is 500 meter, for scenario 3, 1500 meter. And with decreasing frequency, we expect to have higher boundaries. The same trend has been observed for the port of Rotterdam, however, with a slightly higher boundaries. Okay, so the design recommendation, the fuel leakage time and quantity significantly impact the extent of safety zone. So the emergency shutdown system and procedures are required with accurate sensors which could monitor the pressure of flow sense variations accurately. Consider ammonia bunkering operation in semi-confined condition to mitigate the spread of ammonia in case of leakage. So conclusion, this study presents design operational recommendation. It serves as a significant step towards developing safe and efficient design and storage of ammonia storage tank and its auxiliaries on board. We found that weather condition to play a key role in the ammonia dispersion. In the study, we mainly followed deterministic approach, while for some scenarios, we identified that a further study based on probabilistic study approach is required, also supported with experimental studies. Nonetheless, the research is progressing in a promising direction. So the results of this QRS study has been presented to ICSOS decarbonization panel and also IMO working group and also to various classification societies such as ABS, RENA, NK. Some of the results has been published in Journal Ocean Engineering, International Journal of Hydrogen Energy, and also have been presented in different conferences. The ongoing research, we are expanding the scope to different ship types, both retrofit and newly built. For example, short sea ferry, 50,000 tanker, 2,700 TEU container, 1,500 ROPAX. And we have identified 5 scenarios, mainly ammonia dispersion in short sea ferry, whether ammonia catching system is required or not, ammonia pool fire in tanker, ammonia jet fire on the container ship inside the cargo hold space, mechanical ventilation in the cargo hold space, which contains numerous number of ammonia tanks, and mechanical ventilation inside the confined space of ROPAC ship. Okay, if you have any questions, you can contact me on my email address provided here. Also, you can get for more information, you can visit the website of the project. Also, we'll be providing regular updates from the project or the LinkedIn link provided. Thank you for your attention.
Thank you. Any question from the audience?
Check. Yeah, thank you for your wonderful presentation. I have some few questions like which DNV code that you were referring to here? I just saw DNV, but not the code name, the code number.
Thank you for your question. So, are you referring to the code which I use for calculating the probability, you mean?
No, the several codes, especially for the classes and all, you were referring to a particular DNV code. I mean, several slides, I can see them.
Sorry, I don't know exactly
No
the
worries.
code number,
I'll contact
but
you.
yeah, you can say that the document title would be ammonia as potential marine fuel, something like that. You can easily find it online.
Okay. And you were talking about, it being carried in a ship, transported in vessels. But how about, have you seen ammonia being transported using pipelines?
You mean the pipelines on the ship or
No.
auxiliary pipelines?
I'm referring to onshore or offshore pipelines.
No, I didn't have any personal experience on
Okay.
that.
No worries. Thank you.
Okay.
Any other question? Dr. Mujib, I have one question. What is the fuel efficiency? When you try to use ammonia as a fuel,
Yes.
how does it perform on the efficiency level? For example,
Regarding
the cost of per unit transportation, for example, for a container ship, will it really get changed, or it will remain the same, or it will go up, or it will come down?
Regarding the ammonia burning or combustion, still I understand that the engine makers, they are still under testing
Because as far
stage.
as I understand the basic
And
economics, ammonia as a fuel is not really that efficient. When you do the cost calculation, your cost of transportation will actually go up. And
yes,
in the areas which are basically governed by the bottom line, it will be difficult for us to justify the cost increase, because look, for example, the commercial shipping, it is already, the bottom line is already strained. So have you looked into
yes,
the cost aspect of it?
no, that's actually currently out of scope, but yes, I fully agree with your comments that it is not efficient as compared to the diesel or heavy fuel oils. There are still further research to be conducted on that side.
Okay, thank you.
Okay.
Mujib, was there any small scale model test related to any of these studies you have made so far simulated?
For the simulation I have conducted, no, we don't
Okay,
have
fine, fine.
any. But on the project side, we have just finished the design for ammonia storage tanks. So we are now moving to the testing stage where we're gonna test the ammonia storage tank and the installation on ship, probably in the next year.
Okay, thank you, Mujib.
Thank you. So we are concluding this session. Thanks a lot.
Now continue the session for 3 phases. How many more papers?
Thank you, Professor, for your valuable time. Now we'll move forward for the next session, which is a technical session and is based on ocean energies. So I would like to request Professor Abdus Samad and Dr. Bitin Ghorai for being the chair and co-chair for this technical session. Sir.
Good afternoon. Yeah, I'm Professor Abdus Samad. I'll be
My name is under chair, right? And with me, Vitin Ghorai, he will be co-chair. And how many papers are there? 4 papers. So 20 minutes is 15 minutes. 15 plus 5 minutes time. I think all presenters are there, right? All 4? Oh, 3 online, 1 will be face to face. Okay. I request the presenter to fix time maximum 20 minutes. Otherwise, lunch will be delayed. Okay. Within, maybe you can announce.
Yeah, we have the first presentation, dynamic response analysis of an offshore wind turbine under seismic loads and vibration-induced shutdown. The presenter is Shubham Kashyap, I guess. It's an online. Yeah.
Can you hear me, sir?
Yeah, you are audible.
Thank you.
Yeah, you can start.
Yeah, so my presentation is dynamic response analysis of an offshore wind turbine under seismic loads and vibration-induced shutdown. So I shall quickly review over some seismic design load cases prescribed by design codes, followed by what happens during an emergency shutdown for an offshore wind turbine, and what are the possible avenues on how the control system can interact with the seismic induced vibrations, and followed by investigation of some case studies which shall hint over a possible shutdown system calibration methodology that could possibly be efficient during seismic operations of wind turbines. So seismic design loads. Seismic design load cases are prescribed by IEC and DNV standards. So the IEC prescribes the combination of seismic loads for during normal power production and during an emergency shutdown. So it is expected that the turbine will have some alarming vibrations, which are going to trigger some shutdown mechanisms or in the wind turbine system. So these are the most latest recommendations by DNV in the respective code, and if you see the design situation, it actually expects that nothing is actually left uninvestigated. So the earthquake is combined with different operating states of the wind turbine. So it expects the earthquake for during a power production, then during a shutdown, and also during a parked in a standing condition. So these load cases actually define 3 different transition states, or you can say 3 different operational states. Both these cases are valid statements. However, the codes still do not provide a guidance on how the shutdown timing shall be assessed for load assessment, for accurately assessing these design loads. So during an emergency shutdown procedure, the blades pitch from its initial position to a fully feathered position, which results in the reversal of the lift force, and it decelerates the rotor. And this actually translates to the global turbine motion, where the turbine is pushed into the wind for a moment as the shutdown procedure takes place. So when we are talking of an earthquake, the earthquake is also expected to occur in conjunction with this transient event. So the control systems of offshore wind turbines, or wind turbines in general, are very proprietary in the industry, and it still lacks a lot of transparency in the research literature. And most of these control systems are open loop safety supervisory measures, which mean that these are pre-programmed and they are preset for certain thresholds and certain behavior of the turbine. So during a seismic event, the abnormal behavior can be very uncertain, and it is very difficult to assess whether the turbine shut down due to the seismic vibration or due to an altered state of a turbine, which led to the triggering of a safety system measure. So, as far as the seismic case is considered, the code recommends that the shutdown should be initiated during the strong ground motion part of the earthquake signal. So, this is an important statement with regard to load assessment and the design of the calibration system or design of the shutdown system, because the earthquake in general is a very uncertain event. We do not know the magnitude, duration, and the type of and the frequency content to effectively assess the strong ground motion part of the signal. So if we like look back to the design load cases, we can appreciate that they have sort of considered a very conservative combination of seismic loads and the shutdown loads in their seismic load evaluations. However, I was intrigued and I was interested in exploring this aspect of whether this scenario of combination of earthquake and a shutdown is actually realistic enough with regard to certain sensors. So, what happens during an earthquake induced shutdown scenario? What can possibly ideally happen? So, the turbine is equipped with certain monitoring sensors. Usually, it is very usual to find thresholds for nasal acceleration sensor, which is updated regularly with the obtained SCADA data. And as soon as some threshold is detected or some functional abnormality is detected, the safety system it uh, it overrides the normal operation, and pushes the remedial actuator commands for a shutdown to occur. So if you see the bottom figure, the turbine is expected to operate normally, and suddenly the earthquake occurs, and we expect a detection delay. So the detection delay is actually the time that it takes for the turbine to, you know, feel the abnormality in its operation, and as soon as it's detected and a command is thrown by the safety system, the emergency shutdown procedure begins. And all this while the earthquake is still gradually passing as the turbine operates. So if you see this figure, it actually appreciates the codal recommendations where the turbine actually transitions between three different operational states of its intended life. So there is still some lack of operational realism to assess the shutdown efficacy with regard to earthquake, as there are no set objectives prescribed in the code books or in the literature that certifies that a shutdown should perform a certain task of providing safety to certain components or the operation in general. So so I summarized a bit on detection delay and the contingency action duration. So the contingency action duration is the emergency shutdown procedure that happens, which is a blade to pitch feather shutdown in the turbines. So the detection delay will actually be dependent on the sensor sensitivity and the threshold that is set using the SCADA system for the wind turbines. So, and it is also the earthquake characteristics can also play a major role in effectively knowing the detection time. Further, the contingency action duration is with respect to the maximum allowable seismic response that can be that the turbine can sustain. So contingency action duration is actually very difficult to assess for wind turbines with regard to earthquakes, since earthquake is a non-stationary process, and we do not have a regular pattern to predict its occurrence, unlike some other events. So the objective set for the present study was to understand the efficacy for the nominal thresholds for emergency shutdown during seismic events. So it is very common that the reference turbines that are used in the literature, such as NREL 5 megawatt turbine, they are assessed with nominal acceleration thresholds of 1 meter per second square and 2 meter per second square. So we investigate these thresholds with regard to nasal, foreaft, and side-to-side sensors to understand the loading that the turbine has in different components during the detection delay and during the emergency shutdown, to bifurcate which which part of the transition is actually more critical to review in the load assessment procedure. So we utilize the modified fast version 7 code for seismic coupled seismic simulations with wind and waves. And the advantage of using such an integrated analysis tool is that we can implement our uh, own thresholds in this integrated setup. So as mentioned, I utilize a NREL 5 megawatt wind turbine for the studies. And for the emergency shutdown procedure, the pitch rate of the blades is set to 8 degrees per second, which is recommended for the chosen turbine. And the choice of earthquake for the present investigation is the Iwate Japan event. And I chose this earthquake for the sole reason that it had a very high frequency content in the that focused on the tower's first natural frequency of 0.28 hertz. So I postulated five load cases, which for load case 1 we just let the turbine operate normally. For load case 2 we had a shutdown with the nasal foreaft acceleration sensor with 1 meter per second square. Similarly, for 2 meter per second square for nasal foreaft sensors. Similarly, we have two similar combination of thresholds with nasal side to side acceleration sensors. And the values of wind and wave were chosen to be near the rated wind speed. And I utilized uniform wind and regular waves for the present investigation to just see what is happening in the system. So the bottom plot actually shows the Arias intensity. So the Arias intensity shows the gradual increase of energy in the earthquake signal with respect to time. And the vertical lines are the different time instances when the shutdown crosses the respective thresholds. So as we can observe, different sensors and different thresholds would have put a shutdown at different times. So when I said the shutdown is put at different times, I want to emphasize on the fact that the turbine itself has a different altered state at each instant due to the passage of the earthquake itself and due to the rotation of the blades. In addition, the combination of wind and waves can also play some role in making this more complex. However, the choice is always between whether we want to choose a higher threshold or a smaller threshold. So a smaller threshold is basically mitigating our risk in a way, and a higher threshold is making our designs more economical and more efficient in terms of increasing the operable hours of the turbine. So I want these results to be viewed with this perspective. And if we see using that, we can see the different time instant. So this is the detection delay that was taken from the earthquake simulations. So if we see the side to side sensors are indicating that the shutdown would have uh, occurred faster. So the earthquake would have been detected by side to side nasal sensors much quicker. And this is primarily due to the spinning of the rotor, which induces aerodynamic damping in the fore-aft direction. So while the turbine is spinning, it is actually providing additional damping to the system when the earthquake occurs, which results in delayed signal recognition or delayed earthquake detection. However, if we see for a higher threshold, the fore-aft nasal sensor has has an earthquake triggered shutdown at 63 seconds after the occurrence of earthquake, whereas the maximum allowable seismic response occurs at 67 seconds. So this duration, this almost a 4-second duration, is very short for the earthquake to be successfully mitigated by a shutdown operation, because the turbines usually have a shutdown duration of 10.8 seconds for the chosen pitch rate. So we can appreciate here how a proper
Shubham, your
calibration of this
time is up.
shutdown
You try
system.
to quickly wrap up.
Sure, sir. Okay. So I compare some Fourier transforms for different turbine for different load cases, and I observe that the wave loads do not couple pretty well with they do not pose any such problem in this scenario. And it is actually the operational modes of the wind turbine, such as the 3P and 3P load, which combines with the turbine during seismic operation. So so when we put a shutdown, what we actually do is we push more amount of energy to the first natural frequency of the system by shutting down the rotors, and this actually reduces the fore-aft tower base bending moment by a factor of 1.71, and it reduces the nasal displacement by a factor of 1.69. So the shutdown in general and plays a good role in mitigating some of the loads and displacement restrictions. So followed by this, I we the sensitivity of the emergency shutdown can be assessed can be more critical in terms of the initial conditions at which the shutdown is initiated, because as the earthquake passes, the earthquake energy grows, and it is expected that the turbine's response would become more hazardous in nature as the earthquake passes. So waiting for the higher threshold to put a shutdown may actually push the turbine in a more difficult state to be more in a more stressed state for a shutdown activity. Which so in this case, as it is highlighted, so the detection delay duration and the shutdown duration loads are segregated, and as we observe that the detection delay the detection delay is actually for a higher threshold would impose higher load factors, because yeah, as we wait longer, the seismic energy has grown into the system, and it is pushing the turbine to more displacement, more stresses, and which is seen in the detection delay. Similarly, the shutdown duration also, we can see if we wait for a longer duration for a higher threshold, the shutdown itself can become a very problematic scenario for the turbine, where these seismic loads, where the shutdown loads can be as high as 1.5 times the maximum seismic loads that would have occurred without any shutdown. And so side to side nasal sensor acceleration, side to
Shubham,
side nasal acceleration.
I think your time is up. We need to take some questions from. If you can just conclude your presentation, it's better.
Yes, sir. So a decision for the best shutdown system actually depends on what sort of where we are expecting more errors, or rather we can say like where we can manage more stresses in our system. So if we refer the paper, there are a few arguments on how to select the best shutdown system or postulate some criteria. And we have further worked on developing a metric which would actually give more control to the designer for load assessment, for initiating shutdown with certain surety and control in the simulations. So yeah, so that's all for my presentation.
Thank you, Shubham. We'll take one question from the attendees. If you have any question, please ask. Okay, then we'll conclude. Give him a round of applause. Thank you, Shubham.
Thank you, sir.
Okay, we'll go to the next presentation. The next presentation is development of a digital twin module for digital healthcare engineering in aging monopile type offshore wind turbines under combined environmental and operational conditions. The presenting author is Abdul Aziz Sindhi, I guess, if I have correctly pronounced your name.
Yes, that's correct. Can you hear me, or is it clear?
Yeah, can you hear us?
Yeah.
So you are Mr. Abdul Aziz Sindhi?
Yes, that's correct.
Okay, so you have 15 minutes of time. Try to stick within the time limits. And yeah, please start the presentation.
Fantastic. Okay. So I'm going to talk about the development of a digital twin module for digital healthcare engineering in aging monopile type offshore wind turbines under combined environmental and operational conditions. To give a little background on this study, the importance of offshore wind turbines in the industry is undisputed. It is the most important energy source, especially when we're talking about renewable energies. They're set to overtake all sources of energy by 2025. And in particular, the monopile type offshore wind turbine comprises around 62% of the existing offshore wind turbines. They're subjected to a harsh environment as well as degradation, which causes damage over time and lowers their life expectancy. This prompted the development of a digital healthcare engineering system to monitor their life and to ensure their safety as they're operating in the ocean. So in this study, we'll be detailing the steps we took to develop the digital twin module within the digital healthcare engineering system. And by now, you might be wondering, what is a digital healthcare engineering system? So a quick overview of this, it's a digitalization system that has 5 key modules. Module number 1 being in situ monitoring of health parameters that includes ocean environmental conditions such as wind and wave profiles, as well as in-service damages that occur to the structure, that is corrosion, wastage fatigue, and mechanical denting, some of the more prominent in-service damages. This data is then transmitted via Wi-Fi, like fiber optic cables or close orbit satellite, depending on the location of the wind turbine and if there is access to Wi-Fi. And then that is then received by a data analytics center to process simulations as well as to diagnose via AI and predict health outcomes of the offshore wind turbine. And as I've discussed, we'll be talking about, in particular, Module 3, the development of Module 3 in this study for data analytics using digital twins. This module employs high-fidelity CFD as well as nonlinear finite element analysis to calculate both operational loads and load effects on the structure. Of course, these models solve the moment of continuity equations as well as volume of fluid, fifth order Stokes, and shear transport to simulate the ocean environment and FEA formulations. The digital twin module follows 7 steps to realize the digital twin, and it starts by geometrical modeling of the offshore wind turbine components with the blades, nacelle, tower, transition piece, and grouted connection and monopile. The CFD component of the digital twin is established afterwards, where the wave loads as well as wind and all the different environmental and operational aspects of the simulation are, of course, validated to ensure that the simulation represents real life, as well as the nonlinear finite element component. And here I can also note that in-service damages are modeled into the structure. For corrosion, the thickness is reduced, and for fatigue cracking, an opening is represented by the crack, and for mechanical denting, the elements are indented with the respective measurements of those in-service damages. And then loads are transferred from CFD onto nonlinear FEA to compute load effect and structural responses. A sensitivity analysis was conducted for wind, wave, current, rotor, and the combined effect loads in order to assess the importance of each and whether any are negligible, or how could they be taken into account and represent as much as we can into the model without comprising any of the computational efficiency, since the system should be running at the most efficient timing. That's transferred onto the FEA, as I mentioned earlier, to compute the structural responses and load effects. And our sensitivity analysis that while, for example, we have wind and wave loads having significant force on the structure, when combined, we find that this load is significantly amplified by this peak point shown in the graph on the left-hand side. And this is due to them influencing each other and the interactive effects of these loads together, such as a breaking wave, if you can imagine it here. This is the exact peak point where the structure underwent the most amount of force. And the structural responses, as we can see on the right-hand side, are also significant for combined effects, as expected as well. And so these simulations operate at a sub 1 hour efficiency. This means that CFD is simulated within 46 minutes, and nonlinear FEA is simulated within 7 minutes, around 7 minutes. This allows us to stay within the monitoring limits of ocean events. So, for example, you would have, as shown in the animation here in the bottom, is that data is usually averaged over an hour period for real-time monitoring, and the current system, it's automated, allows us to assess the offshore wind turbine with the incoming data without delay, for lack of better words. So in conclusion, the digital twin module that was integrated offers a comprehensive performance assessment. This module is key for enhancing accuracy and monitoring in aging monopile type offshore wind turbines, especially given since that the industry has not seen a fully realized digital twin within this scale up to date. So this is a significant improvement to existing technologies. And in terms of the sensitivity analysis that showed us that the combined effects of wind waves, current and rotor blade rotation results significantly amplify the loads and deflections and bending moments as well in comparison to the scenarios where they're in isolation. So none of them we can say are negligible. And modeling these forces collectively better simulates real-life scenarios. This improves the health assessment. So we can deduce from this study that the digital healthcare engineering system it's integral for the system to employ these environmental and operational effects all in one scenario. These models are high fidelity models, so they're not reduced or anything like this, and they're conducted within less than 1 hour, which makes it possible to employ into current monitoring systems for offshore wind turbines. And by integrating this approach, we can safely say that it's a reliable means of monitoring for offshore wind turbines. And this makes this digital health engineering system a progressive real-time monitoring system. For current work detailed, the module 3 of the digital healthcare engineering system. And in previous work, we've also detailed the methods of predicting health outcomes of the offshore wind turbines. And of course, moving forward, the logical sequence would be to show how we measure and transmit this data, as well as how we diagnose using AI these simulations, as well as any other health parameters that are involved in the algorithm. Thank you.
Thank you very much for a good presentation. Now we will take some question and answers from the audience.
Hello, good morning. This is Professor Atul Banik. Actually, I want to know that you have done the only simulation work or also experimental work you have done?
The experimental work has not been detailed in this particular study, but experimental work has been done already in terms of physical testing of the measuring data. So in terms of module 1 of the digital healthcare engineering system, that's been done, but we're working on publishing this paper at the moment and detailing our technical report on it.
Okay. Now, if I understand, if you are doing the simulation work, then this data, whatever the data you are using from the experimental one, so you have taken also the soil condition, right? And the bed conditions.
Soil hasn't been taken into account, and we showed this in our validation that we can safely say that in terms of structural response, on the grand scheme of things, it's almost negligible at its aging in its aging life when it comes to assessing the load bearing capacity in particular things like the bending moment as well as the deflection, which is what we're interested in, the overall health of the offshore wind turbines. Of course, when it comes to more nuanced simulations and more detailed simulations, soil must be monitored. But for our particular system, when it comes to assessing things that are more gradual and in terms of aging, it doesn't seem to have that big of an influence on the results, as also shown in the validation process. And the other part of your question, can you repeat that again? Sorry.
Now, I'm trying to understand that if you have taken the soil structure interaction first, second, you have taken the wave interactions, then you have taken the aerodynamic interactions. Now, even the condition of the blades, if you, as you are saying that on the operational conditions, if you are taking all those things, or you are, if I say that no, you are considering some part of the simulation, but other things you are considering whatever the data are available as in you have just collected from the literature, or you have taken everything while simulating the entire behavior of the structures. Yeah.
Yes, so all these parameters are measured. Operational parameters such as the rotation speed of the offshore wind turbines blades, those are measured. Winds and waves and current, these are all measured in real time. We didn't detail how we measure these in this report, but we will in the future study. This is all data that we must measure in real time. There's no way around it. Each offshore wind turbine has its own unique scenario, and this is important to highlight. Of course, representative values can be taken just for an illustrative example, but that's definitely not how the system operates. It operates in real time with monitoring a system such as, for example, here a wave buoy or a wave radar system to measure these parameters. For soil, as I've mentioned, we have not taken that into account in our simulation model. A simulation model literally simulates these environmental conditions that we measured there on the site in real time.
Okay, thank you.
Okay, thank you very much. Yeah. Now we'll move to the next presenter. So the next topic is ultimate capacity experiment for containment system of LNG cargo under compression load along normal direction. Who is the presenting author? Is it Shi Gaiji?
Thank you. Thank you for your instruction. Could you stop the PPT, the previous PPT, stop this one? The last share, the presentation, can you stop this one? Oh, thank you.
Yeah, it's okay.
Yeah, good afternoon, everyone. I am Shi Guijie from Shanghai Jiao Tong University. The topic is the ultimate capacity experiments for containment system of LNG cargo and compression loads along the normal direction. The contents include 5 sections. Sorry, this one. Containment system in LNG cargo holds. Mark III containment system has been recognized in the shipbuilding market of LNG carriers. There are several layers of different materials for the Mark III containment system. The shipyard arrange containment system models for steel-built LNG tanks. When working at the elevated location on the tank, scaffolding is required at a spot. The bottom end of the scaffold acts directly on the surface of the containment system. Any damage to the containment system caused by the scaffold, it should be avoided. So, what's the actual capacity of a containment system and compression? This presentation tries to answer this question. The experimental facility experimental model of the containment system. Standard module of containment system of length, width, and height is about 340 multiplied 340 multiplied 400 millimeters. Experimental model consists of corrugated plates, top plywood, primary insulation, secondary barrier, secondary insulation, bottom plywood, inner hull, and written rope. Surface, side surface named Surface 1, Surface 2, Surface 3, and Surface 4. Two models are fabricated, named Model 1 and Model 2. Experimental facility to apply the vertical load. The actuator fixed to the beam of the reaction frame. The actuator has a max load capacity of 200 tons. The experimental model is aligned with the actuator center position. The wooden block, 250 multiplied 280 multiplied 200 millimeters is placed on the top of the experimental model. This is the experimental model. The foundation is made of high-strength steel. Displacement sensors are arranged beside the experimental model. Strain gauge arrangement on the plywood. Totally, there are 12 strain gauges named W1 to W12. W1 to W3 and W4 to W6 are fixed to the side surface of the plywood. W11 and W12 are fixed to the upper surface of the plywood. W7 to W10 are fixed below the lower surface of the plywood. Here is the location and the coordination for all the strain gauges. Surface strain measured by a 3D DIC system. Two cameras, camera 1 and camera 2, are used. Two cameras have a resolution of 12 million pixels, 1% pixel accuracy, and 2 FPS. These two cameras are placed 1 meter away in front of the measured surface 1. Speckle patterns are prefabricated on the primary and the secondary insulation. Speckle areas about 340 multiplied 400 millimeters. Each speckle pattern occupies more than 3 pixels. Experiment procedure. The experimental model is fixed on the foundation. The displacement sensors, strain gauges, and DIC cameras are connected to the acquisition instrument. The load is applied vertically downward by the actuator and the wood block, 2 tons per minute. The experiment is finished when the model exhibits a clear damage. The experiment results analysis. This slide shows the load displacement curve of the experimental models. The two curves are obtained in general agreement for both models. First, there is the the trend when the applied load is small. Then there's a non-linear change as the applied load increase. At last or finally, there is when the applied load remains almost constant, the deformation increased fast, or there is a rapid increase. So there are three stages. For this load, 0.35 ampere. This is the max pressure during the construction stage. The elastic limit is corresponds the max loads in the linear stage. So the elastic limited load is about 122. The critical failure state is defined like this. The deformation starts to increase rapidly at the point of max curvature of the curve. So the critical failure loads for these two models is about 162. The elastic limit, at the elastic limit, the deformation is about 4.4 millimeters. The rigid deformation after the unloading, there's about 9.5. So the ratio of the rigid deformation and the max deformation is about the 62%. This slide shows the structural deformation of experimental models. The top plywood bend downward. The primary and secondary insulation compressed. The bottom plywood slide bent. For the secondary insulation, there's locally fold and convex outwards deformation. This slide shows the strain contour of the insulation by the 3D DIC. In the head direction or the second direction, the strain is not uniform. High strain as the secondary barrier due to its high modulus. Strain concentration at the insulation above the resin rope. So the failure of the insulation is mainly due to the stress concentration about the resin rope support. The similar strain distribution for Model 1 and Model 2. This slide shows the strain variation of the plywood by the strain gauges. For the bottom plywood, here, the bottom plywood, there's a linear change of the strain variation at the plywood. That means the bottom plywood is intact during the whole experiment procedure. Top plywood presents sudden change of strain variation as the increase of the applied load. So there's some structural damage on the top plywood. The top plywood failure is mainly due to the stress concentration at the contact corner here, contact corner of the wood block. The general consistent strain result for Model 2. The ultimate capacity evaluation. Allowable strain for the insulation and the plywood is chosen from the classification society such as ABS and the DNV. The allowable strain for the insulation is about 18,500. The allowable strain for the plywood is about 4,500. This table summarizes the max strain for the two models. All the strain values at the max pressure during the construction stage, that is 0.35 ampere, all the strain values are lower than the allowable strain. Here is the max strain, this the allowable strain. The strain on the insulation is greater than that on the plywood. The max strain location at the secondary insulation is above the running loop. So this condition is the max pressure at the construction stage. This slide shows the strain results at the elastic limit load. The plywood strain is well below the allowable strain at the elastic limit load. The strain value of the insulation is close to its allowable strain. It's 12,900. Allowable strain is 80,500. So the non-linear change in the load displacement curve is mainly due to the insulation failure. Failure sequence of the experiment models is summarized as this. The top plywood first bend, then the secondary insulation and the compression presents failure. The ultimate capacity of the containment system and the compression is about 169 kilonewtons, which is higher than the elastic limit load, but lower than the critical failure loads. A sufficient safety factor should be defined further to deal with the unconsidered factors in the experiment, such as non-uniform compression due to the unevenness of the wood block, non-uniform loading, and each member of the scaffolds. Conclusions. The load and the displacement curves obtained by the two experimental models have basically the same shape. As the load increases, there's a regime of rapid increase in the deformation. When the applied loads reach the max pressure of 0.35 MPa and the construction, the strain is all smaller than the allowable strain. At the limited state, the ultimate capacity is about 2.1 MPa. At the elastic limited state, the vertical deformation of the models is about 4.3 to 4.6 millimeters. The average ratio of the radial deformation after unloading to the max deformation is about 62%. According to the allowable strain in the classification society, the failure of the containment system basically began at the top plywood, and then the secondary insulation reached the allowable strain. Plywood bending deformation and the insulation compression deformation occurs in the experiments and the compression load, but no cracks appear. That's all. Thank you. Thank you for your attention.
Thank you very much, Shi. So we will take a few questions from the attendees. Okay, I think, there are no questions, so we can conclude this. Give him a round of applause.
Thank you.
Thank you. So we'll go to the last presentation of this session. And the last topic of the presentation is experimental investigations on hydrodynamic loads of a jacket structure with anodes. The presenting author is Professor Paneerselvam. Are you presenting? Okay. Yeah.
Good afternoon. So incidentally, the organizer is presenting at the last, so this will be the last presentation. And so it is the work carried out by one of the students under me a couple of years ago. So I have asked her to come and present online, but it was towards the end I'm being forced to present to complete the process. I'll briefly present what the work is about. And it is experimental investigations on hydrodynamic loads of a jacket structure with anodes. So most of you have seen the jacket structure, and the anodes, sacrificial anodes, are being placed on the jacket so that to reduce the corrosion process. And these anodes are large in numbers, and therefore they're attached at different braces, cords on the jacket. And these are called appurtenances, and you know what are appurtenances means. Appurtenances are attachments on the jacket structure which are essential for the function of the jacket structure but will not add strength to the jacket structure. And these are called as appurtenances. And when we add these anodes to the jacket structure, the investigation is that what is the increase in wave load because of the attachment of the jacket structure. So that is the investigation goal. So the research gap is already, this jacket structure and design is well known, but what is the design process and what is the increase in load is all empirical in nature. And so there was a step towards this to quantify how much will be the increase in load. And of course, there should be a lot of experiments before we quantify what is that number. But this is the first of the experiments on a whole jacket structure. So I will just go through what the work done. So jacket platforms were fitted with anodes, and you know it is meant for corrosion inhibition or corrosion reduction. And this, any attachments is going to increase the drag, therefore anodes increase the hydrodynamic loads on the jacket. Now the design process in the industry is to account for increase in wave loads due to anodes by multiplying the wave load on a bare jacket, whatever the hydrodynamic loads that is coming experienced by a bare jacket is just multiplied by a global factor and based on arbitrary thumb rules. Now in this study, the increase in wave loads due to presence of anodes on a jacket structure and subjected to regular waves as well as irregular waves as being evaluated using a model test. So the research gap is no attempt has been made to study the effect of anodes on hydrodynamic loads experimentally on a whole jacket structure. There are experiments done partly by attaching these anodes on a part of a cord or a brace, and then they try to evaluate the additional drag that is experienced because of the attachment of these anodes. So to evaluate the increase in wave loads due to presence of anodes on a jacket structure and in the presence of regular and random waves. Therefore, experiments were conducted on a bare jacket, that is a jacket without anodes, and then measured the forces, and then repeat the process by fitting the jacket with anodes and again measuring the forces, of course for regular waves, random waves, including the taking into the account of wave directionality. So this is the jacket. So a representative jacket was chosen, and the water depth considered was 49 meters in prototype. The total height of the jacket is 63 meters, and the other details are given here. 1:20 scale of the model was fabricated, and then subjected to regular wave and random wave tests. So the anode details are given in the figure. And it is, the jacket is like a cantilever, therefore Force can be measured by attaching appropriate transducers. A force transducers was used to measure the forces on the jacket, and we have to know what are the waves that is being it is subjected to. So these are measured by means of wave gauges. So this is the experimental setup. Experiments these were conducted in Department of Ocean Engineering. So we have a facility here. So so these were kept in the wave basin, which is 30 meter by 30 meter square, and the water depth was 2.8 meters. And we have a frame from which the jacket model was suspended, and it is placed 13 meters from the wave maker. And then there are two wave preps that is kept so that one can measure the undisturbed wave. The other one is placed right at the right of the model. Now these are the details that shows the details of fabrication of the jacket, the closer view of the anodes, and how it was hung from the frame, and the complete setup. All the photographs depicts the different phases that was involved in carrying out the experiment of jacket. So remember, this has to be conducted in two cases, one with a bare jacket, and then other one with the jacket fitted with anodes, which is a scaled model of 1:20. The fruit scaling is adopted as usual for all the fixed structures. So the waves, bare jacket and jacket with the anodes. So the wave directions also considered into account, and basically for three directions, 0 degrees, 45 degrees, and 90 degrees. And the prototype wave, the model wave heights are 10 centimeters and 15 centimeters, and time periods considered are 1, 2, and 3 seconds. And we had a Pearson-Moskowitz spectrum for irregular or random waves with a significant wave height of 0.15 meters and a peak period of 3 meters. So all we have to do is subject this model to these regular waves and measure these forces. So for regular waves, so all we have to calculate the statistics and the significant wave height, and also the significant force amplitude from the irregular time series has been evaluated. And of course, we can calculate the RAOs using the spectral density of the forces and the spectral density of the water surface elevation, just in case you want to calculate the responses for any other spectrum. So these are the regular waves that was generated for different wave heights and different wave periods. And these are the corresponding time series that was measured for the bare jacket as well as for the jacket fitted with anodes. So the bare jacket is shown on the left-hand side, and the jacket with anodes, the forces measured are shown on the right-hand side. So for regular waves, the increase was a bit less only. So this table gives the results of the bare jacket experiments. The forces measured on a bare jacket as well as a jacket fitted with anodes. So you can see the increase was only marginal, and you can see there is a 3% increase for the case of the 15 centimeter wave height and 2 centimeters to 2 seconds wave period. So maximum of experimental force of 86 newtons is recorded on the bare jacket for a wave height of 0.15 meters and period 2 seconds. Now for the jacket with anode, this was about 89 newtons. So there is a 3% increase. Now for the random waves, so we have to compare the spectral density of the forces for the bare jacket as well as the jacket fixed with anodes. The last row, please. Last row. For the jacket fitted with anodes, so these are the comparisons of the spectral density of the forces. And here we can see a significant difference between the spectral density of the forces between these two. And you can calculate the area under the curve to get the value of the significant amplitude or the significant forces. And we can see the differences. And the random waves, significant force due to random waves. So you can see for different directions, 0 degree, 45, 90 degrees, it is 56 newtons versus a significant increase with the anodes is 66 newtons. And for 45 degrees, it is 59 versus 69. And for 90 degrees, it is 63 versus 73. So you can see the maximum significant force is observed when bare jacket or jacket with anodes is subjected to random waves of 90 degrees, and then the maximum of 17%. And 15.64 from the time series increase is significant force observed when the jacket is oriented at 90 degrees. So from the time series also they were calculated, from the spectrum also calculated, they are close. And the repeatability of the experiments. So they had fewer trials and they were able to consistently obtain values which are acceptable. So from this study, force of the bare jacket and jacket with the anodes is maximum when the jacket is oriented at 90 degrees to the direction of wave approach, followed by 45 degrees and 0 degrees. And for regular waves, the increase in force is about 3%. For random wave study, significant force of the bare jacket and that of the jacket with the anodes is maximum when it is 90 degrees, and a maximum of 17%. And about 16% from the time series, increase in significant forces observed. The waves generated correspond to a maximum wave height of 3 meters and 13.41 seconds for the real Cs. So this is of course for one representative jacket only. So to recommend for a definite number, we have to come up with a lot more experiments for different water depths and different jacket heights, and then we can come to a definite number of percentage of increase contributed by the anodes. Of course, these are specific only. We cannot generalize for all the jacket. So that is the end of my conclusions. Thank you.
Thank you, Professor Paneerselvam. So if anyone is having any questions, they can ask.
For 15-meter wave height, you have scaled it, right?
Yeah, we have scaled it.
Okay.
So 3 meter and 13 meter is a prototype. We have scaled it to 1:20.
Okay. And then the plot I am seeing, if you see the plot, no, before that, I find that you see for the jacket theta 0 degree,
Yes.
with anodes and bare jackets, they are exactly similar. That is what you have said also.
Yes.
Yeah, that's exactly similar.
Yes.
But I used to see for theta 90 degree,
Yes.
what's the difference between with the bare jackets and the jacket with anodes?
That is
I
about,
find here also exactly similar.
now when they measured the values, it is only increased by 3%, not more than that. So it's less. In irregular wave, there is a lot more interactions of drag, not like
this is for the regular waves.
Regular
That's
waves.
right. For the irregular waves, you got the
Max,
mass
yes,
changes.
yes.
Yeah. Yes, yes. Okay, thank you.
If any other questions, I think there is a question on the back. Okay. No. So we'll conclude the session, and once again, thank you, sir.
Thank you very much.
Okay. Thank you very much. Now have lunch.
Thank you, Professor Abdul Samad sir, for joining us as a chair once again. Now I would request Professor Abdul sir to honor our co-chair, Dr. Bitin Ghorai, with a moment of, as a token of gratitude. Okay, so this marks as the end of this session, but before we conclude, I have few important announcements.
delegates who already registered for the technical tour or who is also liking to register, which is scheduled for tomorrow, kindly contact Mr. Narendran for further information and clarification. I would request Mr. Narendran, if he's present here, to stand so that you can just have a look at him. Yeah, please contact him for further information and clarifications. And for the upcoming session, which is scheduled post-lunch from 2:30 p.m., it's scheduled here in the same venue. So now you can kindly join for lunch at the dining hall. Thank you. Good afternoon, everyone. Welcome back. The session will start soon, so I would request you to all kindly switch off your cell phones or at least put them in silence mode. Okay. So I hope you enjoyed the sumptuous lunch that was served. Okay, so now we would like to begin the session with an invited talk. I would like to introduce our esteemed speaker, Mr. Rahul Kanotra. Mr. Rahul Kanotra is the founder and director of Inventosian Technology, a company focused on transitioning to offshore renewable energies. With over a decade of experience in offshore oil and gas industries, Mr. Rahul has gained extensive knowledge in marine and structural engineering, with particular interest to FPSOs, FSPVs, semi-submersibles, to name a few. Mr. Rahul Kanotra has worked as an assistant executive engineer, Marine Division, in ONGC Mumbai, India. He has also worked as a naval architect in McDermott, UAE, McDermott, Houston, Texas. Mr. Rahul holds a master's as well as a bachelor's degree in naval architecture and ocean engineering from IIT Madras. He is also a licensed chartered engineer, Engineering Council, United Kingdom. We welcome you, sir. Your valuable, unwavering contribution to the industry and your valuable insights today will surely enlighten all present here. Please.
Thank you for a very nice introduction. I would like to thank my Prof. Paneer Selvam and all the organizers for inviting me here. Really, I'm glad to be back and giving a talk to all the students. And I hope that through my presentation, you will learn some things. You will learn about the opportunities in our field. I have been a big proponent of naval architects and ocean engineers joining core. I'm an example. So can I? Okay. So how do I? Oh, it's okay. Let me just put it in the presentation. All right. Yeah. This one. Okay. All right. So my talk today is going to be on mooring systems for floating vessels. Anything basically that is floating, it can be a semi-submersible, it can be a floating solar platform, or it can be an offshore wind turbine. So, okay. So in my talk, I'm going to discuss the following topics. First, I'll give you a very general overview of mooring systems. I will go a little bit in deep on the mechanisms of different types of moorings. Then I will talk about the forcing, the environmental forces. Then I will also talk about some projects where we have provided mooring solutions and the challenges we faced. And then I'm going to also talk about mooring tech advancement. Okay, let's see. I think this. So a mooring system basically comprises of a floating body or a collection of bodies interconnected and connected to the seafloor or to a dock or terminals by system of lines that provide restoring force against external loads. In this conference, we've been talking about a lot of floating bodies. So obviously, the floating bodies need to be stationed at one position, and that's usually done using mooring lines. So that's the first point. The second is, to operate in deeper waters, you have drilling rigs, FPSOs, tension leg platforms. They all need to be moved to the seabed. You need to also check the clearances with between different vessels, and you need to check the clearances with the pipelines of mooring systems. So you need to design mooring so that you are not basically crossing any pipelines because it can damage them. You have also offshore unloading and loading operations where you have two ships interconnected with mooring where the operations are being carried out. Primarily, there are two types of moorings. One is taut mooring and the second one is steel catenary type mooring. The main difference I'm going to talk to you about, it's easy to understand from this figure. The taut mooring, usually it's a straight line, and in the catenary mooring, you will see a shape of catenary. I have also put a very simple example of catenary. This is between two poles, a chain. The shape is a curve, mathematical curve, which is called catenary, which is derived from its self-weight. This is exactly the same in catenary type mooring. This is important because the two different systems, the primary difference is how the restoring force mechanism works. You will see here it's a catenary type mooring. So basically it can be chained or it can be heavy wire rope, but what generally the weight per unit length is quite high depending on the chain diameter. So when the floating body moves from one direction to another because of environmental forces, the chain gets lifted up. Obviously you will see this is a catenary pattern, and when the floating body moves in one direction because of environmental forces, the chain will get lifted up. And this is how you generate those restoring forces, because obviously the tendency of this chain is going to be, gravity is going to be pulling it down. And that's the main mechanism where it's going to try to bring it back to the original position. This is an example of taut mooring. Here, the weight of line is not very high, especially for deeper waters where the water depths can be very high as 4,000 feet. Sometimes the weight of the chain is going to be very, very high, and it increases the cost. So there we use a lot of fiber mooring, polyester type ropes. And as you can see, since these ropes are very light, the main mechanism of restoring forces because of its elasticity. So here, if you see, this is the length from anchor to the fair lead. As the floating platform moves in one direction, the chain gets stretched, and there are different stretch elongation curve. For nylon, it can stretch about 15% for 30% of MBL load. Likewise, polyester can stretch up to 8%. So this is basically, you can think of it like a rubber band. You pull it and it wants to come back to its mean position. So the restoring mechanism is not due to the weight, but it's due to the elasticity of the line. And this is very important to design mooring, to understand where you are working and what kind of mooring is going to be suitable for your installation. Let's talk about forces. We know that in our ocean engineering, the main forces are wind, current, and waves. For most practical purposes in mooring design, we can consider wind and current to be constant. It is not always the case. But because the frequency of changing is very high, so unlike waves, the frequency of wave is between 4 to 20, not frequency, the time period of waves is between 4 to 30 seconds, and which falls in the natural frequency of the platform itself or any floating body. So that's why waves are generally modeled as time varying. And now you have to look at one of the most important things in mooring design is the second order drift forces and the second order mean drift forces. The mean drift is, I'm not going to go a lot into the details, but what I'll tell you is the second order mean drift forces are again constant. They can be fully derived from potential theory. And that's why I've put them in this green box, which is static loads. But the second order wave drift forces, their magnitude is very small compared to first order wave forces, but they are very, very important when you are designing mooring system. I've seen many students or, there's a practice, sometimes these forces are ignored. And I will tell you why they are very important, although their magnitude is very small. This is one example of catenary mooring, where you will see how the force mechanism works, considering static and time varying loads. So here you can see a buoy, and there is no environment in this current position. So it is obviously at its mean position. And let's say there is wind and current force coming from left to right. As I said that we can consider wind and current to be static for very practical purposes. So we know that this is going to move to a new mean position. And then let's have waves as well, because you will not have just wind and current. When you have wind, you will have wind generated waves. And what it does is it's going to keep oscillating between this new mean position because of the wave forces. So this is basically the wave frequency oscillation, and this is the mean oscillation from the static forces. I have a simulation as well. This is the one which we did for our project. Here you can see how when the waves are being applied in the time domain simulation, how the platform is moving to one direction. It's moving about this mean point. And like I was telling you, this is a catenary type mooring. This is a 28 mm chain. As you see the forces in this direction, the chain gets lifted at this point, and this chain is almost slack. So this is just a simulation to make you understand how the mooring system works when you have time varying and static forces. I just want to say you one more thing here, that you can consider this as an inverted pendulum, right? This is very important concept you have to understand, because the mooring system will have its own restoring force, right? Because once the mooring is in mean position, it is going to oscillate about it. And it's very easy to calculate the natural period of that mooring system, which is just the same equations which you use for any first order vibration system. So you can consider it that. Now, we all understand resonance, right? If the forcing frequency is close to the natural frequency of the system, you are going to see amplification. And this is what happens with primarily catenary type mooring systems, where you have the natural period generally falls in about 1 minute to 2 minutes. It can even be like more than 50 seconds, basically from 50 to 400 seconds. We know that there are no waves with that period, right? So then why do we need to worry about that? The reason for that is because you have the second order wave drift forces. The magnitude is very small, but they are forcing it at the same frequency, which is, if you consider in time period, their time period is about more than 60 seconds. So then, this is the reason why you can have like large oscillations. And this is why it is very important to consider the effect of second order drift forces. So here is a curve. Here is just a curve which I have shown you. This is a 8-point mooring system. This is all catenary mooring on a barge. And if you look at it, you have on the x-axis you have time, and on the y-axis you have force, or it can also be displacement, surge, sway in the direction of environment. But you see how the forces are varying. So there is very small oscillations and there is one big oscillation, right? So this you will generally see when you do a time domain analysis and when you are calculating the second order drift forces as well as the wave forces and looking at the response of the structure. So these are the wave forces. These are in the frequency range of the wave, and these are the second order wave forces. This can be usually 3, 4, 5, 10 seconds depending on what your waves are in that sea. And these will be usually 30, 40, 50, 60 seconds. So this is a very typical curve. I have seen what people miss out on is this one, which is very important to consider because they do not consider the second order forces for when they're analyzing mooring. I'll give you some examples now of different types of moorings, and where we have also designed shoreside mooring and mooring for floating solar and the challenges. This is one of the projects in Middle East where we were given a task to design mooring for a circular FPSO. And the challenge here was that because of this circular shape, you do not have the same fenders which will fit next to the jetty. So we had to, the client had a spacer barge in between the FPSO and jetty, and then we had to do a multi-body mooring analysis. You can see this is a model in the numerical software, and this is the final installation. It feels very good when you see your final installation coming to flotation. This is picture from Google Maps. I have, let's see. I have the simulation as well. Here you will see that these mooring lines are almost taut, and this is because that's what usually the shoreside mooring will be, where you will be connecting it with polyester or nylon rope. You need to do a dynamic analysis to see the response of both FPSO as well as the spacer barge, and you need to calculate what are going to be the maximum loads on each mooring line so that you can size all the mooring components. Moving forward, I wanted to introduce this topic, floating solar, because here the mooring is very complex. There are many challenges. One of the major challenges is that a floating solar farm, usually a floating solar island, it is made up of HDPE floaters. So basically it is very different in terms of its structural capacity from a steel barge. That's the reason why you need to have like many mooring lines to moor it, because obviously in steel barge you will have the holding points which will have very high capacity, which is of the order of maybe 200 metric tons. But for a HDPE type floater, the capacity is only of the order of 2 metric tons, so it's very less. So that's why you need to have a large number of mooring lines. Other challenge is that in the sites for FPV are very different. Here you will see a natural reservoir. So basically in natural reservoir you have undulating bathymetry. This is a man-made reservoir where you cannot do anchoring on the bottom, so you have to do anchoring outside the bottom on the periphery. Both are different mooring designs. Another challenge in floating solar is the water level variation. So let's say at high, because most of these reservoirs, depending on the season, the water level is going to vary a lot. I'm working on a site where the water level variation is 50 meters. So you can imagine that at the highest water level, let's say you have taut mooring, and as the water level comes down 50 meters, this whole entire platform is going to come down 50 meters, and then the line will completely be slack, and then it is easily going to move about 20 to 30 meters in one direction. But you need station keeping, and you need to have some, because it's not just the platform, but there are other auxiliary things connected to it. You have the cable where the DC cable which is going to the shore. Similarly, you have transformer barges next to it, so you cannot make it move so much. The solution for this is to have elastic mooring, very elastic mooring, and you have specialized components which I will talk to you about in the later presentation. But this is the kind of motion you will have when you have very slack lines. So this was a study which we were doing for a client where they wanted us to know what will be the maximum excursions when you have the floating platform at the lowest water level. You can see it's moving a lot, and then again due to different line lengths, you will see some lines are getting stressed more than other lines. This is another challenge in floating solar. Wanted to include this slide just to tell you what happens when you design the mooring which is not very symmetric. This was in Japan. This was a big incident which happened where there was a typhoon. It hit this one solar plant, and because it was, again, the reason I was talking to you about was the HDP itself, the structural capacity is very low, and the mooring was very poorly designed, so the structure basically broke into many pieces. Let's talk about another project where we designed mooring for floating solar. Here the challenge was, this is a reservoir in south in Simhadri. This length from here to top to bottom is about 800 meters. The challenge in this reservoir was the client had told us that you cannot place anchors on the sea bed, on the reservoir bed. The reason for that was because they had a HDP liner, and if you put concrete anchors, it is going to basically damage the liner. So we had to come up with a design where we could place the anchors on the bund outside. But then there was another challenge. Because if we have to place anchors outside, then we have to have a platform which is 800 meters in length. But the floating solar plants, as I said, the bigger the plant gets, the higher the loads will be, environmental loads will be, and it does not have the structural capacity. So we came up with a very innovative design where we broke one platform into 10 different pieces, and we ran mooring lines underneath it. I'll show you the video of modeling. Yeah, let's just see. Okay. This is a numerical study which we did. We modeled about 500 lines in a software. We had ran lines underneath the array, and each of the platform was connected through these brittle lines. This kind of design was very innovative. I don't think this has been done anywhere in the world. And the platform was installed in 2021, and I have visited the site, and the mooring is working perfectly. This is another video where you will see the analysis. So here you can see where when the environment is coming from bottom to top, how the whole entire platform moves. This analysis was done in Moses. One important thing to notice, you will see these platforms are moving more compared to these, and that is expected because you can see the length of these lines is much higher compared to these short lines. So as I said, in taut mooring, you get it from elasticity, the restoring forces. So the longer the line, it is more elastic, and that also means it is going to move more, right? So the challenge here was to design this platform such that these do not touch each other throughout the environment acting on it. Moving forward, this is the good view again from Google Earth, where you can see how these 10 platforms are installed. So it's always nice to see projects on your computer and then on Google Earth.
On C-Flex line.
Now, I was talking about the water level variation and how to handle that in floating solar. One of the things is specialized components. Here you can see a component by a company in US, and this is another company in Europe. These components can stretch more than 2 times its own length. So that way you can control the water level variation. Let's go back to this slide. Yeah, for this project now we are working with elastic components, and I'm doing that analysis. But here you can see, let's say, this slack, we can take it off with this elastic component if we have a pretension which is very low at lowest water level, and as it goes up, this gets stretched more than 2 times its length, and it takes care of the entire water level variation.
On C-Flex.
Let's talk about the new advances in the industry. I am very, I think the renewable energy industry is the future. I'm an optimist on that. Floating wind, floating offshore, solar. These are the upcoming technologies. So now the challenge is to design very innovative mooring, because this is not just one platform, but when you have a floating wind farm, you have hundreds of wind turbines, and then that also means that you have many mooring lines. So companies are coming up with very innovative solutions where they are doing this combination of shared mooring, and again taking all the ideas from nature, right? The honeycomb shape is very you can see that in nature, and this is what is being applied in the floating offshore wind industry. The analysis becomes more and more complex. There are other innovative products just to absorb the shock loads. For example, this one, which is patented by TFI Marine, this is a rubber which is going to reduce the peak loads. This is another component which basically, there's a small video which you can see how it, as the platform moves, how it absorbs the peak loads. Other areas where mooring systems are being, more innovative mooring systems are being used are, again, TLPs for wind turbine, but they are kind of hybrid TLPs because they have also a floating, pendulum, which basically offsets the natural period of waves, and the natural period of the platform changes away from the wave natural period range. Another project which we have worked with IIT is a concept where we designed the mooring system for a floater, and this I was working with Professor Paneer Selvam and one of his students. We have also presented the paper in the same conference last year. A very smart student from from previous batch worked on this, and she's right now working in Acre. Let's see. The future right now is, as I said, renewables. People are looking at ways how to combine floating solar and offshore wind. I'm working on a project where there is fixed wind turbines, and then we are placing floating solar farms in between, utilizing the wind turbine itself, because it will have a very strong substructure, which is it's a fixed type, so you can add mooring lines to that and utilize that capacity. Okay, so I'm done almost. I think I'm up for questions. Yeah. Yeah, please, if you have any. Yeah. Yes.
Beyond that, they do not make economic sense. Because essentially what happens is that if you take too much deep water,
Yeah.
and you still go with the mooring line, the payload will start coming down if the structure is floating. And if you do not have the payload, then what actually you can do for? So is there any guideline that up to this depth the mooring lines are economical? After this depth, mooring lines are not economical, then we have to go for dynamic positioning system or some other mechanism.
Yeah, that's a very good question. So basically, that's the reason why they use more of taut mooring in deeper waters. So what they will do is they will have some length of, it's more or less hybrid because the chain is very heavy. So they will have chain plus polyester lines. Polyester does not have a lot of weight. So that's the hybrid type of mooring which is used for those types of depths. Right, so that's what basically, but the polyester line will not have that much weight. It's going to be very less compared to a chain, mooring chain.
Yeah, Rahul, thank you for that nice presentation. Yes, my question is something similar to Professor Raju Sharma, so probably I will skip that question. I will just move on to the last one you were saying, where the current focus is going the combined offshore wind plus these floating solar.
Right.
What about these practical issues? Once you have a wind turbine, you might once you have installed a wind turbine, you might need to visit it either for maintenance and all other things. If you have this floating wind farm around it, or the floating solar farms around it,
Right.
a jack-up barge cannot go into another stuff. How are you looking at these kind of practical aspects? How you could incorporate the maintenance as well into that?
Right. So that is one thing which needs to be considered before the designing the whole system. Then if those are the issues, there are guidelines from offshore industry where you need to maintain certain distance between two floating bodies. DNV says I think it's about 50 meters. That should be the this thing. But again, the wind farm itself, you have a lot of space in between where any
to get the optimized wind, you need to have certain spacing.
Right, and because of the shared system, you are producing more electricity, and then you are using the same cables because those are very expensive, right? So you are enhancing your energy from combining both floating solar and wind.
Yeah, I know. I think there are plenty of discussions even for Indian market. That makes more sense because we have both wind and offshore, and then have plenty of sun or solar power. So
yeah. So this is one project which we are doing in Far East, where they are putting floating solar farm in between 4 wind turbines. This is a pilot. We did already a pilot which was I think 12 kilowatt, but now we are doing it a little bit bigger. And that's the future for India as well, because you have, again, first, if the offshore wind is going to come, that's going to be fixed. And then later, floating. But again, I want to also emphasize that there is a lot of challenges in floating solar offshore because of just the way waves are in this platform. Like I was telling you, if we are using only HTP floaters, they do not have that structural capacity to take very high wave loads, especially for offshore.
Sure. Yeah. Thank you. Yeah. Thanks. Nice presentation again.
Thank you.
Thank you, sir, for such an informative and valuable, engaging presentation. Now, I would kindly request Professor Paneerselvam, sir, to felicitate our guest of honor with a memento as a token of gratitude.
Thank you, sir. Thank you, sir. That's right.
Now I would like to hand over the session to IAHR Council to take it forward from here onwards. Thank you once and all, and have a great day.
Thank you, sir.
Check. As we get ready to begin the session, I request the panelists to take the dais. Good afternoon and a warm welcome to one and all present here. The session that we have now is the Young Professionals Panel Discussion organized by the IAHR Southern India Young Professionals Network, IAHR SIYPN. I take this opportunity to thank the organizers of ICSOS 2024 for this collaboration. On behalf of the IAHR SIYPN, I extend my hearty welcome to the dignitaries on stage who readily agreed to be the panelists for today's panel discussion. I also extend my warm welcome to the organizers and delegates of the conference ICSOS 2024, faculties and students from the Department of Ocean Engineering, IIT Madras, and to all the attendees both offline and online through our live streaming. To begin this session, I now invite Mr. Sridhar Krishnamurthy, President IAHR SIYPN, to brief us about this YPN community and also about this session.
Good afternoon all. Welcome to the panel discussion organized by IAHR SIYPN. The IAHR Southern India Young Professional Networks, IAHR SIYPN, is the regional chapter of International Association for Hydro, Environment, Engineering and Research, dedicated to fostering collaboration among graduate students, early career faculty, and young professionals in this field. The network facilitates knowledge sharing and exchanging experiences in hydro, environment, and engineering and research. It aims to strengthen connections between local chapters and practitioners, researchers, while also encouraging engagement with the broader IAHR community through participation in regional and global congresses. This community was established with myself, Mr. Sridhar Krishnamurthy as President, Mr. Hariram and as Vice President, Mr. Rishikesh D. Kamble as Secretary, and Mr. Vashant as Treasurer. Our team is guided by our advisor, Professor S.A. Sanasiraj. Now, we are excited to host our inaugural event of IAHR Southern India Young Professionals Network panel discussion titled Bridging the Gap Between Ocean Engineering, Hydrology, Water Resources, and Environmental Engineering for a Sustainable Future. The session is chaired by Dr. Sri Parvati Vijay, Assistant Professor in the Department of Civil Engineering, IIT Madras. Welcome, ma'am. Our esteemed panelists for today's discussion are Dr. Murali Gunasekaran, GFT Specialist, Innovation Team, Danfoss, Mr. Satyakiran Raju Alluri, Scientist E, National Center for Coastal Research, NCCR, Ms. Kasturi Nellayarasu, Head of Offshore Wind Structures, KUVI, Mr. Sanjeev Kumar K, Assistant Director to Hydrology Division, CWC, Chennai. Thank you all for graciously accepting our invitation to participate in this discussion. We are keen to hear your insights. On the behalf of IAHR Southern India Young Professional Networks, I warmly welcome everyone to this event. I look forward to hear the engaging and insightful discussion. Thank you all.
Thank you, Sridhar. It's my great honor to introduce the chair of this Young Professionals panel discussion, Dr. Sri Parvati Vijay. Dr. Sri Parvati Vijay is an assistant professor at IIT Madras. She specializes in hydroclimatology and geospatial data science. With a PhD from IISc Bangalore, she focuses on addressing critical water-related issues in changing climate by leveraging the state-of-the-art machine learning and deep learning techniques. She utilizes information from various big data sets. She aims to deliver sustainable solutions that contribute to the mitigation of hydroclimatic extremes and effective water resource management in the changing climate. We welcome you, ma'am, and I request you to lead us into the session. Looking forward to hear from you all.
Yeah, good afternoon all. So thank you for the warm welcome. And also thank you all the panelists for joining us today. So it's kind of like we are kind of completely delighted to have you all here for this insightful discussions. So coming to the panel discussion, I just wanted to give a quick introduction about what we are, okay. Split screen. Okay. So today we are going to have a quick discussion on how to build the gap between ocean engineering, hydrology, water resources, as well as on environmental engineering. So this is very much relevant in the change in the especially in the changing climatic condition, because if you see, we are all working in the common element, that's water, and it's quite a bit changing because of the variability that is induced due to climate change. So in fact, if you are like working on the traditional approach where you are comfortable with working with your own area of interest, this is not going to serve for the future. So we really need to look into the problem with a collaborative approach where we could integrate various disciplines together to come up with various critical solutions. So that's why, in my perspective, this is very much important and it's a topic of discussion for today. So before we start the discussion, I just want you to have a brief introduction about all the panelists. So let me just start with Kasturi Nallai. She is the head of Offshore Wind Structures Covey India Limited. She is a specialist in offshore wind farm foundation with expertise in steel design. And she is a proud alumni of IIT Madras. She completed her master's degree here. She was awarded the prestigious Pratibha Eaton Excellence Award in 2019 for her excellence. Thank you for joining us here. Next, I would like to extend my warm welcome to Dr. Murali Kunashegaran. He is the CFD Specialist Innovation Team at DAFOS at Chennai. He is also a proud alumni of IIT Madras, a PhD graduate from here. He is an expert in modeling high-pressure pumps for desalination, zero liquid discharge, and firefighting, optimizing cavitation performance, and developing CFD guidelines for internal training. Thank you, Dr. Murali, for joining us here. Next, I would like to introduce Sanjeev Kumar K. He is the Assistant Director at the Central Water Commission, Chennai. He is also a proud alumni from IIT Madras. He has completed his Master's in Geotechnical Engineering from Civil Engineering Department. He specializes in hydrometeorological data collection and validation. He manages data for flood forecasting and coastal management systems. Thank you, Sanjeev, for joining us here. Next, we have Sathikiran Raju Alluri. He is a scientist at National Center for Coastal Research. He specializes in coastal and offshore hydrodynamics, shoreline management, and desalination project. He is an MTech graduate from IIT Kanpur. His research excellence is mainly in developing hybrid beach restoration solutions, coastal observation, desalination plants, and flood warning system. He has an expertise in dealing more than 25 consultancy projects. Thank you, Satya, for joining us here. So we have a diverse expertise right now here. So maybe ranging from hydrology, ocean engineering, water resources engineering, as well as environmental engineering. So people who are not aware about what all these domains, I would just like to give a quick introduction about what it is all about. So why we are all here is basically because of the interconnected nature of the water system. We are all, in fact, looking into the same water system at different perspectives. So if we can bring all these together, probably it can come up in a better way, especially in the changing climatic condition. So we hydrologists, what we do is basically we try to understand the science behind the water system. How is its formulations or occurrences, distributions, as well as how its properties are changing with respect to its movement from atmosphere to the Earth's surface. And a water resource engineer, he deals with the planning, development, management, and conservation of water resources. So basically, in the management aspect, they try to come up with solutions of how to probably come up with a better mitigation strategy to eliminate these kind of extreme events. Next, coming to an environmental engineer, they deals with the designing, developing, and managing systems and technologies to ensure safe, sustainable, and effective use of water resources. And finally, an ocean engineer is dealing with the analysis of ocean dynamics for the design and development of marine systems as well as structures. So, as you know, we all are in fact looking into the same problem. So we thought we should in fact work together. I can again give you one more example about how this is getting interconnected. So in the changing climatic condition means it could be mainly because of the natural variability or the anthropogenic forcing, which we really don't know, because that's a very complex situation we hydrologists are facing to anticipate whether an extreme event is due to a natural variability or is it due to a anthropogenic effect. Okay, let's call it as a climate change as of now. So because of this climate change, what's happening is that we are having quite a bit of variability with respect to the atmospheric variations. Because of that, the hydroclimatic variables are kind of having a lot of variability with increase in precipitation, increase in temperature, which is resulting into different type of extreme events like flooding, droughts, etc. So if you look into the problem of floods, we can see that there are a lot of kind of floodings. That is, one is the coastal flooding, which is of high importance for the especially for the ocean engineers and also for us as a hydrologist. So here it's mainly because of the storm surges and the increase in the sea level rises is what is causing such kind of coastal flooding. Apart from that, we also have the fluvial and pluvial flooding, which is nothing but your urban flooding as well as the riverine flooding. That is also a major concern. So here, when you are trying to deal this problem, you have to have that expertise from the atmospheric science part, where you also need to know what is the science behind that, which is with respect to flooding, and also you need to know about how can we actually come up with probably the ocean aspect, that how can we come up with the better offshore structures and etc. And also you should also have a proper planning mechanism where you need to delve these water resources people also. So, and finally, you need to also incorporate the environmental aspect where you need to have a sustainable future. So that's why we need to have an integrated response approach where we have atmospheric science, hydrology, ocean engineering, water resources engineering, and environmental engineering, bringing in a single umbrella where at least the atmospheric engineering people can come up, tell us about how is the variability in climate is changing, like especially in the future, how are the climate changes going to happen with respect to different scenarios. And if this information is available to a hydrologist, they can come up with what are the variability that is occurring in a hydrological cycle and how it is going to impact different extreme events. And if that knowledge is there, then the ocean engineers can actually assess the structural integrity of the offshore facilities and coastal defenses, recommend design, improvements could be made to withstand the changing climatic patterns. And a water resources engineer can come up with better planning strategies, and also an environmental engineer can come up with a sustainable future. Like how do we come up with a sustainable future with incorporating the ecosystem resilience as well as how do you protect our water system as a whole. So that's the reason why we are all here, and let's have a fruitful discussion right now to think about the direction we can possibly collaborate and come up with an effective solution for a better future. So thank you all for joining us here. So I think we can get started off. So I think I can get started from Kasturi. So with your expertise, can you just probably give us an idea about how can we strengthen the synergy between industry and academia to drive innovation and sustainability in an offshore engineering aspect? So,
good afternoon. Nice to meet you all. I'm happy to be here under these circumstances, having learned so much from this institute. Coming to your question, we are in ICSR right now, so it is quite obvious that collaborative research is the key to the synergy between industry and academia. Of course, we also know about curriculum alignment, guest lectures, workshops, and more synergy between industry and academy. But speaking more at a grassroots level, as a research student, the biggest difference that would make is actually internships. Spending some time interning under engineering firms and also having the opportunity to look at the current projects, the challenges that we are facing in the industry right now, and also opportunities and trends that are coming up will give the biggest insight as to the selection of your research topic. Sometimes it doesn't even have to be groundbreaking or something entirely new. You'll find that we are able to find new applications for existing solutions or actually breaking down, transforming complex solutions into simpler empirical ones which can be easily implemented in the industry. So there are a lot of ways to increase the synergy, but at a fundamental level, internships and job experiences in the field give you more insight than you can possibly imagine.
yeah, I truly agree with your aspect with respect to internship. Yes, we do have a lot of gap between the academia as well as the real world problem implications, like how it is going to probably affect. So that gap, I think we should start building it from the internship where students are getting exposed to the real world problems. I do agree with that. So
There's also one more thing to add where as research students, I have been one myself, we tend to focus a lot on the future and how things are going to be, but there must be equal attention on the past and also the present, because the field as it is now is not what it was 10 years ago. Our structures have become so large. We used to design for 4 megawatt turbines having an overall foundation size of 5 meters maybe in diameter, and we have now gone up to 15 megawatt turbines and really large structures. So some of the solutions that have worked in the past need to be looked at again, or we need to innovate the solutions for fixed bottom structures before we also progress on to floating bottom structures. So there must be equal focus on the past, present, and the future.
That's a really nice point you have added to. So yeah, moving on to Mr. Raju, who's an expert in climate. So I would like to have a closer understanding about what are the challenges of integrating natural and engineered solution for coastal protection and how can we actually overcome this?
Yeah, I will address that question. First of all, thanks for the members, committee A for choosing me to be part of this. Before answering this question, I would like to say one example of where all these different disciplines come into collaboration. Actually, from the ministry, we have done a project called as real-time flood warning system for Chennai. So when we developed this, where you are explaining like different forms are there, like hydrology, all these people. If you look at Chennai, first we need to understand the climate, like what kind of rainfalls are anticipated. That was coming from IMD, then IITM Pune, NCMRWF. These are the forms which are doing on that. Then coming to the hydrology part, that was actually done by the IIT Madras itself. Then climate aspects was done from IIT Mumbai also. Then actually how inundation is happening in the urban, especially on the Chennai side, it was looked after IIT Mumbai as well as NCCR. And what happens when the flood comes, if you are having a storm surge or tide on the down level, water will not be going down. So an input is required from the ocean firm also. So if you look, this particular project was funded by NCCR, like Ministry of Earth Sciences, where we have almost all IITs and IISCs working on from the research level. And from Ministry of Earth Sciences, we have different agencies who are working, and finally we were able to develop a product. So if you look at when there is a problem, really problem, like 2015 floods which occurred in Chennai and later in Mumbai, we have developed systems for both the places. When there is a real problem being there, always departments from various are coming together and we are able to do that kind of work. And one more project which I would like to highlight also is one project which I am working is in Kalpsar project, where exactly I'm playing the role of IAHR, like integrating different people. In Kalpsar project, we are actually doing a 60 kilometers long dike along Gulf of Camber, and it is having a 2 kilometers long hydraulic spillway. Apart from that, there is a 16-lane rail and road network over it, and you have irrigation which is going for almost like 10 hectares of land. Apart from that, renewable energy is also part of it. Now, if you look at this kind of projects, when ambitious projects go in India, this project cost almost like 2 lakh crores, which was one of the brainchild from our present Prime Minister Narendra Modi ji. So when DPR has to be made for this kind of projects, we don't have a particular agency who has all these kind of equipped with them, tools equipped with them. So at NCCR, when we took up this project, what we did was we brought all the agencies from all the best agencies. For suppose if you look at the water availability studies, it was done by NIH. Then probable maximum flood, like what is the anticipated flood, how do you design the flood regulator? It was done by IIT Roorkee. Then design of flood regulator was done by Professor B.S. Murthy sir from same IIT Madras. Then what kind of wave climate has to be done? It was done by Professor Murali sir and Sanyas Raj sir from IIT Madras. Then design of dike, it was done by Professor Subhadis from IIT Madras. Again, how much of irrigation has to go? That was done by Gujarat Department. Renewable energy was done by National Institute of Wind Energy. Then overall commercial viability has to be done. That was done by IIM Bangalore. So if you look at, there are some projects, when the large scale projects comes, we have certain kind of entities. My role here was at NCCR, I was trying to integrate all these agencies. Apart from this, we have almost 30 international and national agencies where we are trying to integrate. And right now we have done the DPR for this project, and we have already submitted this project also. So what I would like to say is, like, apart from, to add to whatever you have added, whenever there is a problem or when there is a topic or a project coming, then automatically everyone will align and we are able to do that kind of projects in India as of now. That is what I would like to add. Coming to this particular one on integrating of natural engineering solutions. So right now what happens is, in the coast, from traditionally we have been mostly using stones and all. So people are more inclined to use that. But natural based solutions are not very much used because they are not used to it. So we had some stakeholder meetings with various people on the ground level, like fisheries people and all. When we go to them and explain to them in real with some case studies, they are ready to accept those kind of things. So more than technical thing here, the acceptance of the people is one of the major thing where socioeconomics and social scientists play a major role to convince the people to move from the harder solutions to the hybrid solutions or natural based solutions. Now we are coming up where we are trying to merge both natural as well as hard solutions, come to a hybrid system by taking advantage of both the systems. That is what we are trying to do.
Yeah, so I would like to add on to the point which you've been telling about, that is about the data management. So that's one thing even as a research scholar as well as a faculty right now, I'm finding it a very hard time to actually get the data. So, if you are an experimental person, you get to have an access to some data. But when you are looking into a larger problem, probably you cannot go to the field and get all the data collection. So can we have such more thought process going into for formulating an integrated data management? It is not just about one particular department, let's say water resources department is the only person who are concerned with the data management. Can we bring it all in a integrated umbrella? So that's what I was what is the kind of challenges probably that is coming in when you're coming to an integrated framework? I know I really appreciate the efforts which has been taken up by various agencies, especially this CWC. They are trying to bring a lot of portals where you can have access, but still when as a scholar as well as a faculty, we do have a lot of challenges in that. So what is the exact problem that is in fact hindering this kind of maybe initiatives?
To add to that, actually initially when you see like 10 years down before this, every data was only in the books and all. We never used to have in digital format. Now each ministry, like CWC is having on the water, Ministry of Earth Sciences is having on the ocean, National Institute of Wind Energy is having on the wind. Now right now the latest thing that is happening in the ministries is how to integrate all these into single platform. That initiation was already started 2 years back. But to come out, it may take 2 more years. So what you are anticipating will surely come. It's only time to happen. But right now, all the ministries are having independent databases which they are coming into one particular database where not that particular ministry, anything data happening in India, you will be able to see it, which will come very soon. There is as part of Digital India, this is coming out as part of this.
Yeah, and with respect to the acceptance of the people, yes, I do agree, because once the problem comes, they really understand how much impact it is causing. But after that, many of us forget, like, what is the repercussions that had caused on us. So it's very important to come up with a lot of strategies, probably to make awareness with respect to the people, especially within the data collection itself. Maybe during the time of a flooding, even the whole society itself can actually come up with a lot of data collection, especially with respect to flooding. Like, I knew about one of the initiative that was taken part by the Chennai people. So they tried to formulate a real-time flood monitoring system where any person anywhere can actually record the water level that was there in that location. So that's kind of a massive data collection process, which I found effective. So I think we can think about all these things in a larger perspective. So that's one thing I wanted to add to that. Yeah, so now coming to Mr. Sanjeev, he's a water management policy expert in water management policies. So how can ocean engineering, hydrology and environment engineering contribute to the formulation of comprehensive water resources planning? So can you just pour on some of your insights on that?
Good afternoon all. First of all, I'd like to thank you for inviting me for this panel. Coming to this question, now for us of CWC, we are collecting all the hydrological and hydrometeorological data, all the streams and rivers, and now we started to collect the coastal data also. So like what are the challenges we are facing means we are having a lot of data. We are collecting, we have all the instrumentation, all the streams and we are collecting the ocean data also. We have a lot of data, but we are lacking and we don't have the collaboration, how to use this data and to develop the studies and to prepare some models and forecasting all the things. From nowadays we are learning from fast floods, like for example Chennai flood 2015. We learned and we implemented real-time telemetry stations. So after 2015 we installed a few telemetry stations for dedicatedly for Chennai flood. Around 5 telemetry stations we installed a real-time telemetry station for rainfall and water level. So and we are using this real-time data for flood forecasting and issuing the warning system. So so mainly we are facing main problem is we are having a lot of data, but still we are not able to develop the very accurate models and to forecast the issues like for flood warning system or coastal management system. So like that.
Yeah, so it's clearly indicating the gap between different, even though like it's kind of a contradictory statement though, like we have data but still we don't have the expertise to.
Yes, exactly.
It's mainly because I feel it's the lack of awareness about what others are actually doing, or maybe we should have a more collaborative network which involves all the expertise from different domain, and that's why we are all here today.
Yes.
So I think that gap is still existing, and that's what much evident from what you are experiencing.
Still we are having models, but still we are not able to improve the accuracy because we are improving the model based on our experience, madam. So we are calibrating the model and improving our forecast system, but still we need more research on that and to improve the models.
Yeah, so that's an insightful thought process which you have just shared. So because we really want to bridge this gap, otherwise we cannot have a better future forward, because I at least feel that all these things are interrelated, and if we can actually come up together, probably we can come up with more sophisticated models also. Like when you deal with coastal, we are actually having hydraulic as well as hydrology models which could be in fact assimilated, like with even with the satellite information. So it can even improve the efficiency of all these forecast systems. So I think that's one thing. So coming to Dr. Murali, who's a CFD numerical modeling specialist, can you just tell me how can CFD simulation assist in the design and optimization of renewable energy structures, ensuring maximum efficiency and minimum environmental impact?
Yes. So first of all, I thank these organizing committee members for inviting me. And coming to the question, so how the CFD simulations can enhance the efficiency of renewable energy systems. So actually my PhD thesis on that. So actually I have done a work on optimization of tidal turbines, which can enhance the tidal energy. So that is my PhD work. Now I'm working on energy consumption in industry. So how energy consumption can be reduced in a desalination industry. So coming to the renewable energy systems. So how the CFD simulations can work. So being into the practical aspect, if you take any wind turbine, any wind farm or any solar farms, bioenergy stations, and then geothermal stations, and then hydrokinetic energy stations. So where we should, before commissioning or before starting these stations or these farms, we should know the potential of that site. So how much, say for example, if it is a wind energy, so our wind farm, how much wind potential is there in the particular site, and how much data in the sense like how much velocity and how much speed, all these things we have to simulate, and it is not like a single machine we are going to install. So we are going to install a number of turbines, which is collectively called as a turbine. So we cannot go for an experimental test on first go. So this can be feasible by aiding CFD's tools. So which can give you how much energy you can extract on particular time or particular velocity or particular environmental impacts. And also you can calculate the structural damage of these sites. So this is with respect to wind farms. When you move on to solar farms, so you can simulate the flow and how much heat it can dissipate. So there are plenty of challenges in the solar farms. So a particular time it can emit lot of heats. It will absorb and it will emit the lot of heats on particular time. So you can simulate those things. So at what time we can expect high level of heat emission from the solar panels. And when it comes to geothermal energy stations, before going to commissioning or after identification of this particular station, so we can simulate up to the depth, up to where we can get the natural gases and how much gas we can get. How much gas we can explore from the ground. So these things can be explored using CFD tools without going experimental facilities. So in such a way, like we can improve the efficiency of the system by doing any optimization. Coming back to the wind turbine or solar panel, solar farms, we can do some structural optimization. So if you take a wind turbine, so you can play around the structure shapes of the aerofoils, what it has. So you can modify these aerofoils, or you can add the what is it called, vertex spoilers. If you see, olden days wind turbine and modern days wind turbine, there are variety of changes. Many changes has happened. Because of this CFD tools and optimization, day by day it is getting optimized so that we are getting more energy and more efficient. This is possible in one way with the help of CFD tools. So this is how I can say how it can improve the renewable energy structures or systems. Yeah.
So it's mostly on the site-specific understanding, clearer understanding, and as well as in an economic perspective also, because
it is economic perspective.
Rather than just simply delving into the problem, you can start understanding the problem and then find solutions to that. Exactly. So I think that's a very interesting area, in fact. So coming to Kasturi, I just want to know what is your vision for the future offshore structures in terms of sustainability and environmental integration, and how do you see these fields evolving together in future?
So in order to measure the impact that we have on the environment, the first step is always to measure the impact. And that's a very fundamental step that is sometimes missing depending on which industry you're looking at. So the fundamentals of that starts with carbon dioxide calculations, CO2 calculations, life cycle assessment in order to look at how much you're impacting the environment throughout the phase of the project, not just the project, but also how it's installed, how it's decommissioned, all the different phases. So accurate calculations to understand the impact. And then as structural engineers, we want to do an optimized design, but with less material and also with alternative materials. But one of the ways we can collaborate with other fields is by looking at integrating renewable energy systems into our current project or our current design. From environmental engineering, we can draw a lot of inspiration on alternative materials, coatings, alternative marine habitats, energy storage, waste management actually, and chemical handling. So before we begin looking at the project as a whole, we need to look at the bigger picture and see if we can establish a circular economy, which is where a project is able to feed itself, sustain itself, but also sustain other industries by the products and the sub-products that it makes.
Yes, so I do agree to that. Like we always think about the sustainability aspect only after the problems. I mean, after we have come up with some solution which might not be sustainable like when you talk about sustainability, you are actually looking into the problem after quite long gap. So I think you have to start the concept of sustainability at the grassroots level itself, if I am not wrong. So your grassroots level understanding about what all measures can we bring in with respect to nature-based solutions as well as all the new technologies. I think we can incorporate sustainability in all the aspects in whatever research we are doing, be it ocean engineering, or hydrology, water resource, everywhere we can actually bring in the sustainability component from the grassroots level. That's what I feel we can be incorporating.
And also, sustainability is now a buzzword, everybody uses it, but the fundamental meaning of it is that we are able to secure our future without compromising the future. That is the fundamentals of it. And it is also not just environmental sustainability, there's economic, there's also social sustainability. There are different elements to it. Our mind always jumps to biodiversity when we come to think about sustainability, but there are so many other facets that make up what sustainability actually is.
I think we have to integrate the engineering as well as the probably human aspect, like integration of both the human aspect as well as the engineering aspect has to be brought in together when you're dealing with sustainability. That's one thing I also wanted to add on to that. Next, coming to Mr. Raju, I want to know how can we ensure the coastal protection measures remain effective over the long term, especially as climate change is getting accelerated, especially in the last decades, if we can talk about it.
Yeah, so when you look at this long-term things, so first thing which we need to know is how the climate is. We see that a lot of cyclone frequency has changed a lot these days, and intensity of the cyclones has increased a lot. And we are thinking about the sea level rise, where water level is going to rise. So we need to firstly have an understanding of what could be the anticipated levels this could happen in 50 years, 100 years. If you look at a lot of research happening across the globe, everyone has their own models giving some different random numbers. So if you start designing by taking this into the picture, you may have a lot of uncertainties in the project and you will end up spending a lot of money as of now. So when you look at the long-term thing, you should have something called as adaptive pathway, where your structure, what you construct now, should be able to adapt in the future to change a modification. For suppose I am constructing a seawall where I am saying that the crust level should be at 6 meters as of now, considering the existing system. But if I have a sea level rise of 0.4 meters in the future, 50 years or 40 years down the line, when that particular scenario comes, can I modify my structure with little modification so that it can be made adaptable? This is how we need to think in the direction, rather than thinking what will happen 50 years down the line and construct it as of now. This is more like making our structures adapted to it. And few more things which we also has to look is like especially in the coastal structures, there is one significant factor that is covering, which comes from the geotechnical side. when this covering happens in front of the structures, like in India, you'll see lot of stones and all you have seen in Kerala and all. So what these structures has done is they have started covering in front of that. So what is happening right now is larger waves are coming because of the depths which are in front of the stones. So what we have done is, by not understanding these things in the past, we have done some mistake which is making bigger waves to come onto the coast. That is the reason why you see a lot of flooding happening in Kerala. So these are the areas where we need to focus little more and go to a system where we adapt to the system when the scenario comes and get ourselves prepared now, rather than designing and implementing as of now. This is what we need to do for a long-term strategy.
Yes, I 100% agree with your aspect, because we have n number of global circulation models, regional models, which each one of them gives its own fancy numbers to that. So yeah, as a scientist or as a researcher, what we do is we probably take the average out. We really don't know what is the best or what is not the best unless it gets happened, and you cannot really wait for it to happen to understand the the performance of that model. So the uncertainty aspect with respect to each of these model has to be understood in much detail, because that's where I also started off with. When you deal with the problem, maybe we should start from the atmospheric science part, where we should have the maybe accurate predictions, I can say, but then that's a very challenging aspect which cannot be predicted, mostly because of the anthropogenic activities as well as natural variability. That is not something very quantifiable at this stage. So this uncertainty aspect, I totally agree. So because of this huge uncertainty, whatever we do after that, whatever planning aspects we do, it's not coming effective. Like when a flood happens, we really don't have the anticipation time or probably a flood warning system which could equip for these kind of impacts. So that's one thing, and yeah, we should in fact come up with more adaptive strategies when you are in fact coming with any planning mechanisms. That's truly one of the key challenges we are facing right now. So I think that's a very good point which you have raised right now. So now, thank you for that insightful thought. Coming to Mr. Sanjeev, I just want you to have like some of your experiences of how a scientific research in hydrology and environmental engineering could be integrated into developing water resource policies, and what are the current gaps you find it in this particular domains.
For example, now we are collecting the data, madam. We have a lot of data, like we are having rainfall data, real-time delimited rainfall data. But some of times what we are having the IMD forecast data for the large basin wise we are having the data. But if you want to issue for some small area, if you want to issue some warning for Chennai city, so we don't have the high resolution data for the certain area only. We have the larger data, large resolution data only we are having. We don't have fine data. So due to this, we are not getting the accurate forecast, and we are not able to issue actual forecasting or warning system. So this is one issues we are having. So we are trying to get high resolution data for particular our study area, madam, where we are focusing. So that area we need high resolution data so that we can improve our forecasting system and we can issue the warnings. And also when in other projects, like we are collecting some coastal information data, some coastal data we are collecting, but when the river is connecting to the sea, so there we are having some challenges, like we have some methodology to collect the river data, like we are collecting the river velocity and discharge through the river. And the same when it's connecting to the sea, so we are having lot of issues and challenges. And due to this, the flow of the river into the ocean, so we are getting lot of erosion and deposition. So for this area, we are facing lot of issues to how to assess this impact due to this flow, because the flow also it's changing based on frequently it's changing the course also, this river. So due to this, what is the impact and how we can study this and how we can implement these policies. So that is one area, madam, we want to focus on.
Yes, that's also somewhat connected with the larger problem. So we have a lot of regional scale data, but no one is actually interested in bringing it to a local scale data set, which could be at much finer spatial as well as temporal resolution, because that's very much important when you're coming to a planning aspect, because without a lot of people all over the world are actually looking into the larger picture, but not that bringing down towards that local scale, when we at a city level scale is still a area of probably a research gap, I can tell you. That models are not performing as good as it is expected. So that's one thing.
Yes, one more challenges we are having, for example, if you want to prepare some floodplain map, in that even we need all the departments involvement, all the stockholders. For example, when we are preparing this floodplain map, so we need involvement of the all the revenue departments and water resource department and local authorities and stockholders. So this coordination should be very effective. It's very challenging part, madam, to coordinating all the departments, getting the input and preparing the holistic and the maps, madam. So
yeah, that's coordination with the departments. As I said, it is almost equivalent to the integration of the data thing itself, because if that is happening, probably the other parts would, at least the integration of data would have been much more easier. So that's also a major challenge we have. It also has an implication in the policy development also. So yeah, and also I really agree with the point which you made on impact assessment with respect to the changes in the hydrological variables. Let's say you looking into the stream flow also, people are going with the prediction models and everything, but how much impact it is kind of causing in the ecology. So that's where one has to more have a proper understanding about the ecological impacts these kind of climate change is kind of causing. So that's one area we should actually more focus on. I think the environmental aspect should be brought in that. That's the reason why we have to bring all this in a looped form, right? You need to have the broader understanding about all these ecology also. So I think that's a very good point we have raised. Coming to Dr. Murali, how effective are the current carbon capture and storage technologies in mitigating global warming, and what are the challenges and opportunities in scaling up these technologies from your experience?
Yes, so coming to this CCS, current carbon capturing storage technique. So actually our company is right now working on this, working towards this. Basically we are from Danish based company. So our motto is by 2030 we should be carbon neutral, at least in Denmark. So that is what our motto now. So coming to the question, so CCS, current carbon capturing technique. So we can see this as in that term called ECO, that is effectiveness, challenge and opportunity. So coming to effectiveness, so how we are capturing this CO2 from the large scale industries. Small scale, it's okay, yeah, we can do that. But for the large scale industries, it is very big challenge, particularly for the industries like cement industries, power plants, and some industries like sugar industries particularly. So capturing those pollutions and CO2 from the cement industries, it's very big challenge actually. Then coming to opportunities like how we can integrate with the different technologies to capture these things, and how can we store this, and how can we transport from one place to another place. So when you look into this zero liquid discharge large scale plants, so at the end if you see, it will be almost like I can say it is a mud actually, it is a mud. So how can we transport this large scale muds into some places on the earth? How can we store for long term? So there are several challenges actually, storing these kind of environmentally hazardous material in the ground. So it involves a lot of challenges, like to the earth and to the local people and to the ecological animals and other, there are such that there are many challenges. So how can we integrate the modern technologies to store and transport and, you know, to handle these things is a big challenge actually. So for the small scale industries, some techniques are there, some technologies are there, not in like countries like if you go to Sweden or Norway, they are handling in appropriate way in the small scale industries. But again, when it comes to large scale industries, it's a question mark. So where we are emitting more pollution to the atmosphere. So in if you ask a company like Danfoss, is like it's a very big challenge, but we are stepping towards zero or neutral, zero carbon by 2030. Very slowly we are taking our steps, and we are finding a better, partners and funding from both private sectors and government sectors globally. So it has its own challenge in terms of funding and in terms of storage and in terms of transport. So if we find a way for these three things, storing, transporting and capturing. So if we find some common technologies, or if we integrate these three things in a single platform, then we can achieve this carbon capture techniques, whatever we have. But it's like it involves huge money actually. So it depends on money. So I think we are working towards how to get the funding from the global organizations. So it has its own plus and minus actually.
Yeah, so this regulation of carbon emission is a big
also
problem, especially for the developing countries, because you have the population here in India is quite a bit, and you cannot simply impose some restrictions on the carbon emission because that's going to even affect our economy. So that's a bit tricky part. How do you balance out both? And yes, transport of hazardous emissions is another big challenge. So recently I had been going through one of the research articles that was on phytoplanktons, which in fact captures carbon dioxide in the atmosphere. So I was very much interested with what is actually happening. So that's the problem what I at least could figure out. Like many things we are not aware about, especially about the nature-based solutions. We are always going behind the advanced technology. So I think there should be a balance. I mean, at least we should try to also understand what are the nature-based solutions that are there right now. Probably that could be a solution for most of these economy-related as well as people like in India, like especially in India for developing country where money is a big constraint. I think that should also be a better option. We should actually think about. So yeah, that's a very insightful thought. Coming to again to Kasturi, I just want to know what are the latest technological advancements in offshore structure design and construction, and how can these technologies improve safety, efficiency and environmental sustainability, like in a broader aspect?
So like I said earlier, we are now moving towards very large structures. We are looking at 150 meter hub height for the turbine, 200 meter diameter rotor blades, and monopiles are like 10 meters in diameter, which means that the solutions that we had before, they need to evolve in order to become relevant again. So if you're looking at the connection between the turbine and the foundation that we are designing, they are currently bolted assemblies done in a certain way, but with the growing size or the evolution of these turbines, that means we need to re-look at the connection between the turbines and the foundation itself. So this means a change or an innovation for our existing problems within projects where we are growing into XXL size foundations. And that also means our installation methods need to improve, as well as decommissioning as well. So if we are looking at foundations these days, we are looking at different types of connections between the foundation itself, but also we are severely limited by the weight that installation vessels can handle. So if it's only 2,000 metric tons that it can lift, then we need to make our solution fit into that fabrication criteria. So there's a lot of research, or actually sensitivity studies towards how do we improve our old solutions to fit the new data that we have now. And then coming to design optimization, we are heavily leaning towards digitalization, which is improvement of our processes and operations towards a more digital platform. In terms of safety, we are now moving towards virtual and augmented reality to help train workers for operation and maintenance procedures. before they even step offshore. So that plays into safety. We also have LCI procedures where we link all data, all documents related to the project within the 3D model so that at any point in time, you know what it's supposed to take the load for, how much you can exceed it, what is the factor of safety involved, and what it should not be. So ensuring structural safety in terms of how you manage your data is also key. And then coming to efficiency, we are now moving towards digital twins, where you're able to simulate close to CFD, where you're able to simulate the behavior of a structure before it even happens, and making sure that it actually aligns with reality. And when you have 3D models, then that's also how you communicate with clients and all your involved stakeholders so that you mitigate the risks that can happen during a project. And then in terms of sustainability, we have energy management systems and ocean batteries where we are assessing, okay, how much energy are we producing? Are we consuming the energy that we are producing? If not, is it going to waste? That means we need to store the energy and make sure that we are not producing electrical energy that's just going to waste. And that involves also alternative materials and coatings and looking at solutions from other industries which may apply to us now.
Yes, I think that point of digitalization, I think that's the way forward for irrespective of what domain it is. I think that's a key point which we have to really look into because then storing the data for a better future is something we really want to look into. So I think that's a very good point you have mentioned. Thank you for that. So coming to Raju, I need to know what is your vision for the future of coastal protection in the context of climate change? How do you see the roles of ocean engineering, hydrology, and environmental engineering probably evolving in the future?
Yeah, for this specifically when you speak about the climate change, mostly sea level rise is one of the major things which will be happening. So when we are speaking about sea level rise, as of now, we don't see it many places. We are only speaking on the paper and all. But if you take some of the examples, we can actually see it. For suppose you take the Wellington Island, which is where Cochin Port is installed right now. It is actually a man-made island which was done in 1920 by dredging the sand for the port. This is almost like 8 square kilometers, and the elevation at those time was fixed to around 2.5 meters. That entire island was at 2.5 meters. Now there we have an establishment of an airstrip, a port, and Southern Naval Command headquarters is sitting on the same island. Now what is happening from 1920 to 2000, there should have been some sea level rise. Right now the problem that they are facing right now is any rain comes, the water doesn't go out, hydrology point of view. So what we are ending up is, whenever there is a rain, the strip, airstrip gets filled up and then you will not be able to do any of the naval aircraft landing over there. So if it continues further sea level rise, what happens is you will not be able to use this island where almost like 8 square kilometers fully having the infrastructure over this. Now the options which are left out right now is like you can't increase the level because entire infrastructure has to be modified, which you can't do it. So we are pushing ourselves to a side like Netherlands, where they are below the sea level, where they use for artificial pumping systems, collect the soak pits. So if you don't think of some things right now and take a proper decision as of now on these kind of projects, we will end up in the same scenario in the future. Like we may have to go for a harsher reality where you need to spend more amount on maintaining the whatever infrastructure you are developing right now. So climate change, though we are speaking, it is actually really can be seen some of the projects like these kind of projects.
I totally agree. We are not still learning from our mistakes because this is not the case with the Wellington Island, I suppose. This is a common problem for all the small islands, including Lakshadweep, Andaman, everything. We talk about a lot of development that should happen in future, but then we are not concerned about the climate change aspect as well, how much this small islands could withstand these sort of climate variability. So we should in fact incorporate this thing right from the time when you start the development. So that's a very important perspective that you have shared actually. That's a very concerning, most of the time what we do is we compare with some of the developed countries where they might have already taken a lot of precautions to avoid all sort of repercussions. But as in India at least, we are not much concerned about what is going to happen with respect to. We are only looking into the development aspect. So then we should have a balance between both. That's a very thoughtful discussion point that you have brought in. Thank you for that. So coming to Sanjeev, just one last question because we don't have much time ahead. So what are the biggest challenges in implementing water resources policies in the local, regional and national level? And how can these challenges be probably overcome in future at least?
Actually, these are the big challenges we are facing, madam, like locally as well as regional also. So for this we need more interaction with the stockholders and to build the capacity building and trainings and the involvement of public awarenesses and involvement of local community. And we should prepare some guidelines and SOPs to involving all the people, and we need to explain all the problems and the solutions, madam. For example, in water resource, we are facing so many issues regarding water allocations. So this and all we need to study scientifically what is the climatic changes and what is the actual scenario. So accordingly, we need to revise the guidelines and other guidelines, madam, so that we can study based on the changes due to the climatic changes. We need to revise and we can make the revised policies, madam. So that is one thing. So this is the one thing, major.
So there is a lack of integration between various stakeholders, publics, as well as even the policy makers, because there's a huge gap between all these things. So they independently take some decisions which probably might not be helpful for the actual public. So I think there should be an integration between the departments.
We need
it's
to
very
study,
much
yes,
important.
so we need to scientifically study all the data, whatever we are having, the historical data, and we need to do the research, and we need to revise the guidelines and policies, madam,
Yes.
so that we will avoid
I think
this
that's
conflict.
one thing we are actually lacking. We still keep on adopting to the policies and regulations which have been made at least 20 years before. So that's something we need to still work on. So yeah, thank you so much for all your insightful thoughts, and it was a really engaging session. So I think we could actually look into the whole problem of bridging the gap, just not within the academia. It's also like how can we incorporate the industry perspective as well as policy, government perspective or policy. How can we actually integrate all these as elements is one thing what we want to actually look into in future also. So as Raju had already told, there still exists a big gap between all these different disciplinary. So we really need to look into the problem in a integrated manner. So that's one thing. So apart from that, we also discussed about the integrated data management thing. Also, we should have a digitalization for all the problems. It's not just relevant to the sustainability point, as Kasturi has already mentioned. We should actually bring the concept of digitalization in almost all the domains so that we can actually preserve all the data and take it forward for the future. So that's a very key point which I felt. And yeah, we should develop a collaborative network. So when you have a problem, you should know whom to actually contact to, because that's a very important thing, because if people are independently working at different corners with their own comfort level, that's not going to work for the future. So then we should actually have a collaborative network, and we should also initiate more capacity building programs to probably make awareness as well as understand about the gaps that is still there in research. Also, we should also initiate a lot of outreach programs. That's what I felt from all of your perspectives. So we should come up with more outreach programs to probably educate the people around. Then we should also have when you actually start solving a problem, we should also have an understanding about the site-specific conditions, and we should know the problems in the particular area before you start solving the problem. And also, when you talk about climate change, it is not just about predictions. We should in fact look into the uncertainty perspective from an atmospheric science perspective, because that's also very important, because if your prediction models are not going to give you an accurate result, whatever planning mechanism that we go ahead is not going to work out. So that sort of an integration should be there. So that's where I think we should, as an atmospheric scientist, hydrologist, as well as a water resource people, has to work collaboratively rather than independently, because the water resources person would only be able to say, okay, see, your models are not going to work well, because the other person can only give you about the uncertainty estimates, but that uncertainty, how much it is going to affect the actual planning, is something of major concern. So that's where we can, so there we should also think about how can we bring down this regional scale models to probably local scale models, because that's also very much important when you go with the planning aspect. And coming with the regulations of the carbon emissions, I think that is also very important, because especially for developing countries, because we should also think about what are the other nature-based solutions when you are having this economic constraints. So then we can come up with more sustainable solution for that. And when you talk about sustainability, it is not just about the engineering aspect. We should actually look into the ecological aspect as well. So then again, we also discussed about the transport of hazardous emissions. I think that is also one key aspect where we have to think about, because we say we have to go with net zero emission rate, but then how do we actually achieve that? Because if you don't have the proper transport facilities, how do you actually bring about that is also another question. So these are some of the major points which we discussed. Pardon me if I missed something, very key point if I missed something. So I just give this an open for all the audience out here. So what do you feel about this? Like, do you have anything in addition to add on to what we had a discussion on right now?
Thank you for the wonderful discussion. So we all realize that there is a great need for data integration, and we also saw that we need much of networking between disciplinaries. So I just wanted to know, is there an already existing a central body or some organization which is trying to connect these disciplinaries? Is such a thing already exist, or if not, don't you think it's really necessary to start one to bring about more coordination?
I think, I'm also an early faculty, so I don't have much experience to add on to that, but then I can say there are some initiatives, obviously, from the government side to probably bring a collaborative network, which is not as effective as it is, because if that was effective, I would have known by now. So I think that has not been working out very properly. So I think some of you are some of all of us, like young professionals, can start building it up. So then maybe this question may not be asked by the next generation people. So that's what I can comment on that. Yeah.
In the starting, I was saying, because right now it is like if you look at different ministries, each one is having their own data sets. But suppose if you look at the Ministry of Health Sciences, there are two things. One is from the atmosphere, where all the atmosphere related things are there in one portal that is coming to IOD. And when it comes to ocean, it is called a digital ocean, which is available in the invoice. Same thing with CWC. If you look at all the water, river network, everything is there in the CWC. Now there is a policy which is being built up, like how to bring all the data into one unified portal. That has Adinshira has started. Because if you see, to move from the records to digital itself, it took almost like 8 to 10 years. To unify all this into one data set, maybe 5 or 6 years down the line, you may be able to see a single portal where you will be able to have all the data. For example, if you see Gajashakti portal, where you are seeing all the planning of India, whatever new project comes, it has to be first go to Gajashakti portal and yeah. So if you look at like similar thing has been happening for the planning also, like there is something called as Gajashakti portal which was inaugurated by our PM, where all the plannings of any project has to be part of that. Right now, that access of all these things were not given to the public, but these access are with the ministries, where they are looking like how to further improve it. Once the improvement is done, then it will be released to the public in the later stage. It is there. Maybe 4 to 5 years down the line, you will be able to really see that integrated portals.
Is it just because of the lack of some technological advancements or advancements also with respect to the portal handling? Because I find there is a huge delay when you access these portals. So I think there should be some sort of technological advancements that is not integrated with these models.
Not specifically in terms of technological advancements, because if you see, look at IMD, IMD is having almost like 50 regional centers where they have data from 1900s. So all those things has to be converted into a digital format, then brought into a digital field, and all this has to be done. So it requires some amount of time to be done. So every product when you're developing, there is some time for it to come out. So the first stage will be they'll build it and they'll release it to the internal ministries will be having the access to it. Once all the ministries approve it, like okay, everything is done, then it will be coming out to the public. So this has certain time to happen.
Okay, so
More than technology, it is like, for suppose if you took at NEWA, National Institute of Wind Energy, they have almost like 100 to 150 masts, which is again measuring the wind speeds. IMD also has certain set which they are measuring wind speeds. Now these two has to come into a unified model or unified portal, both are wind speeds only. So like that, there is something which is happening in the ministries right now. Maybe that's what I'm saying. Maybe 3-4 years down the line, you will be able to see both data sets in a single portal.
More regarding what Raj sir said, like we have in CWC, we have more than 60-70 years data, madam. So it's taking a lot of time to digitalize the data. We have all the hard copy data. So digitalizing data itself, it takes a lot of time now. Now recently, now we are collaborating with state government also. So we are having some MOU. So now we are sharing all our data, our meteorological and hydrological data. We are sharing with the state government. So they are preparing some common platform portal they are preparing. So it's all slowly it's improving. So we can see full-fledged portal within 1 or 2 years, madam, to effectively coordinating.
Good to hear that, because that's where most of us are struggling. So I think that's a very promising thing.
Excuse me, ma'am. Since we have water resource expert here, actually I just have a small question. From my point of view, we are totally depending on groundwater as a actually major resource for our water. So what is the challenges in converting actually seawater to fresh water, like desalination in large volumes? In my point of view, we are actually we are not that much here actually converting like large volumes of seawater into fresh water. So you just share your thoughts on it.
So your question is valid for countries like US, Europe and Middle East countries. But when you take India, you can find an RO in every kitchen. So obviously in India, we don't need any kind of RO in big plant, as a big plant. So it is there in other countries outside, but in India, I think as of now, it is not needed. It's my view.
But that RO, what we are using, that is for converting our groundwater into actually drinkable water. But what I am talking about desalination of large volumes. Actually, since we are totally depending on groundwater, from my point of view, actually we are waiting for actually depletion of groundwater, and then we will be moving into desalination. Like I am thinking that we are not into large volumes of desalinating.
I think we don't have any necessary to do that. I think so,
Yeah,
because of our kitchens as individual RO.
Okay.
See, any technology, when the need comes and whenever the price required for that happens, only will happen. For suppose you see, there are large desalination plants in Chennai. You can see there is 400 MLD plant which is coming, very large scale. We will not see in other places. Because Chennai is water scarce already, and the price which you are paying for money is really sufficient for the PPP mode, public-private sector mode, to give you through the desalination, they are able to do that. Similar kind of things happens in the islands, where you don't have any other source. When you pay more for it, then you can get it. But if you see desalination right now, what it is happening is because of large scale things that is happening, the price is coming down. And very soon you will be able to see it like it will come in very huge market, it will be coming. Similar kind of what happened in the solars. When you look at the solar, initially it used to be 10 rupees per unit. Right now, they are bidding for 2 rupees. That is because once the supply chain develops, and when the product, large of companies are coming into the system, when the competition comes, the price will come down, and slowly the amount you are paying for the electricity is also increasing. When these two meet, that particular technology will become large-scale viable in any place. This is what my opinion is on that.
And I think it's also about the tropical country, India, where we have enough and more rainwater. So I think we are more interested in rainwater harvesting than desalination.
Excuse me. Yeah. I got a lot many questions because the discussion was so good that I feel that I can ask so many questions. The first question is, my concern is the vulnerability of our structures, the hydraulic structures. The Chungthang lake, that is in the Sikkim, it breached because of the cloud burst. And we got a big number of like hydroelectric power structures over there in Uttarakhand and all. And then all the roads, all lifeline supporting structures are vulnerable because of the landslides and all. And nevertheless, the Wayanad floods are there. It was raining earlier also. But these rains nowadays are really very different. The entire things are flowing. Now I am concerned about the sustainability of the structures. The ocean levels are moving up. Whatever the fixed structures you are talking about and all, again becomes vulnerable. Now, what we should consider about some studies, some theses are coming to me where the bridges have been considered because of the high floods and all, their vulnerability. Okay. The seismic things we are studying. Now time has come, the water is creating havoc, whether it is ocean, river, whatever it may be. Now, last question is that we don't have enough data. Like in the Bay of Bengals, we want to put up some structures. We don't have a data for many years, like significant wave height, wave periods, and all those things. So there are problems, and there is again a question to Kasturi that, whatever you are doing for your offshore wind turbines and all the fixed structures and all, if there is a floating offshore structure, floating offshore wind structures, so is there a possibilities to place them in Indian oceans, and in that case, whether enough data are available to justify the design of these structures. Okay.
So to answer the first part of your commentary regarding the concern for how do we prepare for such events where we don't have past data or not much data to prepare for, one is the project design basis. It must take into account some kind of predictive or adaptive modeling based on recent data. And understanding of the probability and what it actually means. There is also a criticality in the selection of the return period that you design for, which is based on certain probabilities. A complete understanding of that before you select the basis of your project is fundamental. And your question was about floating offshore wind, if there's any scope for India right now, and regarding data acquisition for that. So we have a lot of oil and gas projects. Our country has very large history with that industry, which is now becoming a heavy inspiration for whether we can transition into offshore wind or not. That conversation is purely an economical one, like we spoke about in the previous question, where the capex has to make sense and enough investors need to be driven into the market due to the demand, which is in turn driven by scarcity. So that's setting the whether we will move into. Of course, I think there's a lot of focus on the coast of Gujarat and India. I've been involved in some pre-feasibility studies where we've been looking into, do we have enough information from oil and gas or marine projects or port and harbor projects? Are we able to draw any kind of patterns and whether we can actually get the data we need? So there are initial steps that are being taken, also sponsored by the World Bank, but we are a little bit further back compared to our European or American people. So there are efforts, but it will take time, and it is driven by the economical needs.
And I would like to add on to that first part of your questions that that is regarding vulnerability. So if you look the case of Wayanad, which is a very recent incident that happened, which is very unfortunate though, there were reports which showed that Wayanad is one of the most vulnerable region to landslide, especially the Kasturi Rangan report, which showed that it is the hotspot region of landslide, and it showed that there should not be any sort of construction that should happen in future. But still the regulations could be because of the political reasons, which didn't, people didn't take it into consideration as such. You learn from, once it happens to you, you really learn the lesson. So that's what is happening. So it's not just about the lack of studies or vulnerability aspect. It's also about something related with the political aspect, as well as some point you are not aware about, at least the public are not aware about. They think that's not going to happen to us, at least. But let's say the case of Wayanad, there were 2 landslides, that too in the same location, at least in last year. Yeah. So even after that, people were not ready to move in, because they were not expecting that this is going to happen to me. So it's also about, you have to have a proper understanding, like public awareness as well as the political reasons has to be minimized, and sometimes you have information about the vulnerability. So that's just an add-on to what she was trying to.
Thank you, all of you. That was a very eye-opening session. So I have one question, it's kind of a question, trying to understand. Parvati ma'am said that we are all working at our best capacity, but we are not we are trying to improve, we are trying to address our mistakes from the past to gap the future, the present and the future. So in this, now we know that we have already accelerated as a community a lot. We are working on big datas, we are working on crunching the datas. Through that, we are bridging the gaps that are already existing. But are we really doing it in the correct way? We have a lot of models which are mimicking the human brains. They are actually working on the datas to bridge the gap. But are the datas are the complex, because all the environmental phenomena are really non-linear and complex. So access to the data is partial. We have low fidelity data. So can we use that to question the existing gaps, and can we use that, if we can solve that, then that can help us, that model can work with us and accelerate our work, working capacity, and addressing the energy concern or the carbon footprint concern. We are planning each and every year, the final date is getting shifted. So first I used to hear that by 2030 we are planning to shift by 40%. Now the percentage has come down, by 2030 we're at least planning by 30%, and the 40% has shifted to 2050. So are we really working in an efficient way, or is that gap still is growing?
Fortunately, the gap is actually reducing from my perspective, but we have a long way forward. So what I find, especially with the emerging deep learning as well as machine learning techniques, it do have a lot of predictive capacity, even though we don't know about what is the physics involved in that, because it mimics the human brains. Yeah, you are getting good results out of that, but how did that come up? So that's a very kind of point of discussion, but still, if you can, that's where exactly we want to bridge the gap between different disciplines. So when a person who is working in deep learning is actually working on a predicting model, he is not aware about what is the physics that is there within the hydrological perspective. So if you can incorporate that element to your deep learning models, let's say you try to incorporate your basic understanding about your Earth system, probably the prediction model would be able to predict it at much better scale. So I think that's the reason why I said that gap is reducing. People started to realize that you should not work independently and come up with solution. Rather, you work collaboratively, get to know what are the advantages of what others are actually working on, and learn from your mistakes about what you have been already doing for quite long. And that's one thing I'm very happy to see. So a lot of young minds are there. So that's where some sort of changes do happens, right? So if you are still working on the traditional aspect, I think it's not going to work out. So it's high time we should appreciate some of these recent developments and we try to incorporate into our understanding which we had made through long years of research. So that's where you are trying to minimize the gap. So that was my perspective to that particular question you asked.
Thank you, ma'am.
Hi. First of all, I would really appreciate this. This is really the need of the hour, to collaborate between the various sectors and to know the point of contacts. Like she said, like Ms. Parvati highlighted, you need to know the point of contacts in the various industry to be able to easily reach out rather than, going somewhere else. So to begin with, I'd really emphasize the fact that Kasturi was highlighting. If you see in architects, in their own curriculum, they have this practice of the final year being a strict practice where you get to do internships. So that build a great, strong foundation. If you go back nearly 40 years ago, I think that was the practice as well. Engineering was practiced for 5 years and not 4. So I think we should also bring that practice. Now, going back, my first question would be to Murli. So you were mentioning that, the emphasis is only on the small scale industries are only making use of carbon capture, CCUS, whereas I've also been involved in some feasibilities and concept studies where, Europe, they already map several technologies, several emitters, several industries together. Let's say, for instance, there is sugar factory, cement factory, and biomethanol plant. They try to, make use of the emissions, and wherein my role comes in, which is I'm a pipeline engineer. I try to build the pipelines, which is used to transport them. So this is already there, and I think it's a massive idea. There is something called the European Hydrogen Backbone. I think you're aware. So I think Kasturi was mentioning that this depends on the supply and demand when it will be happening in India. So on that front, how long do you think it will take for it to be implemented in India? Something similar to the EHP.
Yeah. In India, I think it should take another 2050. I think so. Because if you see, being practical, if we compare with European countries with India, so we are, I think, minimum 30 years behind with those. So keeping in that mind, I would say it is 2050. Because now, European countries has a vision that at 2030, at least we should be carbon neutral. So when it comes to India, it should be at least 20 years.
Okay. Yeah, I think, so there was one more thing I wanted to talk about. Like, I think you spoke about phytoplanktons a bit. Could you elaborate a bit on that?
Yeah, so that was just, I'm not a person who from a biological aspect, so I really don't know about what is the process that is being done, but I understood that these phytoplanktons, those are some bacteria, not bacteria, I should be wrong sometimes, sorry about that. So these are organisms that grow within the oceanic surfaces. So what happens is that it has a inbuilt capability to absorb the carbon dioxide in the atmosphere and it pushes back into the oceanic surface, deep oceanic surface. So what happens is it is kind of a mechanism by which you can actually reduce the carbon emissions in the atmosphere. So this was a very recent article which I just randomly looked into. So I felt that's something which we can actually implement, like nature-based solution. When you talk about, these are something which we can also think about. So I'm also in the process of learning more about it. So maybe 1 year later I can comment more on that. So this was just a random thing I just came in. So I got, okay, this is something eye-opening for me as well.
Yeah,
so,
pretty
relevant.
Yeah.
And you do have a lot of satellite information which captures how much amount of phytoplanktons, that's basically the organisms that float on the oceanic surfaces. So you do have the quantitative estimates of about how much is the phytoplankton concentration is there in the oceanic surfaces. But with the climate changes, these are also getting pretty much affected. So there also we have to be much more cautious. We also have to sustain these organisms because that's very much vital to balance out our ecosystem. So if we can kind of grow it up, so I think that's where my point was in. So,
okay, thank you. Just one last question. So now that you're all here, any next set of plans, like how to integrate the various industries?
I think that's a question for the president.
Okay, that's a great initiative.
Yeah, thank you so much. I think we are short of time, so we have already exceeded the time also, I think. So let's wind it up. Thank you so much for this engaging and very interactive session. And I would also like to thank all the audience who paid a lot of attention to all the discussions we had, because I could see there are a lot of very informative questions that have even come up from the audience side also. So I'm really happy to have you all here at IIT Madras. Hope to see you all soon, maybe through some of the collaborative networks they are planning to build up. So thank you so much for joining, and I would also like to thank all the organizers who have taken up this initiative of formulating this young professional network, which is a need of the hour, because that's very much important, because as a people who are from industry, academia, or even from the government side who are young professionals, they always do have a lot of challenges about how do we actually collaborate. So these kind of ventures would be a step forward to probably grab some of the opportunities ahead of time. So yeah, thank you so much for your coordination, and thank you all for joining us. Thank you.
Thank you, and a huge round of applause to all our panelists for readily agreeing to be on our panel and also giving us such an informative session. So it's time to honor our panelists. I invite Mr. Sridhar Krishnamurthy, President of IIHR SIYPN, to present a memento to Dr. Murali Gunasekar as a token of gratitude. I call upon Mr. Hariram N., Vice President, to present a memento to Mr. Satyakiran Raju Alluri. I request Mr. Rishikesh Dimple Kamble, Secretary, to present a memento to Ms. Kasturi Nallarasu. And I invite Mr. Vasanta Kumar S., Treasurer, to present a memento to Mr. Sanjeev Kumar. I finally request Mr. Sridhar Krishnamurthy, President, to present a memento to our Chair, Dr. Sri Parvati Vijay. Thank you, ma'am, for bringing this session up and guiding us through this program. I invite Mr. Hariram N., Vice President of IIHR SIYPN, to present the vote of thanks.
Good afternoon, everyone. On behalf of IIHR Southern India Young Professional Network, I would like to extend our heartfelt gratitude to everyone who made today's event a great success. So first and foremost, I would like to thank IIHR for readily accepting and providing support for the panel discussion. I thank Dr. Sri Parvati Vijay, Session Chair, for leading the panel discussion and her support in organizing the event. A special thank goes to the panelists, Dr. Murali Gunasekar, Mr. Satyakiran Raju Alluri, Ms. Kasturi Nallayarasu, and Mr. Sanjeev Kumar, who gracefully accepted our invitation and supported their experience and insights with everyone who joined us in person, as well as the delegates who are viewing the live stream. We look forward for more fruitful collaborations in the future. I also take this opportunity to thank Professor Panniselvam and the organizing committee of ICSOS, International Conference of Ships and Offshore Structures 2024, for accepting and supporting this panel section. I extend my heartful gratitude to Professor S. Nallayarasu, Head, Department of Ocean Engineering, and the Conference Chair, ICSOS 2024, for his constant support. I express my sincere thanks to Professor S. A. Sanasiraj, Advisor IIHR Southern India Young Professional Network, for his guidance and encouragement in all our endeavors. And of course, the event was a success thanks to the audience for being such an enthusiastic and engaged group. Our participants and the questions brought energy to this event and helped foster rich discussions. I also thank the media team of IIT Madras for smoothly taking the session to our delegates on the live stream. Last but not the least, I thank the active scholars who volunteered and worked behind the scenes to ensure the event's success. So apart from these sessions, there are many upcoming events in the pipeline that is organized by the IIHR Global Community, IIHR SI YPN community, and other IIHR communities, the details of which are always available in our social media platforms such as LinkedIn and our websites. So feel free to contact us with any queries regarding the events. Once again, a huge thanks to everyone who made this event a success. We look forward to joining all of you in our future events also. Thank you.
That brings us to the end of this session. I request all the participants, attendees, to join for a photo session with our panelist in front of the dais for a photo opportunity, please. And then we'll break for tea and we'll come back for the valedictory session of the conference. Thank you. All the attendees, please join us near the stage. Good evening, everyone. On behalf of ICSOS 2024 and IIT Madras, it's my pleasure to welcome you all to the valedictory function of this prestigious international conference. Over the past 3 days, we have witnessed insightful presentations, thought-provoking discussions, and valuable networking, making this event a grand success. I now request Conference Secretary Professor R. Paneerselvam to lead the dignitaries onto the stage. We have our chief guest, Professor S.K. Bhattacharya, and Conference Chair and Head of the Department, Professor S. Nalayaras. Can we give them a huge round of applause as they take up the dais? As we begin this valedictory function, I invite Head of the Department, Department of Ocean Engineering, IIT Madras, and Conference Chair, Professor S. Nalayaras, to brief the gathering.
Okay, good evening to all of you. So we have come to the final day of the conference. To honor this and to conclude the session, we have invited Professor Bhattacharya, former head of Ocean Engineering Department and professor for several decades since its opening of the center and then as a department. And both of us, myself and Paneerselvam, were students of Professor Bhattacharya. And he's here for us to brief about what we have done for the last three days and also to distribute the certificates. So various participants from different states, different locations, different universities have gathered for the last three days. And I have been on and off coming and attending some of the sessions, especially the last one, the session organized by our IAHR group on sustainability of ocean engineering and gaps between the hydrology and water resources was very good. In fact, the discussion was so lively that several aspects which sometimes we don't even think was discussed. It's good to hear such kind of young people discussing about those kind of ideas, and some of them may not have answers, but it starts putting in your mind that you have to start thinking about it. So that was, in fact, attending conferences of this kind is for that purpose. Of course, more than counting number of papers published by you, attending a conference in live session will give you many thinking ideas afterwards. And that's why we, IITs, we encourage research scholars to attend conferences overseas or in India, where when you listen to those presenters, few things will come to your mind. How I am presenting and how he is presenting, how I am expressing the work I have done, and also what new things I can do in my work and improve. Especially when you are looking at numerical modeling or experimental studies, you may be struggling with getting some results in a way that you were doing. But if you go and listen to such kind of presentation by others, then that means this idea can be implemented in my work, and straight away can actually adapt and get a better, kind of research outcome. That's why attending conferences is one part of the research career to become a full researcher. And finally, if you end up as a teacher, it will be very helpful, because then you can stand in front of a large gathering and speak about what you have done. And that's where I find this conference, though it's not a very big mega conference, conventionally, I think it was only a small group of researchers in ships and offshore structures gather every year. Being an annual conference, not too many is coming out, but then, Professor Pike and Professor Elgas from the initial time, they have been doing this work, and we should thank both of them for allowing this conference to be held in IIT Madras, and especially Professor Paneerselvam has taken a lot of effort to talking to them, because he has been attending this conference several years before, wherever it was held. So he brought this conference to this IIT Madras and Department of Ocean Engineering. I would like to thank him that such exposure to our research scholars in the country. Of course, we have a few overseas scholars attending this conference, but then primarily it is our scholars from the country. Unfortunately, we could not get visa clearances for the foreign participants, especially Chinese and few others. Otherwise, we would have been having a few more delegates coming from overseas. So I hope all 3 days you would have enjoyed this conference, including our beautiful campus and the guest house, food, is the lunch and the dinner. And of course, I think Professor Pannisalvam is also organizing some more lunch tomorrow. So that's what I heard. So hopefully you will enjoy. And probably next time in the same conference next year in Canada, right? Sweden, So hopefully we can meet, and I will try to come. And thank you all. I hope you have enjoyed. Thank you very much.
Thank you, sir. It's my great privilege to introduce our chief guest for the valedictory function, Professor S.K. Bhattacharya. Professor S.K. Bhattacharya is currently the professor and head of the Department of Naval Architecture and Offshore Engineering at Ahmed University, Chennai, but he is also a retired professor and former head in the Department of Ocean Engineering, IIT Madras. His expertise spans over a vast regime like dynamics of floating bodies, computer-aided analysis of ship and offshore structures, to name a few. He has also served as eminent personnel in various technical panels, including the Naval Research Board, NRB, and DRDO. He is also a member of American Society of Mechanical Engineers, INA, and other professional bodies. Thank you, sir, for gracing the occasion. I request you to address the gathering.
Thank you, Iya. Most people here are young, so I'm basically addressing to them. This is my first experience. I came only today. I attended this conference today, full day almost. This hybrid conference I've never attended before. So in fact, I don't know, we have conducted earlier a hybrid conference here? Yeah. So it's really wonderful. I mean, you can speak from anywhere, and then interaction is much more than I expected. So that is something which attracted my attention. As Professor Nallarasu was saying, that attending conference is a best way to improve your communication and getting ideas, new ideas for research. The papers, I had a look of the papers. I think quality of papers are pretty good. I hope Professor Pannisalvam organizes some special issue in some journal of selected papers. So the standard seemed to be very good. And presentations, whatever few I attended, had been very good. And you would have seen not every one of them is a great innovative idea or something. Many of the ideas are practical, like LNG, how to contain. It's a simple thing, but it has got a lot of potential in application. So both the things, the research has these two sides. One is something which is applicable, which ready application, and which is, of course, a little bit futuristic. So this conference addresses both these types of research. The students, the professional interaction in the last 1.5 hours, that was very impressive. Trying to connect loosely the idea of oceanography, water resources, offshore engineering, all of, what do you call, river systems, atmospheric sciences, and for various, all of this are connected in some sense or the other. As you can see, that particular session went very well. all these people, young people, were very articulate, and I thank them for that, including whoever conducted it. And here today you will find many examples of, everybody talks about global warming and climate change, and these have serious effect on engineering design. Ships and all that are being designed for much stronger waves. Offshore structures are being designed for, these days 1,000-year waves and all that, not previously 100-year. And of course, background of this is, which we knew long time back, the extreme value statistics of natural processes, which tells you, what is the wave height, for example, for a 10-year or 100-year or 1,000-year wave. So those kind of things are being cross-related. So climate change effect on marine structures, or now, as I understand, the rivers or floods and atmospheric events, and Dr. Banik was talking about mountain slides, instability of, those, cloud burst, right? So those are becoming more severe, and obviously it has to be codified. Research has to be done, it has to be codified, and so that engineers can apply it day-to-day life. So this extreme value statistics, these are the kind of things we teach at IIT Madras sometimes. I don't know how many courses exactly, I cannot remember. But we have learned, all of us have learned those kind of things. So all in all, the conference seems to have gone very well organized. Of course, only thing is, I would say that we have been organizing conferences, and all of them have been well organized, in my opinion. We have, everything here, at least things conducted by Ocean Engineering Department goes like clockwork, and, never any departure. So with that, I think some of you are eligible for getting a certificate. So I'll ask Dr. Paneerselvam to distribute the certificates, right? Yes. You can do it now. Thank you.
So she will read the...
Yeah, I'll read.
No, you have to give.
You can give
Yeah. Okay.
I will read it over the.
Oh, okay.
Okay. So the recipients have to walk the area. Start from there. Okay.
A small appreciation brings bright smile on our faces. So we'd like to give certificates to the delegates who presented papers acknowledging their efforts. Dr. R. Prithiv Kumar. Atul Krishna Banik. Ram Kumar. Suja TP. Pradeepa M. Basanagoda I. Patil. Ashish Unnikrishnan. Ajay Kumar Das. R. Ashwin Kamalakannan. Dipali Goyal. Surush Afzali. Vedant Wagh. Kenshiro Takahashi. Prashant Kumar. Ashwani Vishwanath. Keshav Pathak. S. Vishnuvardhan. Kailash Chand Swami. Prabhat Kumar Maurya. Swarnadeep De. Saumen De. A.V. Mahalingaya. Subhendu Paul. Vignesh R. If any of the co-authors are there, you can collect it. Bharatraj A. Sir, you can get it on behalf of Bharatraj A. Gopinath S. Rajan. Manmada Krishnan Palraj. Congratulations to all the participants. We'll now present a memento to our chief guest. I request Professor S. Nalayarasu to present a memento. I request Conference Secretary Professor R. Paneer Selvam to brief us about the report of the conference and present the vote of thanks.
Good evening, all. So we have come to the end of the 3 days session. I hope you enjoyed ICSOS 2024 events at IIT Madras. In this 2024 ICSOS, there were 9 technical sessions. We had 40 papers were presented in the conference. 41 was scheduled, but 1 paper was cancelled at the last minute. There was no registration. Offline papers physically present numbers were 33. Online papers were 7. And there were 4 keynote lectures delivered. Professor Soren Ehlers, Professor J.K. Pike, Professor V. Chen Koo, and Professor Jonas Ringsberg. There were 3 invited lectures, Professor Ananda Subramaniam, Dr. Y.V. Sadish Kumar, and Dr. Mujib. So this is the summary of the ICSOS 2024. So I now stand before you to propose the vote of thanks. And ladies and gentlemen, as we draw this remarkable conference to a close, I have the privilege of extending our heartfelt gratitude to those who have made this event possible. First and foremost, I would like to express our deepest appreciation to our esteemed patron of the conference, our director. His unwavering support and guidance have been instrumental in making this event a grand success. Thank you, sir. We would like to extend our gratitude to the head of the department, Professor Nalayarasu. His guidance and support throughout the past 6 months in organizing this conference. We appreciate your commitment and leadership. Our sincere thanks to all the faculty members in the department. Your involvement, expertise have greatly contributed to the success of this event. Thank you for your continual support and hard work. We are immensely grateful to our sponsors. We thank for their support during this event. A special mention to our student volunteers, especially the last 3 weeks or so. Your enthusiasm, dedication, and tireless effort have not gone unnoticed. Thank you for your invaluable assistance. and for being the backbone of this event. We would also like to extend our gratitude to the conference secretariat. Your assistance throughout the planning and execution phases has been outstanding. Thank you for your commitment and professionalism. To the staff involved in making this event hybrid, a heartfelt thank you. Your technical expertise and adaptability have ensured that we could reach a wider audience. Lastly, I would like to acknowledge to all those who extended their best wishes and support. Your encouragement and good thoughts have been a source of strength to us. In closing, thank you once again to everyone who has contributed to the success of this conference. Your support has been invaluable, and we look forward to continuing our journey together. Have a wonderful evening and safe travels. Thank you very much.
As we conclude this valedictory function, let us carry forward the knowledge, ideas, and inspiration we gained over these days. Until we meet again, stay curious, stay connected, and keep pushing the boundaries of research to make a meaningful impact. Thank you, and wishing you all the best in your continued journey of discovery. Thank you, and we'll now formally end this conference with our national anthem. I request you all to rise for the national anthem. जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलति तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे. Thank you.